We are now on the analytical geometry section of this paper, and we start off with question 3, which says, in the diagram, A, which is 4 and 2, B, which is 6 and -4, and C, which is -2 and -3, are vertices of triangle ABC, as we can see over there. And T is the midpoint of this line CB. Okay, so this is equal to that. And then they tell us that the equation of AC is 5x minus 6y is equal to 8. Okay, so it's just not in its standard form, but we have the equation of AC over there. We should probably put that down. Okay, so AC is this, 5x minus 6y is equal to 8. Okay, then they tell us that the angle of inclination of AB is alpha. As we can see, the angle of inclination, the angle it creates with the x-axis. And then triangle DCT over here is drawn such that CD is parallel to BA. Okay, those two lines are parallel, so we will see the kind of fun angles we can find on them. And then the lines AC and DT intersect at S. Okay, just an intersection. The y-intercept of AC, okay, that is also a y-intercept. PF and R are x-intercepts of D, AC and AB respectively. They're just naming all the x-intercepts. This is analytical geometry, so it will be useful. Okay, so the first question is calculate the gradient of AB. Okay, let's look at that. AB is a line with both points, okay, and the coordinates are there. So we can just use the gradient formula to find the gradient of AB. So the gradient is equal to y2 minus y1 over x2 minus x1. Formulas are in the formula sheet. So gradient of AB is equal to, just be consistent. So I'm going to go top minus bottom. So y2 minus y1, that's 2 minus -4, which gives you 2 plus 4, okay, because minus and minus give you plus. And then over, we have top minus bottom again, 4 minus 6, okay, so 4 minus 6, and let's just put that down, 4 minus 6. So that's going to give us, you know that on top you're going to get a 6, and then the bottom you're going to get a -2. 6 over -2 gives you -3. So there we go. Gradient of AB is -3. Moving on to the next question. And 3.1.2, of course, they're asking us for the size of alpha. Okay, remember that we have the gradient now of this line AB. This is the angle of inclination of AB. So use the angle of inclination's formula, which is that tan of your angle, we'll just call it alpha straight away, is equal to the gradient. So the line we're referring to is AB. So tan of alpha is equal to the gradient of AB, which is -3. And so we can find alpha like this. Alpha is equal to, and you're going to take tan over so that you can let alpha be on its own, and it becomes the second function of tan, okay, which looks like this. But of course, on your calculator, when you calculate this, you will see that you're going to get a negative angle, and it's fine. Shift tan -3 gives you -71.56. And you don't want that because, as you can see, alpha is a positive angle, okay? So it's just been measured the other way around. Okay, so that's that. So to get that angle, you can just add 180 degrees, because remember that angles are measured anti-clockwise. Okay, so that's the way to measure angles. So this is negative, so it was measured clockwise. So that's why it's -71 point something. So to make it positive, remember that this is all on a straight line. So just add 180 degrees to it. Okay, so it will get to this point and 0 at this point, and once it gets to here, it's positive, and that's how you end up with a positive angle. So we just add 180 degrees to that. Okay, so here plus 180 degrees, and we'll get our answer. So just add 180 and it should be fine. And that gives us 108. So alpha is equal to 108.43 degrees, and that's our answer. Okay, moving on to the next question. The next we have to find the coordinates of T. Okay, so where is T? Okay, T is the midpoint of this line. So we're just going to use the midpoint formula to find that midpoint. That's all. Okay, so our points are C and B. Let's write them down and use the midpoint formula. Okay, so that is what we have. And t, to find t as the midpoint, it is x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, just a half of all those. Then let's go ahead and substitute this. This is going to be negative 2 plus 6 over 2, and negative 3 plus negative 4, which just gives you a minus 4, okay, because positive times negative is negative, over 2. Okay, and just simplify, that's all. So t is equal to 6 minus 2 is 4, 4 divided by 2 is 2, and then negative 3 minus 4 is negative 7 over 2. So there we go. That is our answer, 2 and negative 7 over 2. Moving on to the next question. The next thing we have to find is the coordinates of S. Okay, so let's just see, where is S? What line does it belong to? S. Okay, so that's why it's always important to write down things that you have. You see that on the line AC lies this point S, and S is the y-intercept. Okay, so if you put this in standard form, you'd be able to see that y-intercept. So that's exactly what we're going to do. Let's write down that equation and put it in standard form. Okay, so to get it in its standard form, we need y to be left alone. So let's leave negative 6y first. We'll take that 5x over and it becomes negative 5x, and this is still positive 8. Then get rid of the negative 6 by dividing both hand sides by negative 6. Therefore, y is equal to 5 over 6x, and then these divide. Now, they can actually simplify. Sure, it's going to be negative, but the common factor, highest common factor between 8 and 6 is 2. So if you divide both by 2, you're going to be left with negative 4 over 3. And there we go. So that means your y-intercept, because it's in the form of y is equal to mx plus c, and c is your y-intercept is negative 4 over 3. So that is S. So the coordinates of S is, the x value is going to be 0, and the y value is negative 4 over 3. And there we go. Just remember, you could also have done this by simply, because it is the y-intercept of this line, you could have also substituted in place of x, you could have substituted 0, because to find the y-intercept, you make x equal to 0. And you would have also found it like this as well. That would have become 0. This would be negative 6y is equal to 8. Divide both sides by negative 6. Again, y would be equal to negative 4 over 3. Okay, so 2 ways of still dealing with that question. Okay, moving on to the next question. Next question, 3.2 says, determine the equation of CD in the form of y is equal to mx plus c. Where is CD? So CD is over here, right? What do we know about CD? Well, we know that CD is parallel to AB. So these two are parallel. And so we can actually find its equation, because if they are parallel lines have the same gradient, okay, because they're slanted in the exact same way. They have the same slope. So the gradient of AB is the gradient of CD. And you see that we have a point on CD. We have C. So we can use that. Okay, so let's just start with saying the gradient of CD is whatever the gradient of AB is, which is negative 3. We found that in the first question. So the gradient of CD is also equal to negative 3. And we saw we had that point negative 2 and negative 3 as C. So we can find the equation. So I'll just use this way. Y is equal to mx plus c. And then in place of m, we'll say y is equal to negative 3x plus c. Substitute your x and your y value, okay, into those coordinates. So that's negative 3 is equal to negative 3 times negative 2 plus c. Those give you positive 6 plus c. And this is negative 3. Take the negative 6 over, so negative 3 minus 6 is equal to c. Therefore, c is equal to negative 9. And so the equation of this line is y is equal to negative 3x minus 9. Okay, moving on to the next question. We are now on question 3.3, which says calculate the size of angle DCA. Okay, so angle DCA, let's just find out where that is exactly. Angle DCA is over here. So this is what they want us to find, the size of this angle over here. Okay, so let's look at the diagram and see how can we find it. Well, there are numerous ways to find it. If you look at it like this, okay, I know they gave us parallel lines and we did use that. Maybe it's going to be helpful. But we could do that whole thing of constructing a an x-axis, right? An imaginary x-axis, and then trying to relate the angles that we have with these lines. Okay, so like finding the angle of inclination there, so that will be part of DCA, and then finding that little part underneath here. But that seems complicated. It actually depends on the mark allocation. It's 4 marks, which is probably a 2-step process. So no, let's actually not go with that. Let's see another way that we can actually find this. Okay, so look at this. Since these lines are parallel, right, it means that we have alternate angles here, right? So this angle is equal to this angle. So whenever we think about DCA, we can just focus on this angle, angle A over here, okay, because that is alternate angles and they're equal. So let's find this angle. Now I'm seeing a whole lot of things that we can use in this region, because you see that we have alpha, and alpha is actually an exterior angle of this triangle, okay? Alpha is the exterior angle. And we know that the exterior angle, okay, alpha, is always going to be equal to the sum of the two opposite interior angles. So if this is what they want us to find, we already have this angle, then we just need this one, which does not seem difficult, because you see that this line AC is over here, and that angle is just the angle of inclination of that line. So let's go ahead and find the angle of inclination of line AC, and then we'll be able to use that exterior angle rule to find this angle, angle A, which is of course DCA. Okay, so first to be able to use AC, we need its gradient. Do you see that we already have the equation of AC, and we already found the gradient as well. So the gradient of AC, when we're working on it, it's over here. Do you see that the gradient is here? Okay, so actually dealing with this like that would have been very helpful. So that's 5 over 6. So we can tell them that the gradient of AC is equal to 5 over 6. And then let's use that. So remember, we're trying to find the angle of inclination of line AC. So what is that angle going to be? So we're going to use the tan of theta is equal to our gradient. So tan of theta equals 5 over 6. And then theta is equal to, we'll take tan over. So it becomes the second function of tan, and 5 over 6. Okay, so let's see what that gives us on our calculator. If you say shift tan 5 over 6, we get theta being 39 point. Now just round off to 2 decimal places here. And the reason I'm going to do so is because we're just working with whole numbers throughout. Okay, we already have this one rounded off. We have the final answer of that. Okay, and so we can use that rounded off. It's not going to affect your final answer. Okay, so we know what that is now. Okay, 39.81. So we can just fill it in there. This is 39.81 degrees. And if that is what this is over here, remember the exterior angle of a triangle is equal to, so alpha, whatever that is equal to this plus that. Okay, so we can actually just write it down first. Well, we know what alpha is. Alpha, we already found that, so we can just put that down in place of that. It is 108.43 degrees. So this means the exterior angle alpha, 108.43 degrees, is equal to the sum of the two opposite interior angles. So it's equal to 39.81 plus, of course, angle A. And so to solve for angle A, you're just going to take that over. So the equation is really just angle A is equal to 108.43 degrees minus 39.81. Okay, so let's go ahead and find that, which is equal to 68.62 degrees. Okay, and then again, remember that that is exactly what DCA is because of alternate angles. So angle DCA is also equal to that 68.62 that we just got as well here. Okay, 68.62. So we have those now because of alternate angles. As you can see, a Z over here. So these two are equal. Okay, so we'll just tell them that, and then that is the answer. So therefore, this is equal to 68.62. And we don't need reasons because this is Euclid. Okay, so that is our final answer. Moving on to the next question. Okay, 3.3.2, the last question for question 3 says we need to find the area of POSC. Okay, so let's draw that out, see where that is, and find this area. So POSC. Okay. So with POSC, as you can see, this is not really any shape that, we can name. It's not a trapezium. If it was a trapezium, then you would have had two, sides being parallel. But we don't, okay? That line is slanted. This is the y-axis. So it's not going to work out. Okay. So what we can do in a situation like this is break up the shapes that you can see here. So what we can do here is construct a line going like this, a horizontal line. And now we have created a trapezium on top and a triangle on the bottom. See, this is not a rectangle because this line is slanted. It's not parallel to the y-axis. Okay. However, the x-axis and this line would be parallel since I'm drawing a horizontal line. Okay, a flat horizontal line like that. Okay, so that's of course perpendicular. So this is a trapezium and this is a triangle. Okay, so we just need to know the area of a trapezium to be able to work through this. Let's actually just get this down so we don't have to scroll up and down. Okay, so with this shape, what we can do here is this. The area of the trapezium, to find that, the area of a trapezium is really simple. This is how it works. It is equal to, so we're going to say A plus B over 2 multiplied by H. And really what we're doing here is the A and the B is really just the top and the bottom of the trapezium. So where you see you have parallel lines, this can be our top, like if it was flipped around, okay? This can be our top, that is our bottom, and then the height of the trapezium is that perpendicular height. So this one over here, that is your height, okay? So that's what we can just really look at. So the A and the B is really just the top and the bottom. So we can take that as the top and this as the bottom. I'll leave this specifically as the bottom since it's also the base of this triangle. And then the height is just the perpendicular height. So it's that OS over there. Okay, so those are really just what we need to find. We have to find the length of A, the length of B, and the length of OS. Okay, so since A goes from the origin all the way to P, and as you can see, P is on the x-axis. So this just means that this P is the x-intercept of this line CD. Now, remember we had the equation of the line CD. That's all we really need. If we can get the equation, this is the equation of the line CD. Y equals negative 3x minus 9. We just need to find out what exactly its x-intercept is. Okay, so y equals negative 3x minus 9 and find the x-intercept. So the x-intercept is the point where y is equal to 0, or it's a point where y is equal to 0. So make y equal to 0 and we can take negative 3 over. So 3x equals negative 9. Then divide both hand sides by 3 and therefore x is equal to negative 3. So now we know what that is. So it means that this point over here, the x value is negative 3. Which really just means that you went from 0 all the way to negative 3. You went 3 units to the left. So the length of A is 3. Okay, so we know that now. A is 3 and we can just find B as well. So B is a little different because it's not the x-intercept. However, do you notice that B, right, the length of B, where it starts from is from this point S on the y-axis. If you're going from S on the y-axis all the way to here, then what it means is that you see the y value that you have here. You have an x value and you have a y value, okay, negative something. That y value is going to be this same point's y value as well. So this point is also going to have the same y value here. So it's very important to actually find out what S is, which we actually did find out. We found out the point S was an x-intercept, okay, of two lines. And there we go. It's negative 4 over 3. Okay, so we know what that is. This is negative 4 over 3, making this y value also negative 4 over 3. And so this is very helpful because it lies on the line CD. Okay, and we have CD. We already found the equation of CD. Okay, line CD's equation is still this. So this time with CD with y equals negative 3x minus 9, what we're going to substitute so that we can find out what exactly the length of B is. How far are we going from here all the way to this side? Okay, we really just need to know what exactly that x value is. Then we will know exactly how far this is, okay, or the length of that. So we're going to substitute that into the y value, right, in that line CD, and we'll find what exactly that x value is. So negative 4 over 3 is equal to negative 3x minus 9. Okay, so at this point, we can take the 3x that over, and this comes over and also becomes positive, and minus 9. So you can see to calculate them, we can call this 27 over 3 because we'll multiply the numerator and denominator by 3. And then 4 minus 27 is 23. So negative 23 over 3. And then divide both sides by 3. Divide by 3. Divide by 3, which really just means to multiply by 1 over 3. And so x is equal to negative 23 over 9. Weird number. Okay, but that is the value of x over here. So now we know that this is negative 23 over 9. We know the base as well. This is also the bottom of this trapezium. So that is going to be, you see, you're going from 0, right? From x being 0. And you're going to the left where x is equal to negative 23 over 9. So that means the distance is 23 over 9 because you just went 23 over 9 units to the left. Okay, so we know that and we know that. And that is enough to find the trapezium. With the triangle, we would need one more thing, which shouldn't be difficult to find as well. Okay, it's better to just find it all at once. So with the trapezium, we've got the top and the bottom. That's good. Now we just need, with the triangle, what can we use here to find the area of this triangle? Remember that the area of a triangle is equal to half base times height. Okay, we already know the base here. So we might as well find the height. Okay, the height would be from the highest point of the triangle down to the perpendicular base. Okay, so be perpendicular to the base. The height is perpendicular to the base. And we already know the y value of this. Okay, the y value is negative 4 over 3 all through here. Okay, so we have a negative 4 over 3 here. And then we can see that the y value at the highest point of this triangle is negative 3. Okay, that is negative 3. So what exactly is your height? How would you find your height? If the base is at negative 4 over 3 and the highest point is at negative 3, then just subtract them to get the height. Okay, so you'll say negative 4 over 3 minus negative 3, and you'll find your height. It's always highest minus lowest, okay? And that gives us 5 over 3. So we know the height of that. It's 5 over 3. Okay, we have everything we need now to find the area of this shape. So this is how we're going to find it. Instead of finding each of these individually, let's just put it all together as one. So we can say the area of this shape POCS is equal to, it's equal to the area of the trapezium plus the area of the triangle. And we know we find the triangle by saying a half times the base times the height, okay, which is the same thing here. So it's equal to, except for the heights, of course. So we can call this height H, big letter H. And then we have A plus B over 2. So the A value is 3. The B value is 23 over 9. So 3 plus 23 over 9 over 2 multiplied by the height of the trapezium. And we can see that the height of the trapezium, like we spoke about, is 4 over 3, okay? Because it's just highest minus lowest of that. So 4 over 3 multiplied by 4 over 3. And then let's just work on the triangle. So this is one calculation. This is another one. Okay, so a half times the base here was exactly the same. It was also 23 over 9 multiplied by your height. Okay, so half times your base of 23 over 9 times the height, which we found of the triangle, which was 5 over 3. So 5 over 3, and then we can find this. Okay, so if you put this all together, it should give you the area of this shape. Okay, so this is what we get when we multiply everything. So we get 35 over 6, which if we simplify is equal to 5.83 units squared. Okay, so that is the area of that shape. Now, there are definitely other ways to find the area of that shape. So as long as you get to this answer, then it is correct. Okay, we can just look at the diagram to really just scan for this. Let's actually look at this diagram. So if you wanted to use another way, okay, trying to find the area in another way, there's also this option. So you could look at it like this. Do you see that you have a bigger triangle here, right? And if you erase this triangle from it, you'll be left with that same shape again, POSC. So if you took the bigger triangle, the area of the bigger triangle minus the area of that smaller triangle, you would also end up with that. Okay, so that's one other way. And of course, you can find these dimensions because you see that 39.81 degrees is here. It's vertically opposite this. So this is your angle. Then you could have used the area rule from trigonometry to find the area of this triangle, as long as you have the sides PF and the sides CF, okay? Then you'd be able to use that. Okay, for now, those are the two ways that I've got. I'm sure there are other ways as well. So you guys can actually mention that in the comments, to help others who are looking at this paper and also just thinking of other ways they could have found the area of the shape. Okay, so that is it for question 3. And we move on to more analytical geometry in question 4. Okay, we're on question 4, which says, in the diagram, M is the center of the circle, having Pn as its diameter. And we have KL is a tangent to the circle at N, as we can see over there. So they tell us to calculate the coordinates of P. Okay, so this is just a midpoint situation because this is the center of the circle. So this is a radius and this is another radius. So since this is one of the endpoints, it means that this is the midpoint. Okay, so we're going to use the midpoint formula here. And we'll remember that this is just one of the endpoints and not the actual midpoint we're looking for. Okay, so the midpoint formula looks like this. It's x1 plus x2 over 2, and then y1 plus y2 over 2. Now, our x1 and our x2 we have to establish because this is just p, we'll call it x and y. This will be our x1 and our y1, okay? Now, the reason why is because remember, this is your center. This is your midpoint, okay? This is the calculation to find the midpoint. So don't label this as x1 and y1 or x2 and y2 because this is the actual midpoint. If you label that as x1 and y1, you're going to find the midpoint of this little line, mn. Okay, so we have that and we're just going to substitute it in. So we already know what the midpoint is. It is 3 and negative 5. But to find the midpoint, we use this. So x1, which is x, plus x2, which is these ones, and I didn't name them, x2, y2. So that is plus 7 over 2. And then y1 plus y2, which is y plus negative 2, which is really just plus, and negative just gives you negative. So minus 2 over 2. Okay, so now that we have this, we have the calculation for the midpoint and then the actual midpoint. They really represent the same thing, the midpoint of this line, that diameter. So we can equate them. Since this is the x values, we'll equate the x values as 3 is equal to x plus 7 over 2. And these are the y values. So we'll equate them as negative 5 is equal to y minus 2 over 2. Okay, so now that we have that, let's go ahead. You see there's a 2 on the denominator that's stopping us from getting to the x. So to get rid of it, we'll multiply both hand sides by 2. And so this now becomes 6 is equal to, the 2's here cancel and you have x plus 7. If you take the 7 over, you're saying 6 minus 7 is equal to x. Therefore, that means x is equal to negative 1 over there. And then the y values here, we'll do it the exact same thing. Multiply by 2 to get rid of the 2 as the denominator. Negative 10 is equal to, those cancel, y minus 2. Take the 2 over, so that's positive 2 minus 10 is equal to y. Therefore, y is equal to negative 8. And so your endpoint, which is this point P over here, is negative 1 and negative 8. There we go. So negative 1 and negative 8, and we can just fill that in so we know that we already have this point, negative 1 and negative 8. And that is it for 4.1, and we move on to the next question. The next question, 4.2.1, says, determine the equation of the circle in this form, okay? In the form of the equation of a circle. So to find the equation of a circle, all we need is the middle, right? The center of the circle, and one other point, which we clearly have throughout in that circle there. Okay, we've got 2 points to choose from. Choose the easier point. Okay, so I'm just going to go ahead and use the midpoint, of course, the middle, the center, and I'll use n. Okay, so let's go ahead and do that. So we're going to already write it in that format, but we just need those points to be here. Okay, so our middle or center is M. So we're going to call that A and B. Okay, so this is A and that is B. And that's what we're going to substitute first. So that is going to be x minus 3 all squared plus y. And then you see it's minus a negative 5, which is going to become plus 5 all squared is equal to r squared. Now to find the r squared, we would substitute these points. So this is going to be our x and our y value because it's just a point on the circle. Okay, so that is going to be 7 minus 3 all squared, and then plus, and the y value is negative 2. So we say negative 2 plus 5 all squared is equal to r squared. And then you can just sub this onto the calculator just so that you can get r squared straight away. Okay, so when we put it in the calculator, we get 25. So 25 is equal to r squared. And then now that we know what r squared is, we can finally write the full equation. Therefore, okay, so remember that this was the equation that only needed r squared. So we just substituted into that. So x minus 3 all squared plus y plus 5 all squared is equal to 25. And that's our answer. Okay, so that's the equation of the circle. Moving on to the next question. The next question, we have to find KL. Okay, so the equation. The equation of KL in the form of y equals mx plus c. So KL is that tangent that we have over there. Okay, let's find the tangent. So to find the tangent is a straight line. So it's in the form of y equals mx plus c. So really all you need is a gradient and the y-intercept. So to find the gradient, sure, there's no other point on KL. However, there's something we know about the radius and the tangent at the point of contact. The radius and the tangent meet at 90 degrees. So because this line is perpendicular to this line, we can actually find the gradient of KL. Okay, so let's focus on finding that gradient first. So we need the gradient of the radius first. So we need m and n, and then we can go ahead and find this. So we already wrote m and n down. Let's just find the gradient of that first. So gradient of mn is equal to, and it's y2. Well, we already have that formula, so we might as well just put this as it is. So that is going to be the y value. So we'll just say top minus bottom. So negative 5 minus negative 2, which is positive 2, over 3 minus 7. And what does this give us? Okay, so that's going to be a negative 3 on top and a negative 4 on the bottom. So that's positive 3 over 4 at the end of the day. Okay, so if this is the gradient of the radius, right? Then remember that with perpendicular lines, the gradient of the radius of mn, the gradient of the radius multiplied by the gradient of the tangent KL, right? It's going to give you negative 1 because those are perpendicular. Okay, so with this equation, do you see that to find the gradient of KL, you would just have to divide both hand sides by the gradient of mn, and that would give you the gradient of KL. Okay, so mn. And then, so we know now that to find that gradient, we'll just say negative 1 divided by that other gradient. Okay. So therefore, the gradient of KL would be found by saying -1 over the gradient of mn, which is really -1 divided by that. And if you divide this number by -1, it's just going to switch over and get multiplied by a negative, which is -4 over 3. And that is the gradient of KL. So now that we know the gradient of KL, we can just find its equation, because do you see that KL, right? It has a point on this line. So we're going to use that point to find the full equation. So y equals mx plus c. We know what m is. Y is equal to -4 over 3 x plus c, and then substitute an x value. The only x value we have to substitute is n, which is 7 and -2. So n being 7 and -2, and this is x and this is y, so that is -2 is equal to -4 over 3 times 7 plus c. Okay, c is finally equal to, do you see that if you multiply these, they become negative. If you take them over, they'll become positive. So here they're going to be positive 28 over 3, because 4 times 7 is 28. So -2 is equal to c. Okay, so that's how we find c. Therefore, c is finally equal to, they just have to both be over 3. So what's 28 minus 6? That's going to be 22. So 22 over 3 is going to be your y-intercept. Therefore, the equation of this line is y is equal to, I'll just put it here, okay. Y is finally equal to -4 over 3 x plus 22 over 3. And that is our answer. Okay, so that is the equation of KL. Moving on to the next question. Okay, we are on question 4.3, which says, for which values of k will y is equal to -4 over 3x plus k be a secant, okay, to the circle? So you see the equation they're using, the line that they're using. Okay, so that line with a gradient of -4 over 3, which we now know is this tangent. Okay, it's not this exact tangent, but yes, they're just trying to see if you have this line, right? For which values of k will it be a secant if k is that y-intercept? Okay, so let's think this through. How can we make it a secant? Well, first of all, we need to understand what a secant is. We have a circle and you have a line cutting through the circle, okay, where, as you can see, it cuts through the circle at 2 points, then this is known as a secant, okay? This is different from a chord. A chord would really just go from one point on the circumference to another point. Then that is a chord, and for it to also be a chord, it must not pass the center of the circle. However, with a secant, this is different. Even if the secant passes the center of the circle, as long as it extends out like that, it's a secant, okay? So, and it wouldn't be a diameter, because a diameter would not have those endpoints, okay? So it will just be like that. So that's really what we're going to look at. So let's look at that. And we know that the line with the gradient of -4 over 3 is this tangent. So for which values of k, if we're looking at y is equal to -4 over 3 x plus k, for which values of k would it be a secant? Okay, if you look at this, right, since we're looking at k, y equals -4 over 3x plus k. K is a y-intercept. So the only way you can manipulate this is through the y-intercept, meaning you can either move it up or down. Now you see when you move it up, that is a bad idea because it doesn't even touch the circle anymore. So it can't be a secant. But if you move it down, then you start seeing it's a secant. Okay, I made the line thinner so you can see this. So if we move it down, it's still a secant. See, it cuts through the circle and it passes 2 points. Okay, so still doing the same thing. If you keep moving it down, it's still going to be a secant until it gets to this point over here where it will be a tangent. And then if it goes beyond that, it's no longer intersecting with the circle. So we need to find the values of k for which the graph is going to exist for all these places, okay? So we know we're moving it down, right, from where it is, from this point over here. We would have to consider what exactly would k be at this point. So if this is your tangent, what is k? What is your y-intercept? Remember, this line would extend upwards, so it's going to intersect with the y-axis somewhere up here. And once it intersects, that's the k value. So we will need to find that first. Let's find that y-intercept first. Okay, so since we know that this line, right, at this point where it is a tangent, right, that is the point where k is equal to, we already found that because we found the equation of KL. So we already know at what point k should be a tangent to the circle. So that was here where we found this already at this point, okay? So it's going to be a tangent where k is equal to 22/3, right? So we know what that is. That is 22/3. And then for it to be a secant, it must be anything less than 22/3. But then it can't just be less than 22/3 and it just goes down forever, because then at some point it's not going to be a secant anymore. So we can see that the place that it should stop is here, because at this point it will also no longer be a secant. It would be a tangent at this point. So all we need to find out is what exactly is the y-intercept when this line intersects this point P. That's really it, because at this point P, it would be a tangent, not a secant. Okay, which is actually okay to find. So we look at it like this. We already know the gradient of this line. It's -4/3. And we know it's intersecting P. So now we can find out exactly what that y-intercept is by finding the equation of this line. Okay, so we're looking at a line with a gradient of -4/3 intersecting P, which is -1 and -8. Okay, so the gradient is -4/3. Okay, so let's find this. It's going to be y is equal to, I'll just use the quick way. So y minus y1 is equal to m times x minus x1. And then in place of m, we can just put in our gradient, which is -4/3. Okay, so let's substitute our x and y value. That's x1, that's y1. So that's y minus -8, which of course gives you a +8, is equal to -4/3 times x minus, and -1, which is going to give you a +1. And then let's just simplify. So y is equal to, and if we distribute here, I'm just writing y because we're going to take the +8 over. So if you distribute here, it's -4/3x, and distribute, that's -4/3. Then if you take the +8 over, it becomes a -8. Okay, so y is equal to -4/3x. And what exactly is -4/3 minus 8? That gives us -28/3. Okay, so we know what that is. So we know what the y-intercept is. So here's the story. If you move that line, okay, from where it was a tangent, and you move it down, it becomes a secant. Secant here all through until it reaches this point where it's going to be a tangent again. So we needed to find out what exactly is the y-intercept, the value of k at this point. And now we found that that's -28/3. So this means that this line is always going to be a secant as long as the value of k is less than 22/3, but greater than -28/3. As long as it's within this region, it's going to be a secant. Okay, so we can actually finally put that down. So our answer, our final answer there is it's going to be a secant for the values of k where k is greater than -28/3, but less than 22/3. That's what we had there. And that is our final answer. Okay, so that is it for 4.3. And then we move on to the next question. Okay, final question for analytical geometry. We have points A and B. So A is made of T, and B are not shown in the diagram. From point A, another tangent is drawn to touch the circle with the center M at B. And then 4.1 says, show that the length of the tangent AB is given by this. Okay, I know they said they're not shown in the diagram, but for reference, let's just put it in the diagram so that we can understand what's going on. So let me get the diagram first. Okay, so this is the case. We have a point, right, called A and B, and they're not shown on the diagram. But they tell us that from point A, another tangent is drawn to touch the circle with the center M. So it's this circle at B. So what's going on is we have this circle, and then from point A, a random point, it could be anywhere. It could be here, it could be here. I'm just going to put it here. So another tangent is drawn from point A. Okay, so this is a tangent. It touches the circle at one point, and it comes from the point called A, right? And they say that, so from point A, a tangent is drawn to touch the circle with the center M at B. So the point of contact with the circle is B. That's what we have going on there, okay? And what they want us to do is show that the length of the tangent AB, okay, that length is given by this. So first of all, we can see that this is square rooted. So they could have maybe used the distance formula or Pythagoras, because those would be things that you would need to square root at some point. But let's see. So if this is a tangent, right, and it's drawn to the circle, it's a tangent at B, and we have to find what AB is. How would we do that? So this is actually one of those questions that you would find in a textbook. Okay, so I know it is in the Kevin Smith textbook. I have seen it there. It's probably also in the Mind Action series textbook, maybe Platinum. I'm not sure about Platinum. But you see, with this, what you're going to have to do is, because you're trying to find this length, let's just look at the problems that we'll have here. They told us that A, right, the point A is T and T. Okay, T and T. That's what we have there. So if you have to try to find AB right now, it's not going to be possible because you're going from A to B. So B is unknown right now. B is just X and Y. So if you found it using the distance formula, there's no way it's going to give you this, because this is only in terms of T. It doesn't have any X and Y in it. So there's a little bit more that we have to do. So what we just did now is we ruled out using the distance formula, because using the distance formula was not too helpful to directly find AB. So we can't really just use the distance formula. Remember how I said that this has a square root? So it's probably the case that we are using the distance formula or the theorem of Pythagoras, because that will be a situation where you would have the square root at the end. That's probably where the square root came from. So let's actually see, can we form a right angle triangle with this tangent and the center of the circle, so that we can use Pythagoras on this? Okay, so let's see if we can do that. So we're going to draw a line, and it's going to be perpendicular, so for a radius, perpendicular to that point of contact. And then, do you see that because this is AB, for you to draw a right angle triangle that includes this length AB, you're going to have to connect the point A and M. And if you connect A and M, there you have a right angle. Okay, right angle triangle. Now, how can we use this right angle triangle to find the length of AB? To do that, you would need this side and this side. So now we can actually focus on that. What are the lengths of these sides? So with MB, pretty simple, because M to B is a radius. So it's just the length of the radius, which we already know is 5 units. Okay, we already found that out as we were working through these questions. It's 5 units. Okay, as you can see here in 4.2, you have the equation of your circle. R squared is 25, then R is 5. Okay, so we know what the radius is. It is 5 units. That is great. So the only thing we need to find now would be AM. Okay, so to find AB, we use MB and AM. AM is pretty simple to find, you see, because it's going from A to M. And this is in terms of T, and this is with numbers. So we can actually use the distance formula to find AM. So let's go ahead and do that first. Let's find the length of AM. Distance formula is found by saying the square root of, and you say x2 minus x1 squared plus y2 minus y1 all squared. So AM is equal to the square root of, and we can just, because they have like t squared, let's just start with the t, so A to M. So we'll say t, so first x value, or x2 minus x1, t minus 3 squared plus, and then the y value, so t minus negative 5, which becomes t plus 5 all squared. Okay, so this is what we have for AM. Great. Now, yeah, it looks funny, but it's fine. Here's why I say it's fine, because this is AM, right? But when you're going to use the theorem of Pythagoras, look at how it's going to work. So we can jump into the theorem of Pythagoras immediately to find AB. To find AB, Do you see that AB is not the hypotenuse? It's one of the shorter sides. So we say AB squared would be found by saying the longest side, the hypotenuse, AM squared, minus the other shorter side, which is MB squared. Do you see that we're going to square these? Okay, so that's why I said it won't really be a problem that this one looks like that. So we can even go ahead and square it from here, or we didn't even need to include the square root, honestly. So if you squared it, okay, then those square roots just break open. So we have AM squared is equal to, and we just have T minus 3 all squared plus T plus 5 all squared. Okay, now you have the choice to actually simplify this, which I think is a good thing to do. We can simplify that first and then work with the theorem of Pythagoras. So let's just pull this down here and then let's just clean this up. So this says AM squared is equal to, and let's go ahead and FOIL. So you can deal with this the quick method. So you'll say the first term squared, which is T squared, the last term squared, which is positive 9. Okay, and then first term times second term is negative 3T, and then you times that by 2, which is negative 6T. Same thing on this side. First term squared is positive T squared. Last term squared is positive 25. First term times second term is 5T. Then times 2, which is positive 10T. Okay, so this is what we have. Therefore, AM squared is equal to, and the T's together, which gives you 2T squared. And then those together, 10 minus 6 is positive 4T. And then 25 plus 9, which is going to be 34. Okay, so that's what we have. Okay, not bad. We can actually work with that now. So remember, to find AB, we're saying AB squared is equal to AM squared minus BM squared. So let's just substitute. AB squared. AB squared is what we're looking for. So we leave it as AB squared is equal to, but with AM squared, we already found AM squared. It is 2T squared plus 4T plus 34. And then minus MB squared. What is MB squared? MB is 5. So when you square that, it gives you 25. So minus 25. And then we just have to simplify this. So we have AB squared is equal to, and this is 2T squared plus 4T, and then just subtract those. 34 minus 25 gives you positive 9. Okay, so that's what we have. And you see the final answer is to find the length of AB, not just AB squared. So to find the length, we're going to square root both sides. You don't have to include plus or minus because these are lengths. They cannot be negative. So it's equal to the square root of 2T squared plus 4T plus 9, just as they said it would be equal to. Okay, and I just noticed when you square root, sorry, that's going to give you AB. So that is the final answer. Okay, so that is it for that question. And moving on to the last question in analytical geometry. Okay, so 4.4.2 says determine the minimum length of AB. Okay, so we can do that. You see how this question really helps you? Because even if you didn't get this one right, you could have still gotten this one right. Because they gave you the length of AB already. They told you that it's going to be that. So, you would still be able to do that. Okay, so determine the minimum length. Okay, you want to find the minimum length. The length right now of AB is this, okay? That's square root 2T squared plus 4T plus 9. What do you notice about this and what is under the radical? Okay, what's under the square root is a quadratic expression. You can find the minimum length of this. So if you find the minimum length of the quadratic expression and you substitute it into this, it's going to give you the minimum length of AB. Because even if it's square rooted, it's still a minimum. So it's still the smallest length that you can have. So our focus is on this quadratic expression. We have to find its minimum value. To find the minimum value, remember this is really just a concave up parabola. And you want to find the lowest value that it can have. You just have to find the y value of the turning point, because that would be the lowest value. Okay, if it was on a Cartesian plate, that is the lowest value to ever have. Okay, So we can do that by deriving this, but you could also use this formula. X is equal to negative b over 2a. That finds the x value of the turning point. So x is equal to negative, and our b value is 4, over 2, and our a value is 2. So that's negative 4 divided by 4, which gives you negative 1. So we know what x is. We know what t should be, really. Okay, because this is in terms of t. So we know what t should be. And if you substitute this x value that belongs to that minimum turning point, you're going to find the y value, which is the actual minimum value. So we can go ahead and substitute. So AB is finally equal to the square root, and we'll say 2 multiplied by negative 1, and then plus 4 times negative 1 plus 9. Okay, so that's what we have. And then we can just find out what exactly this gives us. Okay, and the minimum length of AB is this. I forgot the square. So it's the square root of 7. That is the minimum length. And now we're on question 3, and question 3 says, in the diagram, the equation of line AF, so AF, that equation is y is equal to negative x minus 11. Okay, then B, a point on the x-axis, so here's B, is the midpoint of the straight line joining A and C. So here we have A and C. This is the midpoint of that line. Then they say the angles of inclination AF, so the angles of inclination of AF and AC are alpha and 63.43 degrees, as you can see there. And then we have that AF cuts the x-axis in E. So it cuts the x-axis at E here. Then D is a point such that DE is parallel to AC. So here we have two parallel lines as well. Okay, the first question, we have to calculate the value of T. So as you can see, T is the y value of this point A, which is on the line with the equation y is equal to negative x minus 11. So all we have to do is, this is your x value, negative 1. This is your y value. And because it lies on this line, we're going to substitute it into this. So since t is the y value, in place of y, I'm going to say t is equal to, and we'll say negative and x is negative 1. So negative bracket negative 1 and then minus 11. Okay, so this will give us t. So we can say t is equal to negative 1, and that becomes a positive 1. So 1 minus 11, because it multiplies in. And so we have t is equal to 1 minus 11, negative 10. Okay, so there we go. That is the value of t. And then we move on to 3.1.2, and they want you to calculate the size of alpha. Okay, so let's look at alpha. Alpha is over here, and we can see it is the angle of inclination of the line AF. Okay, to find an angle of inclination, you just need the gradient of that line. So of this line, the gradient is negative 1, as we can see. So we know the gradient of AF. Gradient of AF is equal to negative 1. To calculate the angle of inclination, we use the formula tan of theta, but in this case, I'm just going to call it alpha, is equal to whatever your gradient is. And our gradient is negative 1. Okay. So also remember, the gradient is negative. So angle of inclination is speaking about the angle that is formed by this line and the x-axis. As you can see, this is an obtuse angle. So there's something we need to add here when the gradient is negative. So to solve for alpha, try to leave alpha on its own by taking tan over. So when you take tan over, it becomes shift of tan. So on your calculator, you're just going to press shift tan, so arctan, and we have negative 1. So this is to find alpha of negative 1. Now, the thing is, this is angle of inclination. If you say shift tan negative 1, you're going to get negative 45 degrees. And that's not going to make sense right now. How can that be negative 45 degrees? But we can clearly see this is an obtuse angle. Okay. So what you need to do so that you can actually get the obtuse angle is you need to say plus 180 degrees. The thing is, it's measuring backwards. It's actually measuring here. It's measuring this little angle. And that's why it's negative 45 degrees. So the size of it is 45 degrees, but it's measuring clockwise. Angles are meant to be measured anti-clockwise. Okay, so we're going to have to say plus 180 degrees so that you can get the obtuse angle. So if I say that and I say plus 180 degrees, I get 35 degrees. So alpha is equal to 135 degrees, which looks perfect. It's an obtuse angle. Okay, so that is alpha. Moving on to the next question. So the next question, 3.1.3, says we have to calculate the gradient of AC to the nearest whole number. Okay, let's look at the line AC. So this line AC, and it's always important when you find something, fill it in. So we know now what that is, that Y, that T is negative 10. Okay, so we need the gradient of AC. Normally, to find the gradient of a line, you need 2 points. But you can see on this line, look at the problem we have. We have 1 point, we have A. B is missing, C is missing. So what else have they given us in order to find this gradient? Well, as you can see, we have an angle of inclination here. Remember the formula that we used to find the angle of inclination? It included the gradient of the line. It's tan theta is equal to the gradient. We're going to use this formula to find the gradient of this line AC. Let's use its angle of inclination. Okay, so we're saying tan theta is equal to the gradient. If we say tan theta equals to the gradient, and we know what theta is, the angle of inclination is 63.43. That's the angle of inclination of AC. So we're going to say tan of 63.43. That is going to give us our gradient. So let's see what the gradient is. If you say on your calculator tan 63.43, so we get, as you can see, they said round off to the nearest whole number. That would be 2. Okay, rounded off to the nearest whole number. So we have the gradient is 2. And that is for 2 marks. Okay, so that is the gradient of AC. Moving on to the next question, we have determine the equation of AC in the form of y is equal to mx plus k. Okay, so to find the equation of AC, we have everything we need. We have a point A, we have the gradient of this line, we can find that. So there's 2 equations to find the equation of a straight line. There's y is equal to mx plus c, or you could use this formula, y minus y1 is equal to m bracket x minus x1. I like to use this because I just feel like it's simpler to find that c value. Okay, it just finds the equation of the line straightforward. So you can go ahead and use the other one, but I'm going to use this one. So in order to use this, first of all, you need a point. The points that we have is A. And the coordinates of A for this line AC is -1 and -10. So we have that -1 and -10. And we know the gradient of AC as well is 2 that we found. So we're just going to substitute this in. This is going to be your x coordinate. It's going to be x1. You see, x1 and y1 are for your points. So this is x1 and that is y1. And so let's go ahead and substitute. We have y minus y1 is -10. So that's like saying minus a -10. And if you multiply that in, that becomes a +10. So I'm just going to already change it from here. It's going to become a +10 when you minus is equal to, then we have the gradient, which is 2. So 2 bracket x minus, and as you can see, we have a -1. So as you can see, the same thing will happen, negative and a -1. You multiply in and you get a +1. So I'm going to change that to +1. Okay, so this is what we have so long. Then we're going to FOIL this in. Okay, so over here, what's going on is we have 2x and +2. Okay, that is done now. Then I'm going to take this 10 over, because it's going to come over either ways. -10 now, that's what it becomes. And then we're just left with the y on this side. Okay, this is why I like to use this method, because it just finds the equation straight. So we have 2x and +2 minus 10 is -8. And there we go. So that's the equation of the line AC. Okay, moving on to the next question. Okay, now we move on to 3.3. Okay, so 3.3.1 says calculate the coordinates of C. So let's find the coordinates of C. C is here, one of the endpoints of this line AC. Okay, in C, remember what they told us? They told us that AC, right? The B is the midpoint of this line. The good thing about this is we have the equation of this line now. So the equation of that line is y is equal to 2x minus 8. We already have that. So y equals 2x minus 8. And in order to find C, we have A. We can find B. Since we know B is the midpoint, then using the midpoint formula, we'll be able to find C. So B, as you can see, is the x-intercept as well as the midpoint. So since it's the x-intercept, we can go ahead and find it by making y equal to 0. That's how you find the x-intercept. So let's find B first. So to find B, we're just going to make y equal to 0. So remember our equation was y is equal to 2x minus 8. We'll just say 0 equals 2x minus 8. Then we can take negative 8 over. And so we have positive 8 is equal to 2x. To solve for x, divide both sides by 2. And so x is equal to 4. Okay, so here we have B. B, the coordinate is really just 4 and 0 because it's an x-intercept. Okay, so now that we have B, we can use this to find C. So 4 and 0. Now remember, B itself is the midpoint of this line. Okay, so because B is the midpoint, we're going to use the midpoint formula. And remember, the midpoint formula just says x1 plus x2 over 2. And we have y1 plus y2 over 2. Okay, so that's the midpoint formula. Now you need to remember what is going to be referred to as x1 and x2 and y1 and y2. That is going to be the endpoint, meaning A and C. Okay, if you use B as any of these x1 and x2, you're not going to find the midpoint. It's not really going to, it's really just going to find like for example, if you used A and B, you're just going to find the halfway point of that. We don't want that. We're trying to refer to this as AC, and B is the midpoint. So this -1, that is going to be your x1. And your -10 is going to be your y1 because this is the first point that we have. Then C. Now C doesn't actually have a coordinate, so what we're going to call it is x and y. And so this will be your x2 and your y2. So that's how we're going to use that. Okay, so here I'm just putting down the formula. I'm saying that the midpoint of AC is going to be, okay, and that's our formula. And so now we're just putting down what we have. Now that midpoint is equal to, so the x1 that we have here, okay, we have -1 plus x2, which is x. So -1 plus x, and then over 2, and then we have -10 plus y over 2 as well. Okay, so just using it as the endpoint. -1 plus x over 2 and -10 plus y over 2. Now, remember, we're trying to find the midpoint of AC. But the thing is that we already know what the midpoint of AC is. The midpoint of AC is B. It's right in the middle. So that 4 and 0. So we're going to put that in place of midpoint of AC. That is the 4 and 0. So you see, this calculation is meant to find the midpoint of AC. This is the x value of the midpoint. This is the calculation for the x value of the midpoint. That is the y value of the midpoint of AC, and that is the calculation for that. So they represent the same thing because this is just us calculating this, but we already know what the answer is. So what you're going to do is we're going to take the x value and the x value and equate it. So we're saying that 4 is equal to, and we're equating it to this, -1 plus x over 2. And 0, the y value, is equal to, we have -10 plus y over 2. Okay, so this is what we have. We just have to solve for x and y. So here to solve for x, you see we're trying to get to there. The 2 is a problem, so we need to get rid of this 2. Since this is being divided by 2, to get rid of it, you would multiply by 2. But what you do on the one side, you do on the other side. So I'm just saying times 2 and then times 2. Okay, so that will give us an 8 here is equal to, and here the 2 on the numerator and denominator would cancel. Then we're left with -1 plus x. Then we're taking this -1 over, and so that is an 8 plus 1 is equal to x, and so x is equal to 9. Okay, so we have x, and now to find y, we'll do the same thing. There's a 2 on the denominator. To get rid of it, you multiply both sides by 2. 2 times 0 just stays 0 is equal to, that cancels, and you have -10 plus y. Take the -10 over, that will give you a +10, okay, as y. So we can say that y is equal to 10. So there, that is the x and the y value of c. Okay, so c, the coordinate of c is really just 9 and 10. Okay, that is our final answer. Okay, moving on to the next question, we have 3.3.2. So they want us to find the size of the angle FED. So FED. E is the focal angle. So we have FED, which we would draw like this, FED. So this entire angle, let me just erase these. We have to find this entire angle over here. Okay, so with these stuff, sometimes it's a bit of construction that you need to do. So let's look at this angle and just see a way that we can actually just find it. Okay, so a piece of this angle, I'm just going to call this E1 and E2. A piece of this angle, we kind of already know how to find. You saw that this actually just measured this angle backwards. So we know the size of this angle when we were trying to find alpha. And we really just found that by saying, remember, when we're trying to find alpha, when we said shift tan, so where was alpha again? Okay, so here, when we said took this over and we said shift tan of -1, right? When we did that, it gave us a negative angle. I think it was -45. Okay, it gave us -45 degrees. Now that, because it was referring to the line AF, this line AF, it was measuring this angle but backwards. So that is that 45 degrees. Now I'm not going to bother about the fact that it is negative. I'm really just going to take the positive of it. So this over here is 45 degrees. We just have to find this part. Okay, so I'm just going to say to find that little piece. I don't want to call it, I'm just going to call it E1 because it's just a small part. So we found the E1 by saying that tan of theta was equal to -1. Okay, the gradient of that line AF. Then we're just taking tan over, and so that is theta is equal to shift tan of -1. And that would give us -45 degrees. But then you can just multiply it by -1 because we're not really bothered about the direction it was going. We just want the size of the angle. So theta is equal to 45 degrees, or E1 really. So +45 degrees. That is that little part. E1 is 45 degrees. And then we have to find the other part of that angle. So we have this first one. Okay. So to find the other part of the angle, this E2, many a times you're going to have to make constructions on this so that you can just see what's going on properly. So what we can do, you see that E2 is being created by the line ED. Okay, so it's being created by the line ED, and as you can see, ED is parallel to something. If lines are parallel, their gradients are the same. So ED is parallel to this line AC. So it means they have the same gradient. Now remember this line AC, we found its gradient, that 1.999, so it was basically 2, right? We know the gradient of AC is equal to 2. So it would mean that the gradient of this line ED is also equal to 2. Okay, so I'm just going to note that down first. Because the lines are parallel, I know the gradients are equal. So I know that the gradient of AC is equal to the gradient of ED. Okay, so that is down already. Now, why am I trying to actually just focus on this line? Well, if we extend this line, we can actually extend it. So I'm just going to extend this line just so that you can see what's going on. It needs to be a straight line. Okay, something like that. So we know that this is parallel to this. They have the same gradient. if you were trying to find the angle of inclination of this line, it's from the x-axis moving up to the line. Okay, now because they have the same gradient, their angle of inclination would also be exactly the same. So if this angle over here would be exactly the same as this angle over here, okay, because they have the same gradient. So this is also 63.43. So this is 63.43 degrees. And this is the reason why it is helpful to extend this angle. Look at what we can actually see from this. Now, remember, we're trying to find E2, angle E2. So if we're trying to find this angle over here, let's see what it's being created by. It's created by the x-axis and this other line, DE or ED, extended like that. Okay, this is the reason I'm trying to find out how this angle is being created. Because, you see, this is the size of the angle. And you can see now we just created vertically opposite angles. What do we know about vertically opposite angles? Vertically opposite angles are equal. Okay, so that's a way that we could have looked at it. So really from instead of just jumping to this, I only jumped to it because I could actually just see it now. What you could have done is start from E2 and see, okay, how is E2 created? So E2 is created by the x-axis and this. So to understand this more, you could have extended this line like I did here. And then now see that, okay, we have vertically opposite angles. So it means that this itself, E2, is 63.43 degrees. Okay, so now we know E2. So I'm just going to put that down. I know now that, I'm just going to put a line here. E2 is equal to 63.43 degrees. But remember, they want us to find FED. So FED, okay, which is the addition of both angles. So FED is made up of this little E1 and the E2. So we're just going to add 45 and 63.43 degrees, and that will give us that angle. So 45 degrees plus 63.43 degrees. So FED is going to be equal to, and remember, you don't really need reasons. This is analytical geometry. It's not Euclid. And when I add that up on the calculator, I get 108.43 degrees, and that is the size of FED. There are other ways of calculating these, okay, but I like to use the method of finding out what lines create the angle, extending certain lines so that I can understand where these angles appear again because of vertically opposite angles. Okay, so that's it for that question. Moving on to 3.4. And now we are on the last question, and question 3.4 says, G is a point such that EAGC in that order is a parallelogram. Okay, we have to determine the equation of a circle centered at G and passing through the point B. Write your answer in the form of this. Okay, so the equation of a circle. So they've given us the equation of a circle, but they've also told us that G is the center of the circle. Okay, the equation of the circle centered at G. So G, just remember that it's going to have the coordinates A and B. Okay, so that is going to be G's coordinates, whatever A and B is, which we're going to find. And then we also have B is a point that it basically passes through. Okay, so B is already there. I think that was 4 and 0. Let me just confirm. So B is, yes, 4 and 0. So we have these two. So B, 4 and 0. Do we have G? Okay, so G is one of the ones that we have to find. But they're telling us that this shape is a parallelogram. So in that order. So this shape, EAGC, in that order. Okay, so let's draw that shape out first. EAGC. So here's E, A, and so then we're going to have G somewhere, and then C is a parallelogram. Okay, so kind of something like this. We can extend this line. We're going to have EAGC. Okay, since this is the last question, I'm just going to get rid of some information that I don't think is really necessary. Okay, and remember we have C. C is the point 9 and 10. Okay, so we have C already, which is 9 and 10. So we have this. Let's see what they're trying to tell us to find. They tell us that we have a point G, right? And they're saying that this shape is a parallelogram, EAGC. Okay, that is a parallelogram, something like that. So if I just connect it, we have that, and we have this over here. And they want us to determine the equation of a circle, and its center is G, which we don't have, and it passes through B. Okay, so some sort of circle like that. Okay, with the center at G, I know this is not really drawn to scale right now. The center is at G and it passes through B. Okay, so something like that. Okay, if we have to do that, for now I'm just going to erase the circle. We need the center of the circle. We need the center of the circle and at least 1 point on the circle. We have 1 point on the circle. It's B because the circle passes through B. So how do we find G with the information they've given us since this shape is a parallelogram? So how do we actually find the coordinates of G? Okay, looking at the information they gave us, the coordinates of G, we don't have E, we don't have G, although we do have these two. Okay, so there's something here now we can use. Because we have E, A, G, C, those are the points on this parallelogram, right? The 4 points that we have. It would mean that this AC is a diagonal. Okay, and since this is a parallelogram, something we know about diagonals in the parallelogram is that they bisect each other. And really what that means is when something bisects another thing, it's not the same as it intersecting. To intersect just means to cut through. But when something bisects another thing, it means, like if I have this line and I say this new line I'm going to draw bisects this line, it means it actually cuts this line into 2 equal parts. That's what it means to bisect. Okay, so if the diagonals bisect each other, what it would mean is that we have here AC, the other diagonal, which would be EG, right? So EG, it's also going to bisect AC. And basically, they're going to share a midpoint. Okay, now already from this, I can already see something is weird about this information. We already know that the midpoint of AC is B. So it means that the midpoint of EG should also be B. So this line, okay, this point G actually, it's clearly actually on the x-axis because see, E all the way to G is one of the diagonals we're going to have. So this is actually how this should have been drawn. So we're going to have G somewhere maybe here. And if we extend the point, we're going to have this. It's on the x-axis. Like let's say that's G, and then it's going to connect like that. Okay, so basically something like that. So you see now EG, let me just say G, EG is a diagonal and AC is also a diagonal. And we have B as the midpoint of both of them because it's a parallelogram. The diagonals bisect each other, so they share a midpoint. Okay, so this is the 4 and 0. Okay, so with this information, we can use the midpoint theorem. Since we already have this, we have these two endpoints, we have the midpoint of it. We just have to use the midpoint formula, not theorem, the midpoint formula on EG, okay, since we already know the midpoint. So for us to use that, we don't have G. That's just X and Y so long. But we can find E. Okay, we may not have E right now, but we actually can find it. I'm not sure, do we actually find E? Let me just check. Okay, no, we don't have E. So we can actually find E. You see E, it's sitting on the x-axis. So it is the x-intercept of this line that it is on. And we have the equation of this line. So we just have to find the x-intercept. Now that I'm saying that, I feel like we found this already. But okay, let me see. So the x-intercept, when you want to find the x-intercept, you just make y equal to 0. Okay, so that's all we're going to do here. 0 is equal to negative x minus 11. And so let's solve for x. We can just take this negative x over. Positive x is equal to negative 11. And so it means that E is just negative 11. And because it's an x-intercept, the y value is 0. Okay, so we have E now. And now that we have the coordinates of E, negative 11 and 0, we can use this to actually find G. We have its midpoint. We have the midpoint of the line EG. the midpoint of that line is point B, which is 4 and 0. So we're going to use the midpoint formula. Okay, to calculate the midpoint of this line, e.g., we would say x1 plus x2. So this will be our x1. This will be our y. This is the y value. So y1. And then this one over here, the other endpoints, because we want to find the midpoint of EG. Okay, so that is x2 and y2. So we're going to use that, but we already have the midpoint, kind of like we did already in this one of these questions here. Okay, so let me put down the points that we have and let's just calculate that. Okay, so we have E, we have G, and the midpoint of EG itself is that coordinates B, okay, which is of course 4 and 0. So let's use the midpoint formula. So that says x1 plus x2 over 2, so midpoint of EG. Okay. And then y1 plus y2 over 2. You don't necessarily have to put an equal to here because this is actually a point, but it doesn't matter. Okay, then we're saying the midpoint of EG is going to be, and so x1 is going to be this. We have negative 11 plus x2, that is x2 plus x over 2. And then we have y1, which is of course the 0. So 0 plus y2 over 2. Okay, now in this formula, this is just to find the midpoint of EG. We already know what the midpoint of EG is. It is 4 and 0. It's that coordinate of B. So in place of midpoint of EG, I'm just going to put 4 and 0. And like before, again, the logic behind this is that this is the calculation. This is the formula or the calculation for the midpoint of EG. But this is the midpoint itself of EG. So we can just say that this x value would be equal to this x value because it's really talking about the same point. This is calculating the point. This is the point. And then this is the y value and the y value. So we're going to equate it like that. So we're making the x equal to the x. So 4 is equal to negative 11 plus x over 2. And we have the y. 0 is equal to, 0 plus y2 is just going to give you y2. So I'm just going to say, I didn't have to say y2. I could have just said y. Okay. Because the y2 was y. Okay, so plus y over 2. Then we just have to solve. So here we need to get rid of the 2, multiply by 2 on both sides. We have here 8 is equal to negative 11 plus x. And then we're going to take that over. So 8 plus 11 is equal to x. X is equal to, and that's going to give you a 19. Then the y value, just going to get rid of the 2 by multiplying both sides by 2. 0 times 2 still stays 0. And so y is equal to 0. Okay, so because that cancels. So this is what we have now. We finally found the coordinates of G, that endpoint. We know what that is now. So G finally is the point 19 and 0, which makes perfect sense. It is an x-intercept as well. It's on the x-axis. And remember in the information, they told us that this was the center. So G is the center of this circle whose equation we have to find. So this is the center of the circle. And what else did they tell us about this? They also told us that the circle passes through the point B. And we know what B is. So all we have to do now is actually just find the equation. Okay, but let me just make some space. Okay, so we're just going to go ahead and take this equation of a circle. So x minus a all squared plus y minus b all squared is equal to r squared. Because this is the circle center, your value for a and b would be the 19 would be the a, the 0 would be the b. And then since we have the center, we also remember that B is a point that the circle is going to pass through. So B, we're going to use this as a point we're going to substitute into this equation of the circle. We're going to substitute B, which is 4 and 0, and this will be our x and y coordinate. Okay, so let's go ahead and do that. We're going to have, in place of x, we're putting 4. So 4, then minus the a value is 19, all squared. plus the y value here is 0, and then minus the y value here is also 0. All squared is equal to r squared. Then we can just put this all onto the calculator. You see, that's going to be 0. You don't need to put that part. So just 4 minus 19 all squared. And you see what that gives us? It gives us 225 is equal to r squared. I'm not going to solve for r because I just want the equation of the circle. So if I'm concluding, right, you're going to say x minus, and then the a value, okay, we're going to put that in there because that needs to be filled in. A and b needs to be filled in. X and y can be left empty because this is the equation of a graph. It's a circle in this case. Okay, so a minus 19 all squared plus, and then here we're going to have the y minus 0 all squared, okay, because that's our b value, is equal to what is r squared. We just found that, 225. So 225. So as you can see here, y minus 0, that's just going to give you y. Okay, and so that all squared is just y squared. So this is the equation of the circle at the end of the day. Okay, so that is the final answer there. So yeah, that question was quite long. It's about 4 marks. Okay, so that's how we work that one out. And now we move on to question 4. Okay, so now we're on question 4, and question 4 says, in the diagram, the equation of the circle centered at n, which is negative 12 and 5, is x squared plus y squared plus 24x minus 10y plus 153 is equal to 0. Okay, so they already gave us the center, but this is the equation of that circle. Then they said the equation of the circle centered at M, the bigger circle, is this. Okay, then they tell us PS and PR are tangents to the circle centered at M. So here, these two are tangents. And then we also have at S and R respectively, PR is parallel to the x-axis. So these two lines are parallel. Okay, x-axis in that. And then we have K, which is negative 17 and negative 5, is a point on PS. Then they also tell us that the straight line joining N and M cuts the smaller circle at T and the larger circle at S. Okay, so just intersections here and there. The first question is to write down the coordinates of M. Okay, so M, the coordinates of M, that is the center of the bigger circle. The center of the bigger circle, let's see. They told us, what did they tell us about the circle? The equation of the circle centered at M is this. Okay, so we have its equation. When you have the equation of the circle, okay, this will stand for your A. It's really minus A and minus B. Okay, so because of that, when we're going to find A and B, so M, the coordinates of A and B, you're going to always change whatever sign is here. Okay, because of that x minus A, because you're subtracting it. Okay, so instead you're going to have a negative 6, and your B is going to be, since it's positive 3 here, it's negative 3. So that's how we find that. Okay, because it's really just x minus the negative 6. That's why this became an x plus 6. So you see this minus A, here's the minus, and that is the value of A, that negative 6. Okay, likewise with the B. Okay, so that's the first question in question 4. Next question says, calculate, so 4.2.1, the length of the radius of the smaller circle. So we need to find the length of the radius. Okay, so let's look at the equation of the smaller circle that we have, because the radius is always that last number at the end. The equation of the smaller circle is this. They said the one centered at N, okay, this is the equation. So you see, we have to first complete the square, put it in standard form so that we can actually see the radius. Okay, so let me put this down first. Okay, and this thing is only blurry for question 4 and 5. After that, it will be clear again. Okay, so we have this, and we basically just have to complete the square on this. When you complete the square, we're going to, first of all, let's put it in the right order. The x's need to go together and the y's need to be together. So this is actually just x squared plus 24x. Then we have a positive y squared, so plus y squared minus 10y. Then the constant needs to go over, so the number without a variable. So is equal to, that will become negative 153. So this is what we have so long. Then we're going to work through it like this. We say first x squared plus 24x. Then we're going to take the coefficient of x, which is positive 24. And we're going to multiply by a half, or say what is the half of this. Okay, so you can multiply by a half or say the half of this, and that will be a positive 12. So what we're going to do is we're going to add by the positive 12 and then square that number. Okay, then we continue. We have plus, we have y squared minus 10y, and we're going to do the same thing for the y. We'll take the coefficient of y, which is negative 10, and we half it, or you multiply by a half. So half of negative 10 would be negative 5. So you're going to add by negative 5 all squared. Then is equal to negative 153. And because this is an equation, you want it to balance. You want to not change its value or just changing the way it looks. What you do on the one side, you must do on the other side. So what we did on this side was we added positive 12 all squared. And again, we added negative 5 all squared. So we need to do the same on that side. Okay, so this is what we have. Okay, now we have to just simplify this. We're going to have, because we have x squared here and we have a positive 12, because they both have squared on top of it, we're going to put them in one bracket. And so we're going to have x, and this 12 now is positive. That's why we're going to have a plus 12. The plus is not coming from this plus over here. It's coming from the fact that the 12 is positive. Okay, now the logic behind this is that if you actually take this trinomial as it is here, the full value, even that, and you factorize it, you actually will end up with that. So it's this, and then the squareds go on top, all squared. Okay, and we're going to do the same thing with the y. So plus, you see that the y has a squared and this also has a square. So we're going to put it in a bracket, and the squared from this y and from that goes here, all squared. And then we're saying we're dragging down the y, and we're dragging down what's inside this bracket, all squared, which is a negative 5. So we say minus 5, okay, all squared. Let me actually just pull that closer. All squared then is equal to all of this number. Now, at least it's all numbers, so you can just put this onto the calculator. And then we get 16 for all of that, so 16. Okay, the question was the length of the radius. The length of the radius, we're going to find that from this part. Remember, this is in the form of x minus a all squared plus y minus b all squared is equal to r squared. So this part is the r squared. So we're really just saying r squared is equal to 16, because that's what r squared is. And we're going to square root to find the radius. So r is equal to just 4. Now here I'm not going to say plus minus really, because a radius is a length. It can never be negative. So even if you walk backwards, you cannot say I walked negative 2 meters. No, you covered 2 meters only. Okay, so it's just a positive 4. So 4 units. Okay, so that is what we have as the radius. Now moving on to the next question. Okay, the next question, 4.2.2 says, we have to determine the length or calculate the length of TS. Okay, let's look for TS. So TS, as you can see, is just this little line here from the circumference of the smaller circle to the circumference of the bigger circle. So what is the length of that line? Okay, so the way we can find this length is, remember that we already have M. So M is the point negative 6 and negative 3. So put that down, negative 6 and negative 3. Now, since we already have that, look at how we can find TS. Think about it like this. If you took the distance all the way from N going to M, right? And then we subtract by the distance from N to T and the distance from S to M, which of course are the radii of these circles. So the radius of the smaller circle is the nt. If we do that, we're actually going to find that little ts. So it's this entire length, that nm. And if we subtract that by this length over here, nt, minus this length over here, sm, you'll be left with this little piece, ts. So that's what we're going to do. Okay, so to find the entire length of nm, we're going to just have to find the distance of nm. And you see we have both points already. Okay, so let's find the distance of nm. We're going to take that distance and we're going to subtract it by this little distance of nt. Now nt is just the length of the radius, okay, of that circle. From n to t is to the circumference. So that is one radius. Then we're going to subtract again by this little part, sm. By sm, the other radius. And this calculation basically will give us ts. That's how we'll form ts. Okay, so let's go ahead and do that first. Okay, so with this, we can actually separately just find nm. You can do that. There's nothing wrong with that. So nm, and we're going to find that. The formula for the distance, okay, of a line is the square root of, then you say x2 minus x1. Even if you said x1 minus x2, it will work. Just stay consistent with the y's as well. Also say y1 minus y2. Okay, so I'm saying x2 minus x1 all squared plus y2 minus y1 all squared. Okay, and I'm just going to use the coordinates of n and m. Okay, so these are the coordinates that we have. So we can go ahead and say, we're saying square root of, so I'm going to just say -6 minus -12. So that is -6. Remember, minus -12 just becomes a plus 12. Okay, so it's just -6 plus 12 all squared. Then we have y2 minus y1. So this is y2 minus y1, which is going to be, so plus. Then we say -3 minus the 5, minus 5 all squared. Okay, so you can just put this onto the calculator and let's see what we get. So we get nm is actually equal to 10. So nm is equal to 10 units. Okay, so we know nm. Now all we have to do is find nt and sm. Okay, and those ones are actually quite simple to find. First of all, so nt is the radius of the smaller circle. You see the radius of the smaller circle, since this is the formula for the smaller circle, and now we already put it in its standard form, we already found the radius of that. That was 4 units. So from here to here, from nt, that is only 4 units. So we're going to say, okay, we have that one as well. So we're really just saying that ts is equal to, that is 10 units, nm, then minus 4 units for nt, and then minus sm. Okay, now what is the length of that? The bigger circle, the radius is ms, right? And its radius, we already have the equation of it. Look at the equation here, okay? And as you can see, we have 25 here. That stands for r squared. So in order to get r, okay, or the radius of that, you're really just going to say that that r squared is equal to 25, and we're going to solve for r. So to solve for r, we'll have to square root both sides, and so r is equal to 5 units. So now we know what ms is, or sm. That is 5 units, so minus 5 units. Okay, so what is this? 10 minus 4 is 6, and then 6 minus 5 is 1. So this ts is only 1 unit. Okay, that is the length of that, and that is all for 4 marks. Okay, so that is that, and moving on to the next question, 4.3. So 4.3 says determine the equation of the tangent PR. So let's look at that tangent, the equation. So we need to find the equation of this tangent PR. Now remember, like I've already put here, these are parallel. They said that this line, this tangent, is parallel to the x-axis. What that means now is that this is a horizontal line. You see, the equation of vertical and horizontal lines, this is how they work. If a line is horizontal, all you have to do is this. You have a horizontal line. To find the equation, you're going to first find out what number does it pass on the y-axis. Of course, if it's horizontal, it's going to cut the y-axis. And so its equation will start with y is equal to, and then you say whatever number it passes. Y is equal to that. Okay, that's the equation of a horizontal line. On the other hand, a vertical line, you look at which axis does it cut through? It cuts the x-axis. So it will start with x is equal to whatever number it cuts through. Okay, that's the equation of horizontal and vertical lines. So in this case, we have this line PR, it's horizontal, but we don't know, we cannot really see, because if it's extended, of course, we cannot really see what number on the y-axis that it's cutting through. So we need to actually just find that y value. Okay, so what can we use to find its y value? If we look at this, to find this y value, because I just want to know what is the y value belonging to R and of course P. So what is that y value? Well, we know what the radius is. We know what the coordinate, okay, of this center, is. We know what this is. So since we know that this point M, right, is -6 and -3. See, look at this. -6 is the x value. That is -6 over here. -3 is the y value. So we know this y value is -3. Another thing we know is that if you draw a line from the center of the circle to the circumference of the circle, in this case, this line is intersecting the tangent, okay, that this will be the radius of the circle. And we know what the length of this radius is. It's the same as ms. Okay, ms, we already found that. That was 5 units. Remember, that was from here. Okay, we already know the radius of sm or ms is 5 units. So it would mean that the radius of mr is also 5 units. So think about it. Here, the y value was -3. This distance is 5. From here to here is 5. But notice we are moving down. When we are moving down on the coordinates, we are not going to add, we're going to subtract because we're moving down. So we're saying we have -3 here and we just have to move down by 5 units. Okay, so -5. Move down by 5 units and we'll get what that value is. So -3 minus 5, that will be -8. And that's how we find that y value. Okay, so I'm just going to put that calculation there because it doesn't seem like there's much calculation to do. So I knew that we had the point M, which is -6 and -3. And so to find the y value, basically, so that was specifically the y value of R and P, of course, but the y value of R, we said -3 and then moved down by 5 units because that's the length of the radius. And so the y value of R is -8. Okay, remember they just want the equation of the tangent, and that tangent is a horizontal line. So remember what I said about horizontal lines. To find the equation, you just check which axis does it cut. It cuts the y-axis. So it will start with y is equal to. At what number does it cut the y-axis? At -8, because we found out what that R's y value is. So y is equal to -8. And that is the equation of that tangent. So you can therefore say y equals -8. Okay, so that is 4.3.1 done. Okay, moving on to the next question. Here in the next question, we have 4.3.2. They say that PS, we need to, determine the equation, of the tangent PS in the form of y equals mx plus c. Okay, let's look at PS. Let's also fill in what we have. We know now R, well, do we know the x value? Yes, we actually do know the x value of R, funny enough. We know the x value of R because I am taking from the center of the circle, and this is a perfectly vertical line, and it's intersecting, and we know it's perfectly vertical because this is a tangent, this is a radius. The tangent is always perpendicular to the radius. Okay, so because of that, we already know now that the x value, so the x value here is going to be the exact same x value here because look at it, they're in line with each other. If this is -6 over here, the x value right down here, because this is a perpendicular line, is also going to be -6. And now we also know its y value, which is negative 8. Okay, I'm just filling in all the things that we have already found because it usually helps. Then P, we don't really know its x value, but we do know its y value because you see it's a point on this horizontal line. So its y value is also negative 8. Okay, this is what we know so long, and they want us to find the equation of the tangent PS. Okay, equation of the tangent PS. Let's see what we have. In order to find the equation of a line, okay, you need the gradient and then you need one other point. Good thing we have a point here, K. We have a point K, and now we need the gradient. So how do we find the gradient in this one? Okay, so if you look along this line, PS, you see we don't really have the full coordinate of P. If we had this x value, this would be so easy to find. We'll just use that and that. We'll find the gradient and basically find the equation. But unfortunately, we don't have this. But if you look along this line, you see we also have S, but we also do not have that coordinate as well. Let me just erase this. I don't think that will be helpful. Okay, so what else can we use? Remember how I said here that MR is going to be perpendicular to PR because this is a radius and this is a tangent, and the radius is always just perpendicular to the tangent at the point of contact. Well, that would also apply here. So from M to S, and then you have this PS as a tangent. So this would also be perpendicular as well. Okay, so let me actually just put that down. So I'm saying that MS is perpendicular to PS. Okay, so we're going to use the rule of perpendicular lines. So we may not have this gradient. We have 1 point, which is good enough. But we know now that this line PS is perpendicular to this line MS. And you can see now from M all the way to N, that's just an extension of the line MS. Okay, so of course the gradient of MS is exactly the same thing as the gradient of MN. So what we can do is find the gradient of MN and then use the rule of perpendicular lines to find the gradient of PS, since these two lines are actually perpendicular. So let's find MN. Let's find that gradient. Okay, so I'm going to put the coordinates down and let's find it. Okay, and let's find the gradient of this line first, then we'll be able to find the gradient of the one perpendicular to it. So the gradient of MN is going to be equal to, of course, it's the y2 minus y1 over x2 minus x1. And so we're going to take y2 as this, so 5 minus y1, so minus negative 3, which becomes a plus 3, over, and then we have negative 12 minus negative 6, which becomes a plus 6. So negative 12 plus 6. Okay, so you can put this onto the calculator and let's see what the gradient of MN is. So you see the gradient of MN is negative 4 over 3. So now that we have that gradient, this is what we're going to use, the rule of perpendicular lines. If we want the gradient of PS, which we need to find the equation, we know that this is perpendicular to this. So this means that the gradient of PS multiplied by the gradient of MN is going to give you negative 1. So MN is going to be equal to negative 1. We're going to use this rule. Okay, so I'm just going to write on the side. So I'm saying, putting that rule down. Okay, and so we don't know the gradient of PS, we want to find that. Saying the gradient of PS multiplied by the gradient of MN is negative 4 over 3, which is equal to negative 1. And now we just have to solve for this. Okay, to solve for gradient of PS, you see that it's being multiplied by negative 4 over 3. So we want to leave this alone. Since it's being multiplied by this, to get rid of this number, we have to divide. Okay, so we're going to divide. But because this is an equation, what you do on the one side, you must do on the other side. So divide both sides by negative 4 over 3 to get rid of it. And this is what we're going to get. You can put that on your calculator, but something you will notice about this when you divide negative 1 by a number or a fraction. So it's negative divided by negative, which is positive. What will happen here is the numerator and denominator just swap. So that's just 3 over 4. So this is our new gradient. The gradient of PS is 3 over 4. Okay, and now to actually find the equation of this line, PS have become very simple now. We have a point on this line, K, which is negative 17 and negative 5. And we can just use that point now to find the equation of this line. So I'm going to use that formula, y minus y1 is equal to the gradient, bracket x minus x1. Okay, let me put the coordinates of K here. Okay, so just remember the x1 is this x value, so that's x1. The y1 is that y value. So we're saying y is minus, okay, y minus, and then the y1 is negative 5. So you're saying minus negative 5, which will become plus 5, is equal to, your gradient is 3 over 4 multiplied by x minus negative 17, which will become plus 17. So you just have to simplify this. Okay, so let me just take it to the other side. Okay, so we're saying, I like to start here because that will go over anyways. So we have 3 over 4 multiplied by x, and you have to multiply by that. So we're distributing that. So we have 3 over 4x. If we say 3 over 4 multiplied by 17, that's going to give you 51 over, so positive 51 over 4. Then multiply that out. This 5 needs to come over. So I'm taking that over, and it becomes a negative 5. What's left on the right-hand side is just the y on the left-hand side, I mean. So simplify this. Y is equal to, we have 3 over 4x. And then what is positive 51 over 4 minus 5? So minus 5, and that gives you a 31 over 4. So it is a positive 31 over 4. And so that's what we get. That is the equation of the line PS. Okay, so there we go, in the form of y is equal to mx plus c. Moving on to the next question. So the next question, 4.4.1 says, we have a quadrilateral PSMR. It's drawn, and we have to calculate the perimeter of it. So PSMR, let's just see what that's going to look like. Okay, so this is this PSMR. Okay, let me just highlight it. Okay, so we need to find the perimeter of this quadrilateral. The perimeter of this quadrilateral, all you have to do, it's perimeter, it's not area. So you don't have to start thinking, what kind of shape is this? You don't really have to even bother about that. All you have to do is take all the sides that you have and add them together. That would be the perimeter of the shape. So from that, we see that we're going to have to find what PS is. So from P to S, what is that length? From S to M, so plus SM, then plus MR, and then of course plus RP or PR. And that will give us the perimeter. Okay, so let's see how we can actually find that. Okay, so PS. To find the length of P to S, we would need to have the coordinate of P and the coordinate of S. Okay, looking at the coordinates of P, we know the y coordinate. We don't know the x coordinate, but we actually know the equation of this line. In the previous question, we found the equation of this tangent PS. So if this is the y value belonging to this x value, let's just take that equation, and in place of y, we're going to put negative 8, and it's going to give us the x value belonging to this. Okay, so remember, here is PS. The equation of PS is this. And to find that, let me just put this on the side. This is just the calculation of it. Okay, so this is the equation of PS. And remember, we have that P point is x and negative 8. So in place of y, we're going to put negative 8. So negative 8 is equal to 3 over 4. We don't have x, plus 31 over 4. Okay, solve for x. Take this over. And so we have negative 8 minus 31 over 4 is equal to 3 over 4x. What is negative 8 minus 31 over 4? That gives us negative 63 over 4 is equal to 3 over 4x. Then to get x on its own, we divide both sides by 3 over 4. And let's see what we get. So x is finally equal to this divided by 3 over 4. So I'm going to just say equal to divide by 3 over 4. On your calculator, you can just say divide by 3 over 4. It will just work. Okay, you see we get negative 21. Okay, so that is the x value, negative 21. So it means the point P is negative 21 and negative 8. So we have point P now, negative 21 and negative 8. Let me put that down. Okay, so let me just put this down, negative 21, negative 8. Okay, we have P. We need to find S. To find S, we have PS. We have the equation of that line. We don't have the equation of NM because you see that PS and NM, they actually intersect at S. So if we find the equation of NM, we can equate it with the equation of PS and we will find that point of intersection. Okay, so guys, at this point, I didn't realize that, you see, these two are tangents. So if they're tangents, it means that you can also apply the Euclid theorem, which states that if we have tangents drawn from the same point, P, basically drawn to the circle, that they are equal. So all I really need to do is find PR. So I'm going to skip this whole thing where I try to find that coordinate of S because it's really unnecessary. And if you notice the mark allocation for that question, you'll see that we're really wasting a whole lot of time. You see, this is only 5 marks. Well, not only, but the work I'm doing is way too much for 5 marks, okay? So I'm just going to jump to the part where we have found PR, and I just need you to remember that PR is equal to PS because this is tangents drawn from the same point to a circle. Then let's also think about the other ones. So SM, right? We also have to find that. We're finding the perimeter of this whole shape. S to M, that is a radius. Okay, it's the radius of the bigger circle, which we already know is 5. Remember from its equation. We have the equation. This is r squared. We square root and we get 5. So this is 5 because it's the radius. That would also mean that MR is also 5. And then you see we have P and we have R and we can find that distance. So now it's just a matter of calculating to find each of the distance. SM is 5. MR is 5 as well. So we have those. So next, let's just find the last one, which is PR. Now, PR, you could also use the distance formula, but it's not really necessary in this question. The reason why is because they told us that this line, this tangent, is parallel to the x-axis. So it's a horizontal line. If you want to find the length of this horizontal line, look at this. We have here, this coordinate here is negative 6, right, of R. So if we know that R is, I'm actually just going to put down the coordinates because I didn't write down this calculation there. So it's kind of going to be, we know R negative 6 and 8. So P is, of course, the negative 21, negative 8. R is the negative 6 and negative 8. Now, I'm not going to actually use this calculation because I don't really see it as necessary in this question. What you can actually just do is, you know that this, the x value, right, is negative 6. So you have negative 6 over here. Let me just get rid of some things. So here, this over here is negative 6, that x value, right? Now look at that. This x value here is negative 21. This is a horizontal line. It's not like this one where you actually have to use a formula. You literally just have to find out what is, if you have to go from negative 6 all the way to negative 21. How far is that? Okay, another way of looking at that is by actually saying negative 6 minus negative 21. Okay, it's always going to be right minus left because the numbers on the right are bigger than the numbers on the left. Okay, so I'm going to put that calculation down for this PR. That will give you that length, okay, because we know its x values. Okay, I noticed I said negative 2, just negative 21. So I'm saying PR is equal to that negative 6 minus negative 21. And we get PR as 15. Okay, I'm starting to realize why I didn't need to actually do any of these calculations. If you look at this diagram, you didn't need that calculation. This is a circle. This is a tangent. This is another tangent. when you have tangents from a circle, okay, or from a point drawn to the circle, they are equal in length, meaning this PS is supposed to be equal to PR. Okay, so sometimes really just step back and look at it and see, is there easier ways of actually doing this? Because that calculation was unnecessary. We didn't actually have to do that. You could have just told them that they're equal and they would have seen that. But even this is fine. Okay, so do we have everything now? So we have PS, we have PR, and we have, of course, those two radii. Okay, so the perimeter of the shape, let me just copy this because that was the calculation for it. The perimeter of the shape, let's just put everything down. This is a long question. And it's equal to PS, we already know that is 15 units. That's 15. That's SM. Remember that was 5 units from that circle, the big circle. Its radius is 5. Okay, so plus 5. And of course, we already have MR, which is also 5. So 5, that's 5 because they were both the same. They were radius of that circle, radiuses or radii. Plus PR, lastly, is 15. Okay, so what is this going to be? 15 plus 15 is 30. 5 plus 5 is 10. 30 plus 10 is 40 units. So this is what we have. The perimeter of PSMR is 40 units. How many marks was that? That was worth 5 marks. Okay. So, of course, the step here was unnecessary. You could have just found that easily. So that's what we have. The next question now, last question for question 4. This is the ratio. You need to calculate the ratio of the area of triangle NPS over the area of quadrilateral PSMR. Okay, let's see what this is going to be. Now, PSMR, we have the dimensions of that PSMR. We have the length of it. Now we have to find the area of triangle NPS. Let's look for that triangle. Let's look at that triangle. NPS, okay, from N to P to S. So it's this triangle over here. Okay, so it's this blue triangle that we have here. To find the area of it, to find the area of a triangle, hopefully it's a right angle, you only need the height and the base. So as you can see, since PS was perpendicular to MN, then this is 90 degrees and this is of course also 90 degrees. Okay, so because of that, because we have a right angle triangle, we can treat this part as the height. But look at this height. You see, they call this NPS. Okay, the height of this is NS, that full length over there. And then of course we have the base of it, which is PS. We have that length already. Okay, so we just need to find the height and the base. The height of this, since this is NS, how can we find NS? Well, we know what NT is. We know NT is the radius of the smaller circle. The radius of that smaller circle, remember when we actually simplified that, we got a 16 on the side. And we found the radius of the smaller circle to be 4 units. Okay, so since we have that, we know what NT is. That is 4 units. Then remember in this question, we actually calculated the length of TS. Everything always adds up. They're never just going to ask you new stuff. TS was the 1 unit. There we go. TS is 1 unit. So you can see now, if that is 1 unit, then from N to S will be a total of 5 units, 4 plus 1. So we have the height. We know the height of this triangle is 5 units. And then we also have the length. We have PS. We did the calculation for that. So to find the area of that triangle, we just say a half multiplied by your base multiplied by your height. Okay, let's go ahead and calculate that. Okay, so the equation is half of the triangle times whatever your base is multiplied by whatever your height is. Okay, and over, we'll find out what that one is going to be, is equal to half multiplied by the base. We're taking this as PS and the height is NS. So multiplied by PS multiplied by NS. Okay, over whatever that's going to be. And This is a half multiplied by what is PS. PS, we already found the length of that bigger side. PS is 15 units. So multiply by 15. And we know now NS is 5 units from N to S. Okay, let's now concentrate on, so we have all that. Let's concentrate on the area of this quadrilateral. Okay, what kind of quadrilateral is this? Let's look at this. Let's just look at this quadrilateral. So there's a 90-degree angle here. There's another 90-degree angle here. This is the radius. This is 5 units. And I can erase this. I don't really need this. This is also 5 units. Okay. You see 2 pairs of adjacent or sides that are next to each other are equal. And we also know that this is equal to this. This shape is a kite. And if it's a kite with right angles. That is a good thing. What we can do is actually take this shape and we can actually split it into 2. We can split it into 2 triangles, 2 right angle triangles. Okay. And then we can separately find the area of each triangle. But notice something here. You see, the height of this triangle is 5. If you also kind of tilt your head, you'll see that this one, the height is also 5. The base of this is PR, which is also equal to this base. And they're sharing the same hypotenuse. This is the exact same triangle. These 2 triangles, or what we would say are congruent, it's the exact same triangle. So the area of this triangle will be equal to the area of that triangle. Okay, so I don't know if there's a formula. I'm sure there is a formula for the area of a kite, but you don't really work through that in grade 12. So you can just use this instead. So I'm just going to focus on one of it, right? And I'm going to find the area of that. Then to find the area of the entire shape, I'm just going to say times 2 because it's double of that. Whatever this area is exactly what this area is. So just find one of it and times by 2. Okay, so the area of this first shape is going to be made up from, we're going to say the height is MR and the base is PR. Okay, let me actually just say it as it is the area of triangle PSM and PMR added together. Okay, so you see it's the area of triangle PSM plus the area of triangle PMR, which will give us that. And of course, we know it's the exact same thing. So I'm just going to say it is really 2 times the area of triangle PS. I'm just going to take the lower one, PMR. Okay, so that is the lower one. Okay, so to find the area of that PMR, okay, I'm only saying 2 times because it's double. It's really just, if you add that and that is the same thing. So it's double of it. So the height of this is MR and the base is PR. So we're taking the height as, we're saying a half multiplied by. So this calculation again, half multiplied by, 2 first, multiplied by the area of that is made up of a half, multiplied by the base of PR, multiplied by the height of MR. Okay, now we can just find this. So on top, if you like, we can just simplify that. And on top, we get a 75 over 2. I will just give it as a decimal because it'll be easier to just divide like that. 37.5 over, here we're just saying 2 multiplied by a half times PR. Remember, that was 15. We already have those lengths. We know PR is 15 and MR is 5. So multiplied by 15 multiplied by 5. Then you can just put this all onto the calculator. So let's see what we get. So I'm putting a fraction for this full thing. Then we have 37.5. This is going to definitely be double because you see we have the exact same thing here and we're saying 2 times. So it's probably going to simplify to a half, but okay. We can say over 2 bracket a half. Then we're saying multiplied by 15, multiplied by 5. And so, yeah, so we get a half or 0.5. The ratio of it is 1 over 2. And that's our final answer. Okay, so that is the last question for that. So as you can see, because this is now 5 units and because we're sharing a base, it ends up being a case where this triangle is really repeated 3 times. That triangle has the same area as this triangle, which has the same area as that triangle. We are on question 3. And question 3 says, in the diagram below, we have A, which is -1 and 4. And then we have B, which is P and -2, and C are vertices of triangle ABC. And then they tell us that E is the y-intercept of this line AB. So if you have the equation of this line, you can find E. And then they also tell us that F, which is 0 and -4, is the midpoint of BC. And we have the angles of inclination of AB and AC are 135 degrees and alpha, respectively. The first question is to calculate the gradient of AB. Okay, let's look at the line of AB, A to B. Do you see that B is missing? So there's no way you can find the gradient by using the gradient formula. However, you see that we have 135 degrees. That is the angle of inclination of AB. And we can actually use that to find that gradient. So this is what we can do. You can say the equation for the angle of inclination is tan theta must be equal to your gradient. And the theta that is referred to here is the angle of inclination of that line. So of that line AB, which we can see over there, is 135 degrees. So it means we can substitute that there. So to find the gradient, you're just going to say tan of 135 degrees. Now, you can go ahead and reduce this using your trig reductions. So this means that your gradient is tan, and 135 degrees falls within the second quadrant, which is where you have 180 degrees minus theta. And this is, of course, sine's quadrant, right? So when you're reducing it, you're really saying 180 degrees minus what angle gives you 135 degrees. And that's going to be 180 degrees plus or minus 45 degrees, right? And then if you reduce this, because this is in sine's quadrant, it's going to become negative. So our gradient is negative tan of 45 degrees. And you can use your calculator, but tan 45 degrees is always going to be equal to 1. So this means that the gradient here is -1. Okay, so that is our answer. The gradient is -1. Moving on to the next question. Then the next question is, show that the value of P is 5. Very simple. Since we have the gradient of AB, right? Because you see that P comes from this line where AB is. We have the gradient of this line. Okay, to find P, all you would have to do is use your gradient formula. It's the only thing missing. So we can go ahead and say, okay, the gradient of AB is found by saying y2 minus y1 over x2 minus x1. That's all we have to say here. Now we already know the gradient, so we can substitute that in place of gradient. And then y2 minus y1, we can just go ahead and say -2 minus the 4, so -2 minus 4 over, and then x2 minus x1, that is the p minus -1. And of course, if you say p minus -1, they multiply and become a plus, so that's p plus 1. So when you simplify this, you get -1. I'll just continue writing here. There's no use going to another page. So -1 equals, and that subtract -2 minus 4 is -6. You have p plus 1. Let's just go ahead and cross multiply. It's just easier in this case. So -1 times the p plus 1. Remember, -1 multiplies to p, giving you a negative p. -1 must also multiply to +1, giving you a -1. And then here you have a denominator of 1, and that multiplies with your -6, giving you a -6. And then we can take negative p over to make it positive. And then we'll take our -6 over to make that positive, and you still have a -1 here. So that's 6 minus 1, and therefore P is equal to 5. There we go. Okay, so because it's the only thing missing, we could actually use that to find that. Okay, moving on to the next question. The next question says, calculate the coordinates of C. Okay, let's just put that we know P now. P is 5, so 5 and -2 there. They want us to find C. Well, what do we know about C? We know that C is part of this line that they told us the midpoint is F, okay? Since we already have the midpoint of this line, okay, and we're looking for C, we can just go ahead and call C X and Y. and then use the midpoint formula to actually find this. So we have the midpoint of this, okay, of CB or BC. Let's call it that. So we have the midpoint already of BC. B is that point 5 now and -2. And then C is the point we don't have. But the midpoint of BC, we have this already. This is F. That's what they told us. They told us F is the midpoint. That's why these two are equal. So we're going to keep that in mind and say, okay, the midpoint is already 0 and -4. And let's use this to actually find it. So we're using the equation of midpoint. So midpoint is equal to, you don't have to say equal to, but it's fine. X1 plus X2 over 2. And then Y1 plus Y2 over 2. Remember, grade 12s, this is in your formula sheet, okay? And then we're going to go ahead and say, well, we already know the midpoint of this. It is this. It is 0 and -4. And this is equal to, now here, this is how we would find the midpoint, by using this calculation. However, we do already have the midpoint, okay? So it means that you can take that as your x1. I just want to put the x first, that's why. And then I'll take that as my x2. And that's my y1 and my y2. So this is us calculating the midpoints, but we already have it though. So to calculate this, we'll say x1. And the x1 here is x. So we're saying x plus x2, which is 5 over 2. And then y1, which is y, plus -2, which becomes a -2, okay, over 2. So on one side, you have the calculation for the midpoint of BC. On the other side, you have the actual midpoint of BC. This means that they are actually the exact same thing, okay? Because if you actually calculated this, if you had x and y, you would have the exact same point since they're the same thing. And so what we're going to do is equate the x values. We'll tell them that 0, the x value of 0 here should be equal to the x value here, which is x plus 5 over 2. And the y value of -4 should be equal to the y value over here, y minus 2 over 2. Okay, let's go ahead and simplify. So you have over 2 here. You can just cross multiply, it's fine. So put this over 1. 0 times 2 stays 0. And then 1 times x plus 5 is x plus 5. Okay, so x plus 5 is equal to 0. And then you take your 5 over. So x is equal to -5. And then the y value, okay, you can also just cross multiply. So put this over 1 and then cross multiply. So that multiplies. 1 times anything stays exactly the same. -2 times 2 is -8. Then you can take your -2 over. So that's y equals, it becomes a +2 minus 8. And +2 minus 8 is going to give you a -6. So you see that C, now the coordinates of C are -5 and -6. Okay, and that is that answer. We can also fill that in our diagram so that we know we have -5 and -6. Okay, moving on to the next question. 3.4 says, determine the equation of AC in the form of y equals mx plus c. So that's 3.4. We have to find the equation of AC. Well, we have everything. We have A and we have C. So we just have to use the equation of a straight line to find this. So let me put down the coordinates and then we can go ahead and find this. Okay, so here are our coordinates and we can find the equation of AC. So let's go ahead and find the gradient first. So the gradient is equal to y2 minus y1. I'm not going to write the formula again because we already have it. So y2 is -6 minus 4 over, and then the x2 and x1. So that's -5 minus -1, which becomes a +1, of course. Okay, so you can use your calculator to simplify that. When you simplify that, that gives you a -10, right? And that gives you, that's like saying 1 minus 5, which is -4. And you see that they will both become positive and they both have a common factor of 2. So if you divide 10 by 2, you get 5, and you divide 4 by 2, you get 2. So that is your answer. Okay, our answer is 5 over 2 as our gradient. And then we just have to find the equation. So you can use the y equals mx plus c, substitute, then find your c, and then put it in your equation. Or you can use this. The y minus y1 is equal to your gradient, which I have, all right? and then x minus x1. Now you just leave it as m for now. So, and then x minus x1. Okay, now let's go ahead and substitute. With this, you just need the gradient and 1 point. Try to take the simplest point. I'll take the -1 and 4. So that is our x1 and our y1. So y minus y1, and our y1 is 4, and is equal to 5/2 multiplied by x minus your x1, which is -1. So if you multiply, of course, that becomes a +1. Then just simplify. So this is, I start here, 5/2x. When you multiply that becomes a +5/2. And then your -4 comes over and becomes a +4. Then we can leave the y here. Okay, then we just have to add those. So y equals 5/2x. And let's see how we're going to add this. So put this over 1. Then just make the denominators the same, or you could just use a calculator. So that becomes 8. So it's saying 8 plus 5, which is 13. And then over 2. So that's our answer. Our answer is 5/2x plus 13/2, and that is our final answer. Okay, moving on to the next question. In the next question, they want us to find or calculate the size of angle CAB. So let's look at our diagram to understand where exactly that is. So CAB. So it's this angle over here. So normally when I'm calculating the size of an angle in analytical geometry, I usually like to extend the lines and then find out exactly how that was created. But in this one, I'm going to take a different approach. So with this, and the reason I'm taking a different approach is because this diagram actually just works well for it. I want you to look at this as, look at your triangle. You have this triangle over here, right? This is a triangle that you have. And do you see that if you extend like this, 135 degrees is your exterior angle of this green triangle highlighted. So it would mean that if you add this angle CAB, and you add the angle alpha, you're going to actually get that. So in order to find this over here, all you need is alpha. And I'm going to actually focus on getting that. And here's the reason why. You see, the previous question asked us to find the equation of this line. So because we have the equation of this line, we also have its gradient. So we can actually find its angle of inclination. So let's find the angle of inclination here, that size of alpha, and it will help us find our CAB. Okay, so we have the gradient of AC. Let's go ahead and say that to find that angle of inclination, we say tan theta, I'll just say alpha in this case because we know what that is equal to our gradient of AC. And we know that the gradient of AC is 5/2. So 5/2. Then it means that alpha is equal to shift tan, or the second function of tan, 5/2. And it gives us this, okay? So in this case, I would actually say it's fine. You can round off to 2 decimal places because you see the other angle you're working with is 135 degrees, which is already a whole number. So you don't have to really worry about decimals here. So 68 point, and then that rounds up to a 1, and then that rounds up to a 2. Okay, so that just becomes, let's just put it in 2 decimal form. So 20 degrees, right? That's what we have there. So since we have alpha now, we can actually use this here. So it's saying that this is 68.20 degrees. And in a triangle, we know that the exterior angle is equal to the sum of the 2 opposite interior angles. So it means if you take angle CAB plus alpha, it must give you 135 degrees. And that's exactly what we're going to write. So CAB, right, plus that 68.20 degrees should give us our exterior angle of 135 degrees. You don't really need reasons. You can if you want, but that's really just because this is not Euclidean geometry. They don't really ask for reasons. Then let's go ahead and solve for CAB. Okay, so that's 135 degrees minus 68.20 degrees, and that would just be our answer there. So the answer we get is 66.8. So that is our final answer in this question. Okay, moving on to the next question. The next question, 3.6, says calculate the area of triangle BEF. Okay, so let's go ahead and look at that triangle BEF. Okay, so it's this triangle. I'll highlight it in blue. So BEF is going from B to E to F. So this is the triangle they're referring to. And we have to find the area of this triangle. Okay, remember that you have two area rules. Okay, you have the one where you don't have a perpendicular height, and you have the one where you have a perpendicular height. Okay, so let's just see which one would suit this. Also, just remember the mark allocation for this question. It's only 3 marks. Okay, so it's not really a long thing that we have to do. So let's think about it like this. So before actually using the formula for the area of a triangle without a perpendicular height, you need to first make sure that the one with a perpendicular height can be used. Okay, you have to try and check whether it can be used or not. It's better to do that way. So let's look at this. Does it have a perpendicular height? Well, not one that they indicate. However, we are at an advantage here because do you see that we can treat this as the base? EF can be our base. And because it is on the y-axis, we can see that this is a vertical line. Okay, so it's not slanted in any way. It's perfectly flat. So to find a perpendicular height, we would have to go to the highest point of this triangle. So kind of tilt your head this way, and you're looking at this as if this is the base of the triangle. What would be the highest point of the triangle? It would be B. So if you go from B and you are going to draw a horizontal line, right, to the y-axis, that would serve as your perpendicular height. Okay. Now, for us to actually use it like that, we need to ensure that we actually take the correct height here. Because B is the highest point and it's 5 and -2, it means that from the y-axis, or really the origin, okay, you can look at it from the y-axis really, you went exactly 5 units to the right to get to B. So it would mean that this perpendicular height is exactly 5 units. As you can see, it's a horizontal line. So we have a perpendicular height. We have a height, and then all we would need is a base. So the base is E all the way to F. If you say the y value of E minus the y value of F, you will find it. Okay, so we can actually use this method. So E, as you can see, is on your y-axis. Because it's on your y-axis, it's the y-intercept of this line AB. What do we know about that line AB? Do we have the equation of it? Okay, we don't have the equation of AB. However, we can actually find it easily. So because we already have the gradient of AB, we can actually use that. So remember, that was the first question they asked. The gradient of AB is -1. And you have a point on AB. You have 2 points, in fact, that you can use. I'm just going to go ahead and use -1 and 4 as my points to substitute to find the equation of AB so that I can find the y-intercept. That's the whole point. I just want to find C because y equals mx plus c. Okay, let's go ahead and do that. So with AB, we have the gradient of AB. So we can say that the gradient of AB, we already know, is equal to -1. And we have a point on AB, which is A, and that was -1 and 4. So we're saying y minus y1, which I'm just going to substitute in already, is 4, is equal to our gradient, which is -1, and then x minus x1, which is a -1, so that becomes a +1. So when you simplify, this is y equals -x minus 1, and take your -4 over to become a +4. And then y equals, we have -x, and 4 minus 1 is +3. Okay, so there, we know the y-intercept now. Since this is the equation of AB, the y-intercept is +3. So that is that y-intercept that we were looking for, E. That is +3. Okay, you can say 0 and +3. So since we know what that is, we can actually find that base now. So E is 0 and +3. Therefore, the base of our triangle, okay, I'll just call it a base, B equals, and we can find that by saying, since this is the base, if you tilt your head like that, you're going to say the y2, the highest y value minus the lowest y value. So that is 3 minus -4. Okay, so we have 3 minus -4 there, which is really just 3 plus 4, and so our base is 7. Now remember our perpendicular height that we needed, we already found that. We found that to be 5 units, okay? Because it is a horizontal line, it's perpendicular to the y-axis, which is a vertical line. So we have 5 units there as our height. So we can actually find this area. So the area of this triangle, which is BEF is going to be equal to a half multiplied by our base of 7 multiplied by our perpendicular height of 5, which is equal to 7 times 5 is 35. So 35 times a half is just 35 over 2, which you can put in decimal form. In decimal form, 30 divided by 2 is 15. 5 divided by 2 is 2.5. So that is 17.5. So 17.5. And because these are in units, the area is in units squared. So that is our final answer for that question. And then we move on to the last question in question 3. Okay, last question 3.7, of course, in question 3 says another point K, which is T and T, where T is less than 0, is plotted such that AK is equal to 5 square root 5. We need to calculate the coordinates of T. Okay, so they tell us what T is. T is less than 0. They don't give us the value yet, of course. They want us to find exactly what the coordinates of K is, since we know it's T and T. So since this is negative, if you have a point and it's T, and they're both negative, it just means that it's on the negative part of the x-axis and the negative part of the y-axis. So that is going to lie in the third quadrant. Okay, so that's where that point is going to lie first of all. So let's go ahead and just use our diagram. So we have a point T, okay, in the third quadrant. So wherever it is, it's the exact same distance. So if you go T units this side, you're also going to go T units that side. So wherever it is, maybe it's just like here, right? The information that they give us is that AK, so A to K, that is 5 square root 5. And we have to find T. So you see that they give you the distance of AK. So we have to use the distance formula. So the distance formula, okay, for AK, you're going to say the square root of x2 minus x1 all squared plus y2 minus y1 all squared. And that would give us the distance, right? But we already know the distance. The distance of this line is 5 root 5, okay? And so we're going to say square root, and let's just take this as x1 and that as x2. That is y1 and that is y2. So we're just saying T minus, and our first x value is -1, so that's -1 squared. I'll just put plus 1 because it multiplies. Then plus, and we have y2, which is T again, and minus the y2, which is 4. So you see that you just have to solve for T, which is not going to be complicated because it's the same variable you're using. It's not like X and Y or P and Q. Okay, so let's go ahead and solve for T. So the first issue that we have here is, of course, our square roots. So we need to get rid of those by squaring both sides of the equation. And when we square this side of the equation, you see that your 5 would get squared because these two are sitting together because they're being multiplied. The 5 gets squared and becomes a 25. The root 5 gets squared, and what happens when a root gets squared is that that square root cancels. So that will become a 5 on its own. So it's been multiplied by 5 is equal to, and here your square root breaks open, and you're left with what is inside, which is the T plus, and I can also just go ahead and distribute. So T plus 1 all squared, square the T, that gives you T squared. Then square the 1, which gives you positive 1. Then say T times 1, which gives you T, and multiply that by 2, which gives you positive 2T. Okay, do the same thing over here. Square the T, gives you positive T squared. Square the -4, gives you positive 16. T times -4 is -4T, and multiply by 2 to give you -8T. Okay, that's how to distribute those quickly instead of writing into brackets and then multiplying those. Those take long, and when you take longer steps, it is easier to make mistakes. So we're multiplying here. 25 times 5 is 125, which is equal to t squared plus t squared is 2t squared. Then the positive 2t minus 8t gives you negative 6t. And then positive 1 plus 16 is positive 17. Okay, we still have our 125, so we can take that over. So 0 equals 2t squared minus 6t plus 17 minus 125. So what is 17? I'll just calculate it here on my calculator. 17 minus 125 is negative 108. Okay, so we have that. Now we have to actually just factorize this and solve for t. Do you notice that each number, okay, or each value has a common factor of 2? Is common factor of 2 all through. So we can actually just divide by 2 on both sides of the equation to get rid of this common factor. So divide by 2 and divide by 2. So it means that 0 divided by 2 is 0 is equal to 2t squared divided by 2 is t squared, and then we have minus 3t, and then 108, 100 divided by 2 is 50, 8 divided by 2 is 4, so that is 54. Negative 54 is what we have over there. And now we just have to actually factorize this. So let's go ahead and factorize. You can use the quick method if you want, it's fine. So that's t multiplied by t, and factors of 54. Okay, so I know 1 would not work. 2 would definitely not work. We're going to have to use bigger factors. So I want to just show you quicker ways to work with this. Make sure you go in order. So we're looking for factors of 54. So what times what gives you 54, right? But those numbers should also give you negative 3. The first thing we need to note is that because 54 is actually negative, one of your factors should be negative, the other should be positive. So I'm going to divide 54 by various numbers. 1 would obviously not work, neither would 2, because you see, 2 and 27 can never give you negative 3. Okay, 3, clearly too small. 4, nope, that doesn't even work at all, it's not a factor. 5, of course, is not a factor. 6 and 9, that looks more promising. So we can use 6 and 9. So we're going to take the 6 and the 9. Now decide which one should be negative so that you have a negative 3 in the middle. Okay, you want it to remain negative, so give the negative to the bigger number. Okay, so that is negative 9 and plus 6. If you multiply those, they give you negative 54, but 6 minus 9 is in fact negative 3. Okay, so those are our factors, and then we're solving for t. It means that t is either equal to, when you take that over, it becomes a positive 9, or t is equal to, when you take that over, it becomes a negative 6. Now, here's how we find out what exactly t is. Do you remember in the beginning here, right, in the beginning of this question, they told you that t must be less than 0, okay? Because we know where t is sitting. So it means that t is actually the negative 1. So don't take the 9. Take this. T is equal to negative 6. Okay, and that makes perfect sense. The reason you're getting 2 answers is because they're really just saying from A, right? You can actually have 2 points that will have this exact same distance, which is very possible. So you can have another line that's the exact same 5 root 5 distance, okay, over there. But that point, right, its value would have been 9 and 9. Okay, so now that we have that, we need to just conclude. K is finally equal to, so the coordinates of K, T, and T is negative 6 and negative 6. And there we go. So that's our final answer. And we finally move on to question 4. Okay, so we are on question 4. And question 4 says, in the diagram below, the circle centered at M is, we have this point negative 2 and 3. Okay, so we have a circle centered at M, and it passes through A, which is 1 and negative 1, and C, which they do not give us over there. Then they tell us that BA and BC are tangents to the circle at A and C. So those are very important. We have tangents over there, respectively, with BC parallel to the y-axis. Okay, so this line is also parallel to the y-axis. And the first question is determine the equation of the circle in the form of, and that is in the form of an equation of a circle. So what we're going to do with this equation, just remember what these points stand for. Your A and your B, remember, those are the coordinates of the center of the circle, okay? And then the x and y, you can leave those open, but of course we're going to have to substitute values in it so that we can find r squared. Okay, so in place of x and y, you're just going to find a point that actually lies on the circle. So let's go. We're going to say, first of all, x minus, and our A, the center point, that is A over here, and this is B, since these are the coordinates of the center of the circle. So that's A and B. So that's x minus -2, so minus -2, which of course becomes a positive 2, all squared, plus y minus, and we have a 3 there. So y minus 3, which is our B, is equal to r squared. So you see now that r squared is the only thing missing. So to find that, you have to substitute a point so that those are filled, and we'll be able to find exactly what r squared is. So let's go ahead and find a point that lies on this circle, which would be A. So that is our x and our y value. So substitute 1 and -1. So we are saying 1 plus 2 all squared plus -1 minus 3 all squared. Sorry about that. I forgot that squared. Is equal to r squared. Okay, so let's go ahead and substitute this onto the calculator just to make things quicker. And so you see that r squared is equal to 25, which is equal to r squared. Okay, so there we go. We found r squared, and so that means that the equation of the circle is x plus 2 squared. Okay, we're just using this one because r squared was the only thing missing here, plus y minus 3 squared is equal to 25, and that is the equation of our circle. Okay, moving on to the next question. The next question, 4.2, says write down the coordinates of C. Okay, so we need to find the coordinates of C. Okay, so the only thing we're told about that is we have BA and BC, which are tangents to the circle. So these are tangents to the circle. Well, that would also mean that they are equal in length. I don't think that's important here, but it's good to take note of that. And what else they say? Since it's a tangent, okay, we can actually use something here. So we can use something from Euclid here. Do you remember that if you have a center of a circle, right, and you're going from the center of the circle to the circumference, then that is a radius, okay? So center to the circumference. But there's something we know about the radius and a tangent to a circle, okay? The radius and the tangent are always perpendicular at the point of contact. So what that would actually mean is, you see this line MC or CM? That line is actually parallel to the x-axis, making it a horizontal line, okay? And it's parallel to the x-axis, of course, because it is perpendicular to this line, which is parallel to the y-axis. So we have a horizontal line here. Now, why is that important? That's very helpful because that can actually help us to find a specific coordinate of C. So we have an x and a y coordinate, right? But are you thinking about this? If this is a horizontal line, it means that whatever y value this is, which is 3, so on the y-axis, this is where 3 is, it means that this point C has the exact same y value. So now do you see that the only thing we have to find is this x value over here? And that's what we're going to go ahead and do. So how do we find the x value? We found the equation of this circle. And do you see that this is r squared? If r squared is equal to 25, what is the radius? And I think this is how we can actually find it. What is the radius going to be? So r squared equals 25. It means that the radius, if you square root both sides, r would be equal to 5. You don't have to say plus or minus because it's a radius, which is a distance and can never be negative. So here's why I say that's important. You see, you know this is 3 already. You just want to find out exactly what C is. There's another thing we know here. We know exactly what x value is here. The x value here is -2 because this is the middle. Went -2 and 3 units up to get that point M. So this is -2 over here. But you know the radius, right? You know that the length of the radius is 5 units. If the length of this radius is 5 units, it means you're just going on the x-axis from -2, and then you're going 5 units to the left to get to C. Okay, because that is the distance of the radius. That is 5 units. And that's how we can actually find that. So -2, 5 units to the left, that's -5. And that would give you that value over there. So I'm going to find x by saying x is going to be equal to -2 minus the 5 units, going 5 units to the left, and that gives us -7. Okay, I already knew that the y value was 3, and I think I should have said that in the beginning. So I already knew the y value was 3 because of that being perpendicular. Okay, I don't think we need to say that, but we can tell them that CM is perpendicular to BC. Okay, and therefore it means that the y value was 3. And so it means that C, the coordinates of C, is really just -7 and 3. And there we go. And that's how we find those. Okay, so remember, we already knew the distance of the radius. So we know we're going from -2, 5 units to the left to give you -7. And we know this is 3 because of those are perpendicular. So this is a horizontal line. They share the same y value. Okay, so that is it for that question. It's a 2-mark question. So yeah, it's a good thing I went through this route because that is really all we need to do. You don't have to overthink this one. Okay, moving on to the next question. The next question, 4.3, says determine the equation of the tangent AB in the form of y equals mx plus c. Okay, let's look at AB. So AB is this. Do we have anything about it? We need to keep filling in things. So that is -7, and I'm just going to erase these because we don't really need those there. Okay, so AB, to find the equation of AB. Well, we don't have B, but we do have A. And we know the radius, right? We know what the radius, well, we know the length of the radius, but we have coordinates to actually calculate this gradient of this radius, okay? The gradient of that. And the reason why this is important is because, again, this is a tangent. And you know that your tangent, let me actually make that red as well. You know that the tangent and the radius is always perpendicular at the point of contact. So it means that if you find the gradient of this, because these two lines are perpendicular, the gradient of AB multiplied by the gradient of your radius, AM, when you multiply them, they must give you -1. So that's how we can actually find that gradient of AB so that we can find the equation of AB. Okay, let's go ahead and do that. So I'm going to take A and M, those coordinates down, so that we can go ahead and find that gradient of the tangent. So here's A and M. So we'll find the gradient of AM. Remember, AM is just our radius. We're just finding the gradient of that first. So that is y2 minus y1 over x2 minus x1, which is equal to, and so we're saying 3 minus -1, which becomes a +1, over -2 minus, and that's just a 1. And so the gradient of AM is equal to, that gives you 4 over -3. Okay, so it means that if you wanted to find the gradient of AB, which we know is perpendicular, okay, to AM, you're going to multiply those. But here's a quick way to find it. You see, ultimately what we're actually doing is you're just swapping the numerator and the denominator, and then you're multiplying that by -1. That's really all we're doing there. So it means that the gradient here would be +3 over 4. And that's what we're really just doing the whole time when we are working with those perpendicular lines. So we know the gradient of AB. We also have 1 point on AB, which is more than enough for us to find the equation of this line. So we're going to use A, and I'm going to use that quick straight line formula. So y minus y1 Okay, so here's our A. I'll take this is my x1 and that is my y1. So I'm not writing the full equation because I've already written it in the previous question. Okay, so y minus y1, y1 is -1. So that becomes minus -1, which of course will become a positive 1, is equal to our gradient, which is 3 over 4, multiplied by x minus x1, and x1 is just 1. Then we just have to simplify. So this is equal to 3 over 4x when we distribute, and minus 3 over 4. Then we take our positive 1 over and becomes a -1, and we have y here. So y is finally equal to 3 over 4x, and you have to subtract. You see, 1 can be written as -4 over 4, that -1, right? And so numerator minus numerator, that's -3 minus 4, which gives you -7 over 4. The denominator stays the same since we are subtracting. And that is our answer. So that is the equation of that line AB. Okay, moving on to the next question. Okay, 4.4 says determine the length of BC. Let's go ahead and see what BC looks like. They want us to find the length of BC. Now here, this is a vertical line, right? So with vertical lines, you just have to take the y value, because it's a y value. Take the y value of the highest point, and if you subtract it by the y value of the lowest point, you're going to end up with the distance of that line. So all we have to find is the y value of B. That's our goal, because we already have the y value of C. It's 3. We know exactly what that is already. So let's go ahead and find the y value of B. And how can we find that? Well, we have the equation of this line, right? We just found it. We found the equation of this line to be 3 over 4x minus 7 over 4. And we also know that this is a vertical line. So do you see that C has an x value of -7? Because it's a vertical line, it's not moving anywhere like left or right. It's just perfectly straight like that. So it would mean that B will also have that exact same x value as well. So B is -7 and something else, a y value. Okay. And here's the thing. Because we have the equation of that line and we have an x value, why don't we just substitute that x value in here to find its y value? Okay, so that's what we're going to do. So I'll first of all tell them that I found that the x coordinate of B was -7, right? And I have the equation of that line that we just found, that AB. So I'm just going to substitute to find the y value. So we're saying y is equal to 3 over 4. And in place of x, we're substituting our -7. And then minus 7 over 4. And I'm just going to go ahead and use a calculator because it's not really necessary to just calculate it with hand. And we have -7. Okay, so the coordinate there for B is actually -7 and -7. Okay, so that is at the x and the y coordinates. Okay, so that is it for that question. Moving on to the next question. Then question 4.5 says, determine the equation of the circle centered at A that has both x and y axis as tangents. Okay, interesting. So we have to determine the equation of the circle centered at A. So this is where A is. We have A over here. And let me just get rid of every other thing. Okay, I just decided to copy this because I don't want to keep scrolling up. So we have to determine the equation of the circle centered at A. Okay, I should have gotten rid of that. But we have a circle, right, centered at A. And the only thing they tell us about the circle is that the x and the y axis are tangents to that circle. Okay, so it's really not a complicated thing. We just have to think about it like this. So we have x and y axis being tangents. You see, the minute something is a tangent to a circle, it means that the circle is going to have contact with it, right? If you know that this is the center and the tangent is going to have contact with the x and the y axis, then it means your circle kind of just looks something like this, right? And then it's just perfectly touching the x and y axis. And then the center is there. Okay, so something like that. So we have to determine the equation of this circle centered like that. Well, this is already hinting at a lot of things. We can actually find the radius of this circle, first of all, because we know that this circle, it has a center at this, and then it touches the x-axis. We can actually find it like that. So here, this point is 1 and -1, meaning when you are at the origin, you must have gone 1 unit to the right, right? That's 1. And then you went -1 units down. That is already telling you the length of your radius, because if you're going 1 unit to the right to get to the center, look at it like this. Imagine I was here and I went 1 unit to the right. I already know that the radius, the length of the radius is 1 unit. Okay, if you didn't see it like that, see it as when 1 unit to the right, and then now you're touching, okay, the circle or the circumference of the circle, and then you went 1 unit down. So we can already see that the length of that radius is 1 unit. Okay, so we have the radius, it's 1 unit, and we have the center. That's all we need. So instead of taking this as x and y, we're going to use it as a and b. We just need the formula of the equation of a circle, which is, we already had that there, x minus a all squared plus y minus b all squared equals r squared. Okay, so x minus our a value is 1 minus 1 squared plus y minus our b value is -1, and that becomes plus 1 all squared is equal to our r squared is 1. So 1 squared gives you 1. And that's the equation of your circle centered at A if the x and the y axis are tangents to that circle. Okay, so that is 4.5. Then moving on to 4.6, which is the last question for question 4 and for analytical geometry. Okay, we're on question 4.6, and it says, if another circle with center N, which is P and 3, and a radius of 4 intersects the circle centered at M at 2 distinct points, determine all the possible values of P. Okay, so we're going to need the diagram in this situation. So let me get the diagram. Okay, here is our diagram. And what they're saying is, if we have another circle, so I don't know what that circle looks like, but we have another circle and its center is N, which is P and 3. So that is actually a very interesting point, because we know that we have points here with 3. Even C had a 3. C's point was -7 and 3, right? So it has a y value of 3. So -7 and 3. So if that circle has a y value of, its center has a y value of 3, then it means that that circle, right, the center is horizontally in line with this circle center as well. So that's what we're going to have. We're going to have that circle somewhere. But what they told us is that this circle has a radius of 4 units, and it's going to intersect this circle at M at 2 distinct points. So it needs to intersect at 2 distinct points. So we have to now determine all the possible values of P for which this can actually happen. So what should be the values of P for another circle with a center N to intersect with this circle at 2 points? That's really the question. Okay, let's go ahead and see how we can actually construct this. So first of all, I don't know what that circle looks like. So it could be a bigger circle. We'll see, right? Let's just say we had a circle, and let's just read more into it to see what exactly the circle looks like. They told us that its center is at P and 3. So it is horizontally in line, okay? So it's not going to be like lower or higher. It's just in line like that. So what we have is that the radius is 4 units. Okay, so that helps us a lot. Do you remember this circle centered at M? What was the radius of that circle? The radius of that circle, which we already saw in the previous questions really, is 5 units, because we know that when we found the equation of that circle, we had that, well, there it is, okay? We had the 25. R squared is equal to 25, so the radius is 5 units. So we know that this circle that they're referring to is smaller than the circle centered at M. So because its radius is 4 units. So let's say it's something like this. And what we need to ensure is that this circle intersects the other circle at 2 distinct points. So I can actually see 2 places that this circle can actually be. It can either be here on the right, Okay, so the reason why is because let's just say it is in line, right? And we have our P over here, the center of it. So N, I mean, right? Which is P and 3. So it's in line, horizontally in line. What happens here is that if this circle has to intersect the bigger circle at two distinct places, it needs to move to the left. So there, it starts intersecting at two distinct places, two places again, two places again, and it will keep intersecting at two places as we keep moving it until it gets to this point. Then it stops intersecting at two places. It only intersects at one place. And if you move it further, it doesn't intersect at all. So we need it to intersect at two places. So that's what I mean by there's this place here that you can put it, but there's also this place. Because you see, the thing is, they didn't tell us what P is. They didn't tell us that P is positive or negative. So we don't know that. They didn't tell us that it's in the first quadrant or anything like that. So it could also be here. You could also have it here. Okay. But I think it's better to deal with this case first, and then we'll work on that second case. Honestly speaking, with this, I don't think we need any formulas. It doesn't look like a kind of question that needs formulas. We really just have to work with what they've given us. Remember how I said that the radius of this circle is 5 units. That is going to be very helpful. So let's just watch how this thing moves and see how we can manipulate P so that it always intersects with this circle at two places. Okay, so let's go ahead and move this. So here, it doesn't intersect at two places, it intersects at one place. And then when we move it to the left, in other words, when P, right, whatever P is right now, if P becomes a value lower than that, then it starts intersecting at two places. So the first goal we have is to find out what exactly is P at this point. What exactly would P be when your two circles are only intersecting at one place? Okay, so let's find that. We can actually find that here. And how we can find that is this. Do you see that we know the radius of this? So then we know this is 5 units. And we know this is negative 2 and 3. So it means that over here we've got our negative 2. And we know that 5 units away is our radius. So if you count the distance here, this is 5 units. So we can find out where exactly these two intersect. So 5 units away from this point, negative 2, would be negative 2 and then plus 5 because we're moving to the right. So that is going to be positive 3 that we have over here. Okay, we have positive 3. Now, what do we know about the smaller circle? Well, don't we know its radius? We know its radius. We know the radius is 4 units. So for you to get from the circumference, because this is where they both meet, its circumference to its center, you're just going to calculate the distance of 4 units. So you're going from 3 and you're moving 4 units to the right. So that's 3 plus 4, which gives you 7. So we know exactly where they intersect. Okay, that's good. So we know that P, first of all, just need to be values that are less than 7, because the minute P is less than 7, it starts intersecting at two places. See, less than 7 intersects at two places. But we can't just say P is just less than 7 and we just keep going. That's not going to work. If you keep moving this and we say it's less than 7, where do we stop? Because if you keep moving and just P being less than 7, at some point it doesn't even intersect anymore. It's not intersecting at all. So the last place we should move it is to this point, because you see here, it's still intersecting at two places. And we just need to let it sit on the other circle. This is the last place they intersect. So it needs to be less than 7, but it shouldn't go beyond this. So remember, just focus on what exactly P stands for. P is the center of that circle. It was the center of the circle here. It's still the center of the circle here. So we still need to find out what exactly the center of this blue circle is. The center of that blue circle, not so difficult to find, because now we know this is 3. We know that they will both touch at this point here where x is equal to 3. And we know that this radius, the radius of the blue circle, is 4 units. So just go from 3 and go 4 units to the left. So that is 3 minus 4. And if you go 3 minus 4, what do we get? So 3 minus 4 gives you negative 1. That means that the center of the blue circle is now going to be here at negative 1. So what that means is our P values, what they need to be for this circle to always intersect with this circle at two distinct places, is P needs to be less than 7. So we're like this, needs to be all values that are less than 7, but it should not go anything beyond -1. That p-value, the center of that circle. How we can write that is like this. We can actually say that p needs to be greater, because it shouldn't go anything beyond -1, right? Meaning it needs to be values that are bigger than -1. So greater than -1, but less than 7. Okay, and that will be the first part. That is if the circle was actually on the right-hand side. So I'll put that down because that is definitely a solution. That is p needs to be greater than -1, but less than 7. Then I'm going to say or, because this doesn't only happen here. So I'll leave the circle here just so that we remember how that worked out. And let's take this and also just copy and paste it here. So it could have also happened here as well. In the same way, see, if we can figure that one out, this one shouldn't be difficult to figure out. So it can also intersect with this circle at 2 distinct places here. So when we have it here right now, we don't exactly know what the center is, because once we start moving it to the left, it starts intersecting at 2 places like we wanted to. So we need to find out what exactly the center is at this point. The center of this circle, well, to find that, we can actually find that here, because we know what exactly the center of the bigger red circle is, right? The center of the big red circle is -2. And we know that its radius is 5 units. So go from -2 and go 5 units to the left. So that's -2 minus 5. And that's going to give us -7. So we know exactly what the x value is at the point that they meet. So it's at -7 that we have there. And then to find the center of this blue circle, we're going to go from -7, and we know that the radius of the smaller circle is 4 units. So we're just going 4 units to the left. That's -7 minus 4. And that gives you -11. So we know the center. That's good. And now that we know the center, we're saying that the center, the p value, because that's really what they're saying p is, they said the n, right, is the center of the smaller circle, which is p and 3. We're saying that our p value needs to be values that are, first of all, greater, because we're moving to the right-hand side this time, greater than -11. See, there, it intersects at 2 places, keeps intersecting at 2 places. Where should we stop? It keeps going, still intersecting at 2 places until it reaches here. And if you go anything beyond this, it's not even intersecting at all. So we need to stop here. So remember, we're trying to focus on the center of the blue circle. What exactly is the center of the blue circle at this point where this circle and the bigger circle circumference meet? So what exactly is that going to be? Well, we can find that because this circle, its radius, the blue circle's radius is 4 units. And we know they intersect at -7. So just go 4 units to the right. So that's -7 plus 4, which is going to give you -3. So that would be the center over here at -3. So it really just means we're taking the circle and we're moving it, right? It needs to have p values. The center needs to be values that are greater, because we're moving to the right, than -11, right? Greater than -11. Is it just greater than -11? No, because if you keep going, it doesn't intersect anymore. It needs to stop here. So greater than -11, but less than -3. It shouldn't go anything beyond -3, the p value, that center. So that would be our answer there. So or p needs to be values that are greater than -11 but less than -3. And that is our answer. We are on question 3, and question 3 says, in the figure we have L, S, and N, and we have their coordinates. Are the vertices of a triangle having angle SLN being 90 degrees? So that angle is 90 degrees over there. And then they tell us that LN intersects the x-axis at K. So we have an x-intercept over there. Okay, the first question is calculate the length of SL, leaving your answer in third form, so we don't have to round off here. Let's go ahead and find this. So to find the distance or the length of a line, we use this formula, which is in your formula sheet. So we're going to say x2 minus x1 all squared plus y2 minus y1 all squared. And we're going to have SL is equal to the square root of, let's just go ahead and find these. So this is SL. So we can look at that as x2, right? And y2. So that's going to be negative 4 minus 4 all squared. So negative 4 minus 4 squared plus, and we have 1 minus 5 all squared. And then you can just substitute this onto your calculator and get your answer. So SL is finally equal to, and leave it in third form. And in third form, that is 4 square root 5. And that is our answer. Moving on to the next question. So the next question says, calculate the gradient of Sn. So we just have to find the gradient. That's all. To find the gradient of a line, you say y2 minus y1 over x2 minus x1. So x2 minus x1. And so with Sn, see this is S and that's N. We can look at the bottom ones as the second points, okay? So x2 and y1. So we have y2 minus y1, which is negative 3 minus 5. So we're going to have negative 3 minus 5 over, and then the x's. So negative 2 minus 4. Negative 2 minus 4. And that will give us the gradient of Sn. Let's go ahead and calculate that. So if you say negative 3 minus 5, you get negative 8. And if you say negative 2 minus 4, you get negative 6. So our answer is going to be positive at the end of the day. The gradient of Sn is equal to, that becomes positive, but you see that they both have a common factor of 2. So 8 divided by 2 is 4, and 6 divided by 2 is 3. So that is our answer. Our answer is 4 over 3. Okay, so that is the gradient of Sn. Moving on to the next question. The next question says, calculate the size of theta, the angle of inclination of Sn. So because it's the angle of inclination, to find the angle of inclination, we always use this formula. We say that tan of theta, your angle of inclination, is equal to the gradient. So let's go ahead and have a look at what that line Sn looks like, and that theta really. So we can see that this is the line Sn is an increasing function. Okay, so the gradient is going to be positive. We already have the gradient. We are just trying to find that. That's all. So we don't have to think about adding any 180 degrees because the gradient is positive. We have the gradient of Sn already, so that's what we need there. So tan of theta is equal to, our gradient of Sn is 4 over 3, which we found in the previous question. So this is equal to, theta is finally equal to, we're leaving theta on its own, and we're going to take tan over. When you take tan over, it becomes the inverse of tan, which is the second function of tan, and you activate that on your calculator by saying shift tan. I'm going to say 4 over 3, and let's get the value for theta. So the answer here is shift tan of 4 over 3, which gives us 53 points, and we can round it to 2 decimal places here, 13 degrees. Okay, so that is our answer for theta. Moving on to the next question. The next question says, calculate the size of angle LNS. Let's go ahead and see how this angle was constructed so that we can actually find it. So LNS is this angle over here. Okay, let me actually just put that in a pen. So that angle over there. Okay, so looking at this, normally, well, not normally, but I was actually tempted to try and find this angle by using this. But I see that that is going to be a bad idea because we don't really have any other information. If we have this angle here, then we could have gone ahead and done that. But because we don't, I will not think about it like that. Here, we can think about it like this. So remember that to find an angle, right, you kind of just see how it was constructed. And to find out how an angle was constructed, you're going to have to relate it to an x-axis. So I'm going to redraw the x-axis. It looks like that. But I'm going to pull down the x-axis. I want the straighter one. So to pull down the x-axis to the point where this angle was created, which is right here at N. So we're going to move it down there so we can find out how exactly that angle was created. Do you see that to create this angle, if you go from this x-axis, this imaginary x-axis that we have here, you go from that x-axis all the way to this line, you're going to get this entire angle. Now, that angle would represent the angle of inclination of line LN. To find this one, if you take this entire angle and then you remove the angle of inclination, so going from the x-axis to this line over here, which is the line SN, right? Then you're going to get this little angle. If you take this bigger angle and you subtract it by that little angle, you will be left with the blue part. And that's how that angle is created. So now we know how we need to get that angle. You need to take the angle of inclination of the line LN and subtract that, okay, by the angle of inclination of the line SN, which we already have. That is 53.13 degrees. Let me leave it in green as well. So 53.13 degrees. So you see how that angle can appear here, but you can still draw it as another point as well, as long as you have an x-axis. So clearly all that's left to find this angle is this bigger angle over here, the angle of inclination of line LN. Now we don't have the gradient of that line, so clearly we need to find that first before we can find its angle of inclination. So let's go ahead and find the gradient of line LN. So here are our coordinates. So we're going to find the gradient of line LN, and I'm not going to use the formula because you would already have the formula on your page. So you can just go ahead and subtract. So we're saying y2 minus y1, which is -3 minus 1 over x2 minus x1, which is -2 minus -4. But when you distribute, that will become negative times negative is positive. So that's +4. Okay, so -3 minus 1 is -4. This is like saying +4 minus 2, which is +2. -4 over +2 is -2. So that is the gradient of LN. It's a negative gradient, so you need to remember what to do there. So when we're looking at that angle, angle of inclination of LN, do you see how big it is? It's actually an angle that goes past 90 degrees. It's not standing straight like that. It's not 90 degrees exactly. It looks like this. So it is an obtuse angle that we have over there. That's an obtuse angle. So we need to remember that rule with the 180 degrees. Let's go ahead and find the angle of inclination. So to find the angle of inclination, you say tan of the theta, but I'm going to call this theta of LN, so I remember which angle I'm speaking about, is equal to our gradient, which is -2. And to find that, we're going to go ahead and take the tan over. So let's leave theta of Ln alone. And we're going to find the second function, use the second function of tan. And we have -2. So remember, we need to do something here to make it an obtuse angle. If you just leave it like that, if you say shift tan of -2, do you see what it gives you? -63.43 degrees. And what it's actually doing is measuring backwards, because you presented a negative value. It's measuring like that. This size is the -63.43, but we needed to give us the obtuse. And so what we're going to do here is we will add a 180 degrees to this calculation. And the idea behind that is the size of this angle is exactly 63.43 degrees. Okay, the size of the angle. Remember, angles come in sizes. Yes, when we measure them in specific directions, they may be negative because angles are supposed to be measured anti-clockwise. But this angle is measured clockwise, and that's why it's negative. But ultimately, the size of the angle is 63.43 degrees. If you want to find this angle, it's like adding the angles on this straight line, and you know it should give you 180 degrees. Okay, so you're really just saying 63.43 degrees, right? Plus that angle you're looking for should give you 180 degrees. So to solve for that, you would say theta is equal to 180 degrees minus 63.43 degrees. Do you see that your 63.43 is a negative angle, just like it was here? When you say tan -2, shift tan -2, it gives you -63.43. And that's why we say plus 180, because our 180 degrees here would be positive. Okay, so that's a quick explanation why we do that. So we can go ahead and actually just add. So that's our angle there, plus 180 degrees. And so theta of Ln is equal to 116 point. I'm going to round off here. The reason why is because Do you see that we already have one of the answers we're going to use is already rounded off? So it's fine to round off here. It's not going to affect your answer. 57 degrees. Okay, so round up to 57 degrees. And now we finally have to find the thing we're looking for. The main thing we're looking for is this angle that they asked us to find over here, right? That angle LNS. So to find that, remember again, it's the larger angle, which is the angle of inclination of LN, minus the smaller angle, which is the angle of inclination of line SN. And we would find it like that. So that is the angle LNS. So we say LNS is found by taking the angle of inclination of LN, which is 116.57 degrees, minus the angle of inclination of SN, which is 53.13 degrees. So 53.13 degrees, and this is equal to, we'll just find the answer of this. And that gives us 63.44 degrees. That is LNS. That is our angle of that angle there. Okay, so that is our final answer. Do you see that it rounds off for you? If you just used that full answer, right? Like if you didn't round off that and you just use that as this entire thing, you would just need to round off at the end. But here, it's already rounded off since we rounded off that answer. Okay, done with that question, and we finally move on to the next question. The next question, 6.3, says, determine the equation of the line which passes through L, so passes through L and is parallel to SN. Write your answer in the form of y equals mx plus c. So it's going to have to pass through L, but is parallel to SN. So this line is parallel to SN. So this is SN. And if it's parallel to SN, it's going to look like this, but it's passing through L. So this is actually what it looks like that. And we have these being parallel. So what do you know about parallel lines? Parallel lines have the same gradient because they're slanted in the exact same way. So they have the same gradient. So we already have the gradient of this line. It's whatever the gradient of SN is. So its gradient already, we know that that is going to be 4/3. We already had the gradient of SN, that's 4/3. And then it just passes through L. So now we can find the equation. We have the gradient and a point. So let's go ahead and work through that. So the gradient of this line is 4/3, and it passes through this point L, which was -4 and 1. You can use whichever formula you want. If you want to use the y equals mx plus c, it's fine. I usually like using the y minus y1 equals m times x minus x1, just because once you substitute and you simplify, it gives you the answer straight. But I'm going to go ahead and use this one. So y equals mx plus c, and we're going to fill in our gradient. So y is equal to, our gradient is 4/3, x plus c. And now that we have this, our equation is almost complete. All we need is a point. So you can substitute your x and your y value. So the y value is 1 is equal to 4/3, and in place of x we put our x value, which is -4, and then we have plus c. Okay, so this is c, we just have to solve for c. Let's multiply here. If we have 4/3 times -4, remember you can rewrite that as a fraction by putting it over 1. So numerator times numerator is -16, denominator times denominator is 3. So this is a -16/3 that is here, but we want to solve for c. So let's leave c on the right hand side, and we're going to go ahead and take that value over to the left hand side. Because it's negative, it becomes positive. So you still have the 1, and that becomes positive 16/3. Okay, now how you can solve for this without a calculator is 1, you just have to make sure the denominators are the same. So 1 can be written as 3/3. So that's 3 plus 16, which is 19. And your denominator stays the same. So that's 1 plus 16/3, which is c. Now that we have that, our equation is finally just y is equal to our gradient 4/3, and we have x and plus 19/3, like we have there. So that is our final answer there. Moving on to the next question. Question 3.6 says, calculate the area of triangle LSN. Okay, so we have to find the area of that triangle. Now, the good thing is that this triangle is already a right angle triangle. So we can easily use the area that says a half multiplied by the base multiplied by the height. Okay, and the reason we can use this is because this formula is used for triangles that have perpendicular heights. This has a perpendicular height. We can treat this SL as the height of the triangle, so that's our perpendicular height, and then this will be our base. The LN will be our base. Okay, now the thing is we already have SL. We found that in the beginning, so we need to just find LN, and then we can find the area of this triangle. So let's go ahead and find the length of LN. Okay, so these are our points that we have, and we're going to find Ln. So this is equal to, and we'll say the square root of, remember it's x2 minus x1, so we can say -2 minus -4, which of course becomes a plus 4 all squared, and then plus y2 minus y1 all squared, so that is -3 minus 1 all squared. And then substitute that onto your calculator and we'll get our answer for that. And we're going to leave this answer in third form because this is not the final answer. So let's not round off. Okay, so now we have Ln, which remember is the base of your triangle. Okay, and we also have Sn, I think that was SL, right? Which is the height of the triangle, the perpendicular height. And that is 4 square root 5. So because you have the base and the height, you can actually find this. So SL is 4 square root 5. The area of that triangle, which is triangle LSN, is a half multiplied by our base and then multiplied by, of course, our perpendicular height, which we can see over there. So this is equal to a half multiplied by, and this is 2 square root 5 times the perpendicular height is 4 square root 5 we have there. So this is finally equal to, let's just multiply these two together since they both have the square root of 5. If you say 2 times 4, you're going to get 8. And the square root of 5 times the square root of 5 is like saying the square root of 5 squared because it's really 2 of it being multiplied. And the squared would break the radical or the square root. So that just becomes a 5 because of that. And so it's 8 times 5. 8 times 5 is 40. 40 times a half, or half of 40 is 20. So the area of this triangle is 20 units squared. And that is our answer to that question. Moving on to the next question. So the next question, 3.7, says calculate the coordinates of P, which is equidistant from L, S, and N. Okay, let's see how that's going to work. We're going to need the diagram. Okay, so here is our diagram. For the point P, wherever it is, for it to be at an equal distance, okay, from L, S, and N, it means that when you have P, right, the distance from P to L should be exactly the same as the distance from P to S, and that should be exactly the same as the distance from P to N. That they should all be the same distance, really, from P. That's really what they're saying. Now, looking at the diagram, the only way that this can actually be possible is because how exactly would you do that? You can't say it lies in the middle. That's obviously not true, okay? This is not equal distance at all. So the only way that that would be possible is, I'll take advantage of the fact that we have a right angle here, is if we have a rectangle. So if we have another side that is parallel to Ln and is exactly the same length as Ln, and then we have another side that is parallel to this line here, okay, and it's also exactly the same length, and that is also 90 degrees, then you'd have a rectangle. Now, for you to have P, that P would have to lie like this. This is how we're going to have to find P. For it to be equal distance, the only points that will be at an equal distance to all these points that they mentioned is the midpoint of your diagonals. That's the only points that can actually do that. So if we had to draw a diagonal here, right, then what we're saying is that P is actually here, right in the middle. That's going to be P, and that way P is going to be exactly at an equal distance between when you look at from P to L, and then from P to S, and then from P to N. That's the only way that would be possible. So how can we actually find P now that we have constructed this? Well, we can find P like this because P is really the midpoint of these diagonals. So do you see that this line SN, right? S and N are both present. We have both those points. So we can actually use it to find the midpoint of P. So that's really what we're doing. We're going to find the midpoint of P, looking at it like that. So the way they asked the question, they didn't just tell you go find the midpoint of P. They just asked it in a way that you were supposed to look at it and then you realize that that's actually the midpoint that they're referring to. Another way that we could have looked at this is like this. For P to be at an equal distance between all these points, we could have also looked at the fact that, okay, so we're saying really we have P somewhere, and if you look at from P to L, it should be exactly the same distance as from P to N and from P to S. Another way that you could have looked at that is if this was a semicircle, okay, not the most perfect semicircle, but if this was a semicircle, and you know that the distance from the center of the circle to the circumference is your radius. So PN would be a radius, PL would be a radius, and PS would also be a radius. So that would mean that all of these are radii and P is the center. So for you to find that center, again, you could have also just looked at S and N and said that we're just going to have to find the midpoint of this line because that would be the center of this diameter. Okay, so, and we know definitely this is the case because we know that the angle in a semicircle supported by a diameter is always going to be 90 degrees. So that is another thing that we could have also looked at there. So ultimately, we just have to find the midpoint of this line. Okay, but I'd rather go with this theory because in the other theory, they didn't present any other lines. Okay, so this is what we can use. Okay, so we're finding the midpoint of line SN. So SN, we're going to go ahead and use the midpoint formula. So the midpoint of SN, the formula is x1 plus x2 over 2, and then y1 plus y2 over 2. And this, of course, is in your formula sheet. So this is going to be that point P. So P is found by saying x1 and x2. So that is 4 plus negative 2. But of course, if you say 4 plus negative 2, that multiplies and becomes negative. So it's just 4 minus 2 over 2. And then the y's, that's going to be 5 plus negative 3, which is just 5 minus 3 over 2. And then we simplify. So therefore, P is 4 minus 2 is 2, divided by 2 is 1. 5 minus 3 is 2 as well, divided by 2 is 1. So our point P is actually 1 and 1. That's the only way that that can happen. So it would have to have some sort of a semicircle there, and then P is the midpoint of your diameter. Okay, moving on to the last question in question 3.8. Then, and the last question says, calculate the size of angle LPS. So let's see where that is. So LPS. So this is the angle they want us to find. We have to calculate the size of this angle. Okay, let's see how this angle was created. How do we find this? Well, I see that we have an isosceles triangle here. But the thing is, I don't know what these angles here are here, and I can't really just assume there's certain things. So I'm trying not to make any assumptions. Okay, now let's just think, did they give us any other angle? Do we have any other angle that could help us here? I see that we have theta, but theta is just way too off. It's a bit too far. So it's not really going to help us here because theta is created by going here to there. Okay, that's that angle. So it doesn't help in LPS. But do you remember that we had this angle here? Okay, we had the angle LNS. And that angle LNS, which we found here, angle LNS, is 63.44 degrees. So this is actually very helpful, 63.44 degrees. Because do you see that we have another isosceles triangle here? Okay, so this is an isosceles triangle. It means that our sides are exactly the same. So our angles are also equal, right? So this angle over here is also 63.44 degrees as well. Now, why is that important? Do you see that this angle that they want us to find, LPS, is the exterior angle of that triangle? So to find that exterior angle, you would add this interior angle and that interior angle, and that would give us that exterior angle. So we can actually find it like that. Okay, so I'll just go ahead and start by telling them that this angle PLN is 63.44 degrees. Okay, so PLN is 63.44 degrees. Okay, and then we can go ahead and use that exterior angle of a triangle. Remember, you don't need reasons here. This is not Euclidean geometry. They didn't say with reasons. So now we can go ahead and tell them that to find the exterior angle, which is the angle they asked for, LPS, we would say the two interior angles and add them together. So that is LPS is equal to, and it's really two sets of 63.44 degrees. So instead of just adding them individually, we could just say it's equal to 2 times 63.44 degrees and then get the answer. So LPS, so that is 2 times 63 is 126 degrees and then 0.88 because it's just double of it. So that is our angle. Our angle is, the size of that angle is 126.88 degrees if we use the exterior angle of a triangle. But we don't have to add reasons to this necessarily. Another way that we could also use to find that angle is you could have looked at it like this. So do you see that because we have a semicircle, okay, we can actually see that the semicircle, its center was what we were looking for, the center angle, right? You know that the angle at the center is going to be twice the size of the angle at the circumference as long as it's supported by the same chord. So this angle at the center is supported by SL, and the angle at the circumference is this one over here. So that's why that would have been twice the size of this angle. Okay, you'd have to tilt your head this way to see that. So angle at the center, angle at the circumference, supported by the same chord. Okay, so that is another thing there that we could have done. Okay, so that is it for question 3. And then we move on to question 4, which is more analytical geometry. We are on question 4, and question 4 says, in the diagram, the circle with center O has the equation x squared plus y squared equals 20. So this is the circle they're referring to. And then we have G, which is 10. O is the center of the larger circle. A common tangent touches the circle at D and F respectively, such that D is the point P and -2, okay, which they didn't really write there, but there, P and -2, and they tell us that this lies in the 4th quadrant. So we just have that common tangent there. The first question is, given that D, which is P and -2, lies on the smallest circle, show that P equals 4. Okay, so we need to find the value of P. Let us look at this and just see what we have. So P is this point over here. We can look at how this point is formed. Okay, how did we get that point? Well, we were at the center and then we went P units to the right, clearly because it's in the 4th quadrant. So we went P units to the right and then we went 2 units down, right, to get that. So if you look at that, it means that here, okay, this is a right angle triangle that we have now because I'm just forming it by just trying to find out what exactly is P, where is P, and how do we find it. So -2 would be here since we went P units to the right and 2 units down. So this is -2 and then P is this. So it means in order to find P, all we would need is this radius, OD. Now, do we have that radius? Well, in the beginning, do you see that they told us the equation of the smaller circle, the circle centered at O? So we actually have that radius. Remember that this right now, because it's at the origin, okay, it's centered at the origin. That's why it's x squared plus y squared. So centered at the origin, the equation is x squared plus y squared equals r squared. So we actually do have the radius. Okay, r squared is 20, so r is the square root of 20, which can be simplified further, of course. So we can actually use Pythagoras to solve for P. Let's go ahead and do that. So we'll leave that as P, which is really an X value. Okay, because we move X units. And then this would be our Y value. So Y value. Okay, so we'll call that Y. And then this is our R, our radius. Let's go ahead and solve for P. So which is the X. So the formula will be X squared is found by saying R squared, which is the radius, the biggest one, minus Y squared. And this is equal to, so X squared we know is ultimately P. So it's P squared is equal to R squared. We already have R squared. R squared is already 20. Remember, R is the square root of 20. That's to find R. But R squared itself is 20, like that. So 20, we'll put that there, minus Y squared. Y squared, Y is -2, so we just square -2. So -2 squared. Okay, so we have P squared, and we'll just have to square root both sides, of course. P squared is equal to 20, and minus, that becomes 4. 20 minus 4 is 16. P squared equals 16, and then we need to solve for P by square rooting both sides, because it's not R, it's plus minus, but based on where P is, we're going to take a certain side. So do you see that P is on the positive part of the x-axis? So we will leave that as positive. Square root of 16 is 4. So there we go. We have proven that P is indeed equal to 4. Moving on to the next question. 4.2 says E, which is 6 and 2, is the midpoint of DF. Determine the coordinates of F. So since E is the midpoint, and they already told us it's 6 and 2, so 6 and 2 need brighter colors here, 6 and 2, and we already have D, which I filled in since we know P is 4. We just have to use this to find F. Okay, so if E is the midpoint, we're really just using the midpoint formula, but the midpoint formula, and then remember you already have the midpoint. So we're really just working with it like we're finding the midpoint of DF. So looking for the midpoint of DF, remember it is still x1 plus x2 over 2 and y1 plus y2 over 2. And then that midpoint we already have. That midpoint is E. It's 6 and 2. So that is going to be our 6 and our 2. And that midpoint is equal to this calculation of the midpoint of DF. So when we're looking at DF and trying to find the midpoint of DF, because F doesn't have coordinates, we'll call it X and Y. So we can say X1 plus X2 and then Y1 plus Y2. That is what we have there. Okay, so that will be the calculation for the midpoint. So we're going to say X plus the 4, and that is the calculation to get that midpoint. So X plus 4 over 2, and then Y1 plus Y2. So again, we're going to start with the Y now. So Y plus -2 over 2. So it's just Y minus 2. Y minus 2 over 2. Okay, so this is the midpoint. This is the calculation for the midpoint. But what we're going to do is, because they really ultimately are the same thing, they represent the same thing, you're going to equate them. So the X value with the X value and the Y value with the Y value. So that means that 6 is equal to X plus 4 over 2, and 2 is equal to Y minus 2 over 2. And then now we can just go ahead and solve for X. So let's just go ahead and cross multiply. This is really over 1. And so cross multiply. 6 times 2 is 12. 1 times anything stays exactly the same. So that's X plus 4 is equal to 12. X is equal to, if you take 12 and you take the 4 over, it becomes a minus 4. 12 minus 4 gives you 8. So we know what X is. It's 8. And then here we can also cross multiply again. So over 1. And multiply, that gives you 4. Multiply, that gives you Y minus 2. Y equals, taking your -2 over makes that a positive 2. So 4 plus 2, which is 6. And so that means that the coordinates of F are, so F is just 8 and 6. And there we go. So, okay, it's just the midpoint formula, but they already gave you the midpoint. So we're just finding an endpoint. Okay, moving on to the next question. The next question, 4.3, says, determine the equation of the common tangent df in the form of y equals mx plus c. Okay, so we already have f, remember? Because we have f, this is more than enough to actually find it. Even without f, we actually don't even need f. But we know now that f is 8 and 6. So to find the equation of this line, you just need 2 points. There we have f and we have d. So we can find this common tangent. So these are our coordinates. So to find it, we can go ahead and first of all find the gradient. So the gradient, we will say y2 minus y1 over x2 minus x1. And this is equal to y2 minus y1, that's negative 2 minus 6 over x2 minus x1 is 4 minus 8. And so that gives you negative 8. That gives you negative 4. Okay, negative and negative give you positive. And so 8 divided by 4 is 2. So we know the gradient of this line is 2. Now that we found the gradient, I'm going to use the method that I prefer using to find the equation of this straight line. So y minus y1 is equal to m bracket x minus x1. Okay, and then we just substitute. So we're saying y minus, and I'll just put it in here already. We put in the gradient, and then you substitute 1 point. I'm just going to take f because it's all positive. It's just simple to work with. So we're going to take that as our x1, and that is our y1. We substitute. So y minus 6 is equal to 2 times x minus 8. Okay, let's simplify, and we're saying 2 and we're distributing. Distribute there, we get 2x, and if you multiply it there, you get negative 16. Now, this negative 6 is still here. We can take it over and it becomes a positive 6. Then we're still left with the y over here. So it means that y is equal to 2x, and we have negative 16 plus 6, which is really like 6 minus 16, and that is negative 10. And that is the equation of this line df or fd. Okay, so that is our equation. Moving on to the next question. Okay, 4.4 says calculate the value of t showing all working. So let's go ahead and find t. So t is this over here. T is the x value of the center of the bigger circle. So how do we actually find that? Well, remember how I always said that the previous question always helps you with the next question? Yeah, we can actually use that here. So the equation of this line that we just found is not really helpful to find that. However, the gradient is helpful. And here's the reason why. Do you see that from the center to the circumference, you have a radius in the bigger circle? What do you know about the relationship between a tangent and a radius at the point of contact? They're always perpendicular. So we can actually use that. Because this is perpendicular to this, we can find the gradient of this line. And then we have a point that this line passes through, this point. Once we substitute it, we will have the equation of that line. And then when we have the equation of that line, we can simply find this point. You see that it's t and 0, meaning we have its y value. If we substitute its y value, we'll find its x value. So we can use that. Let's go ahead and do that. So first step, we need to find the gradient of line FG. We're going to use the gradient of line FD to do that. So the gradient of line FD, that was 2 that we found here. Yes, okay, it's 2 that we have. So to find the gradient of FG would be found by saying, now what do you know about perpendicular lines? Because these lines are actually just perpendicular. If you take the gradient of the one line and you multiply it by the gradient of the other line, they should give you negative 1. So in other words, if you want to find the gradient of one line, you just take the gradient of the other line. And how do you get this m2 out of the left-hand side? Because it's multiplying, the only thing you can do is divide by it to get rid of it. So to find m1, you say negative 1 divided by the m2, the gradient of line 2. Okay, so that's what we can do there. So to find the gradient of fg, we'll say negative 1 divided by the gradient of the line it was perpendicular to, which was the gradient of fd. Okay, that gradient of 2, that line. So this is the gradient of fg is equal to negative 1 over 2, because we know that gradient already. Okay, we have the gradient of that line. Now we can find the equation of this line. So to find the equation of the line, FG, it passes through this point 8 and 6, and this is a complete point, so we can use that to find it. I'll use the quick method again, this one. Y minus y1 is equal to, and our gradient is negative 1 over 2 times x minus x1. Okay, so the point F, remember, is 8 and 6. And so this is our x1 and that's our y1. So we're substituting. Y minus 6 is equal to negative a half times x minus 8. And we can simplify now. So this is equal to, if we distribute, this is negative 1 over 2x. Distribute, that's like saying, so we have negative and negative, which gives us positive. But a half times 8 is saying a half of 8, which is 4. And then we leave our y here, but we take the negative 6 over, and that becomes a positive 6. So y equals negative 1 over 2x plus 10. Okay, so that is the equation of the line FG. Now, to find that point T, or that coordinate T, you see that on FG, that's where this point lies. Okay, it's the x-intercept of it. But ultimately, we can just see that the y value is 0. So we can find the x value. In other words, really just substitute t and 0 in place of x and y. So that's what we're doing here. So to find g, okay, t and 0, this is our x value, this is our y value. So let's substitute. That is 0 is equal to negative a half. And then in place of x, we say t plus 10. Okay, and to solve for t, if you say negative a half times t, you get negative a half t plus 10 is equal to 0. But we can actually just take this over, since it's negative, to make it positive. So now you have positive a half t equals 10, positive 10. And then to solve for t, we can get rid of the half by dividing both sides by a half. If you say 10 divided by a half, it's really like a doubling it. So 10 divided by a half would give you 20. And that is what the value of t is. So that is our final answer there. T is equal to 20. Okay, moving on to the next question. 4.5 says determine the equation of the largest circle in the form of ax squared plus by squared plus cx plus dy plus e. Okay, so we just need to find the equation, then distribute and leave it in that format. Okay, so with the largest circle, you see that we already found t, so we know what the full center of the circle is. It is now 20 and 0. Now that we have that, we can actually use this to find the equation of the circle. To find the equation of a circle, all you need is the center and at least one point on the circumference, which we have. We have those 2 points, so we can use that to find the circle. Okay, the equation of that circle. So G is 20 and 0, F is 8 and 6. So the equation of a circle, okay, in standard form is x minus a squared plus y minus b squared is equal to r squared. And then we're going to go ahead and substitute. So first substitute your center. Remember that the center of the circle was G, right? And that's going to be your A and B value. So we'll substitute in place of A and B, first of all, the G, right? So we're saying x minus, and this is the A, this is your B. So it's going to be like that in that order. Minus 20 squared plus, and instead of saying y minus 0, 0 is nothing. So it's y minus 0, it still stays y. And so we're going to still just have y there, squared is equal to r squared. So this is the equation of that circle. Okay, so now that we have substituted the a values, we can go ahead and work on the x and y values. So this is x and this is y, and we'll substitute that into the equation. Now the point of that is so that we can find r squared, okay? Because the equation is already almost complete at this point. So now let's go ahead and substitute. So we have now, in place of x, we have 8. So that is 8 minus 20 all squared plus, and y squared is just 6. So that is 6 all squared. So 6 squared, and then that is equal to r squared. You can just substitute that onto the calculator because it'll just be easier to work with like that. And we get 180. So 180 is equal to r squared. And now that we have that, we can go ahead and substitute that r squared value into this equation, because that would have been the complete equation of the circle. So therefore, this is x minus 20 squared plus y squared, which is equal to 180. So now we're not done yet because they remember that they want us to put it in this format. So we need to distribute. So you have x minus 20 all squared. To distribute that, you can write it as x minus 20 times x minus 20. But remember, I always say that this method takes longer and it's better to take shorter steps so that you can avoid making mistakes. So we're going to go ahead and square the first term, and that gives you x squared. Then square the last term. If you say negative 20 squared, you get positive 400. Then to find the middle term, you say first term x multiplied by the negative 20, which gives you negative 20x. Then you multiply that by 2, which gives you negative 40x. Okay, then we have plus y squared and is equal to 180. For the sake of them saying put it in that order, okay, remember that in this order, do you see that they have nothing on that side? 0 is on that side. So let's go ahead and bring the 180 over, but also write it in the same format. You see that we have the x squared and then the y squared. So let's rewrite it like that. So therefore, x squared, and then let's write the plus y squared, and then the minus 40x, and then our constant. We have 400 and 180 is coming over. So 400 minus 180 is like saying 40 minus 18, which is 22. So this is positive 220, and this is equal to 0. So there, now it is in the format that they asked us to put it in. So there we go. That is our final answer. Moving on to the last question in question 4. Okay, the last question for question 4 says, the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. Okay, so that small circle must be translated along the x-axis so that it touches the larger circle internally. So here's an idea of what it means for a circle to touch another circle internally. You have this circle over here. So I'm just going to redraw it. If you have this circle, right, for it to touch the other circle internally, you really just move in it, and so that it intersects with the circle, but intersects with the circle in a way that it's still inside this bigger circle. So this is what it means for it to intersect internally. So you see here, we're going to really need this diagram. But here's the thing, that's not the only way it can intersect internally. It can do this in 2 ways, like this, and we could also look at it like this instead. So instead of just like that, we could also see it as moving from here and then moving along the x-axis, and then it intersects on the other parts of the circumference of the bigger circle. And there, it intersects internally like that. Okay, so we just have to figure out how to make this possible. Let's go. I'm going to just go ahead and take this diagram and let's put it down there. Okay, so the first thing we would notice about trying to do this, right, is first of all, this circle is moving along the x-axis, which is a good thing because you notice that both of these circles, right, their center lie on the x-axis. Their center points lie on the x-axis. That's why they both have y values of 0. This one is 0 and 0. This one is 20 and 0. Okay. And another thing is we have, right, the radiuses of or radii of these. Now here's where these are actually useful. We need to move these circles. You saw how we have a circle like this, and that needs to move along the x-axis so that it can intersect internally. So if we have that, we're just really trying to find out how can we get how many units must we shift this circle so that it can intersect the larger circle like this. We can focus on one part of the circle, one point on the circle. We can focus on this over here. Now, the reason I'm focusing on this is because for me to make this intersect here, I have to specifically make sure that this circle, right, this part intersects at this point over here. So when I'm controlling it from here, I'm going to have to control it from this value, this point over here. So how do we find out what exactly this value is on the x-axis? What is this number here? Well, that's where the radiuses, radii, become important. The smallest circle, what was the equation of that? They told us initially that the equation of the smallest circle is x squared plus y squared is equal to 20. right? Remember that from the beginning? They told us that. So it means we can actually find the radius of the smaller circle. So radius of circle centered at O is, let's just call that R1. It is going to be the square root of 20, which square root of 20 can be 4 times 5, which gives you 20. Square root of 4 is 2. So 2 square root 5 is the distance, okay, that we have there. We know the radius now of that smaller circle. So to find what exactly this x value is over here, we're just going to say we're going this time from the center and we're going 2 square root 5 units to the left. So that's going to give you negative 2 square root 5. So we know exactly what that is. And what we're saying is we need to go from negative 2 square root 5 and we need to shift the circle to the right until it hits this point over here. And then we'll find out exactly by how much are we shifting it. Now, to do that, you see that we need to actually know what exactly this point is, because you need to move it from here to here. But we need to know what is this point so we know what we're moving it to. To find this point, you see that that is on the circumference of the bigger circle. We can also find it in the same way. We know the radius of the bigger circle. Well, we can find it now. Remember, we already found the equation of the bigger circle to be this at this point, and then we distributed and got it to that. So it means that your r squared is the 180. So we can find the r. So we'll call that radius 2. Square root of 180 is, okay, I'm just going to use a calculator for this. Square root of 180 gives you 6 square root 5. Okay, so we have 6 square root 5 there. Now we can find out what exactly this is. So I try not to use big calculations. Let's just focus on looking at the radiuses, radii. Okay, so to find that length, I know now that the radius of this bigger circle is 6 square root 5 units. So I'm going from 20 units in the center and I'm shifting to the left by 6 square root 5 units. That's like saying 20 minus 6 square root 5 because we're moving to the left. So it means at this point over here, the x value that we have there is just this number here, 20 minus 6 square root 5. I just didn't put it in decimals. That's the number that we have there. Guess I should just leave it in red so that we know, yeah, it's that. So that's the number that we have there. Okay, good. Now that we have these two, look at how we can find out how it was moved. How much units was it shifted so that it intersects with the bigger circle internally? You shifted it from this point and you moved it to the right to this point. How many units did we move it? Well, we can't really just see it with our eyes, but we know that you moved from here to here. So to find that distance or that difference, you take this minus that, and that would give you the amount of units you shifted that to get to that point, because we're just trying to find the distance. What is the distance between this? That's what it needs to move. It needs to move from here all the way to there. Okay, so that is the first k we can find. K is found by saying 20 minus 6 root 5 minus, and then we're subtracting it by the 2 root 5. So minus negative 2 root 5, sorry. Negative 2 root 5, which of course becomes a positive 2 square root 5 units. So here, do you see that these two are actually like terms because they both have root 5? So that's like say negative 6a plus 2a. Okay, like 2a minus 6a is negative 4a. So that is really just, we still have the 20 and then minus 4 root 5. Okay, you can see roots as if they are just variables when they are the same. So that's what k should be here. And we can, of course, just go ahead and use the calculator to get the simplified value. So what is 20 minus 4 root 5 as a decimal? As a decimal, that is k should be exactly 11.06 units rounded off to 2 decimal places, roughly about that amount for it to intersect internally. So that is the first part. Remember, it can intersect internally here, but it can also intersect internally on the other side as well. So I'm going to copy that circle, and now let's put that over here. So it can also intersect internally by it being here, and then it translates all the way to this point. There, it also intersects internally. Let me change the style and leave it to green so that we can just see it. And let's remove this just so that it doesn't distract us. Now, what we're trying to do is find out how many units do we have to move this circle so that it ends up here. Okay, so to find that, I'm going to decide now to actually use this point over here. Here's why. I wanted to intersect here. I wanted to intersect at the edge there. So I need to start using this end, the right hand end of the circle, so that when we shift it, we can find out exactly what it moves by. Okay, so we need to find this. Remember, the radius of the smaller circle is 2 root 5, right? So you're going from the center to square root 5 units to the right. And so that is exactly 2 square root 5 as an x value. The next x value we would need to find, I think I should just leave this in another color rather, 2 root 5. Okay. And then the next x value we would need to find would be this one over here to find out what exactly that is. So what is this going to be? Okay, I also just left that blue. To find that one shouldn't be difficult because the thing is you have your bigger circle, right? You know this is the center at 20 and 0. And then if you go from the center to the circumference, you have the length of the radius. We know the length of the radius of the bigger circle. It's 6 root 5. So it means you're going from 20 all the way to 6 root 5. That's 20 and you're moving to the right. So plus 6 root 5. And then that's what that coordinates would be there. That x value is 20 plus 6 square root 5 units. That's what that is there. So how do we shift this? How do we move this circle so that it moves from this point all the way to that point and lands right there? To find that, we need to find exactly what the difference is here. What is the distance? What distance did we travel? If we start from here and then we move all the way to here. To find that distance, you're just going to have to say 20 plus 6 root 5 minus the 2 root 5. And that's going to give you that. So the second way to find k, so the other value of k, is k equals, and we're going to say it's equal to 20 plus 6 root 5. And then to find that, you say minus 2 root 5, 2 square root 5. Okay, that would give you that distance of k that you must travel to get there. Therefore, k is equal to, let's just get the simplified third form answer first. 6 root 5 minus 2 root 5 is positive 4 root 5. And then the final answer here. So it's 20 plus 4 root 5, which is 28.94. So k is equal to 28.94 units. Okay, so those would be the two values of k that you can get if you're trying to move that circle so that it intersects with this bigger circle internally. Okay, so we're on question 3, and question 3 says, in the diagram, A, which is 3 and 4, B and C are vertices of triangle ABC. Then they tell us that AB is produced to S, D and F are the X and Y intercepts of AC respectively. And then F is the midpoint of AC. So that is something that is important and we can put that out. So it means that CF is equal to FA or AF, right? Because this is the midpoint. And then they tell us that, and the angle of inclination of AC is alpha. So that's the angle of inclination. The equation of AB is y is equal to kx plus 3. Okay, so that's the equation of AB, and the equation of AC is y is equal to 2x minus 2. Okay, let's move on to the first question. The first question says that we need to show that k is equal to 1 over 3. Okay, so k is, as you can see, the gradient of this line. How can we find the gradient? Well, they gave us the y-intercept, and the gradient is the only thing missing. So if you had a point and you fill in that y and the x coordinate of that point, you see that only k would be missing and you'd be able to solve for k. So do you see now that on this line AC, we are given the point A? We can substitute that. So we have y is equal to, and they told us it's kx plus 3, and our point A is 3 and 4. So A is 3 and 4. So substitute that. The y value is 4, so 4 is equal to k, and the x value is 3 plus 3. Then we're going to say 4 and take 3 over minus 3, which of course gives us 1, is equal to k times 3 is 3k. Then we can divide both sides by 3, and therefore k is equal to 1 over 3. Okay, so that is the value of k, and we have shown them that. Moving on to the next question. The next question says, calculate the coordinates of B, the x-intercept of line AS. So we have to find B. Well, now we know that this is 1 over 3. And if this is the x-intercept, to find an x-intercept, you just have to make y equal to 0. So that's what we're going to do. So it means now that our equation is y is equal to 1 over 3x plus 3. And we'll make y equal to 0 to find the x-intercept. So 0 is equal to 1 over 3x plus 3. Now we can go ahead and take the positive 3 over. So it becomes a negative 3 is equal to 1 over 3x. And then to solve for x, divide both hand sides by 1 over 3. And so it means that x is equal to, well, negative 3 divided by 1 over 3 is negative 9. So it means that that coordinate B, the x-intercept, is negative 9 and 0. And that is our answer for that question. Okay, moving on to the next question. The next question, 3.3, says, calculate the coordinates of C. So the coordinates of C. C is this coordinate over here. How do we find that? Well, they told us that F is the midpoint, right? F is the midpoint of the line AC. I also want you to notice that F lies on the y-axis, so it's a y-intercept. In an equation, right, where we have y is equal to mx plus c, the y-intercept is the c value. So you see that we have the equation of this line, so it means that the y-intercept is negative 2. So this coordinate, as a coordinate, of course, the y-intercept, the x value is 0, and the y value is negative 2. Okay, so do you see now we can actually use the midpoint formula to find that? So here is the midpoint formula. Remember, you have it in your formula sheet as well. But we need to be careful with how we use this formula. So if this is the formula of the midpoint, remember what we're trying to say here. The midpoint of AC is F. Okay, so since we don't have C, we can go ahead and call that X and Y. Let's just establish which one is our X1 and X2 and Y1 and Y2. Because we're saying F is the midpoint of AC, it would mean that that would have to be your X1, this is your X2, or you can make that X1, it's fine. And that will be your Y1, and that's your Y2. You have to use it like that. If you use this as X2 and Y2, you will find the midpoint of this shorter line, which is in the middle here. Okay, that's not what we're trying to do. So we're going to go ahead and use this formula like that. Okay, so we're saying that that midpoint, right? But the thing about it is we actually know what the midpoint is. The midpoint of AC is that coordinate F. So in place of that midpoint, we're going to say this is F, which is 0 and negative 2. We're going to go ahead and put that. So I can really just say is equal to, so that, you know, it's kind of like an equation. So we're saying 0 and negative 2 is equal to, and let's substitute, x1 is 3, so that's 3 plus x over 2. And then we have 4 plus y over 2. Okay, now here's the thing. This is the midpoint of AC. This is the calculation for the midpoint of AC. So they really represent the same thing. That means the midpoint of AC, this is the x value, and this is also the x value. This is the calculation of the x value. And this is the y value, and that is the y value. So we're going to equate the x and the y values. So that means that we're saying 0 is equal to 3 plus x over 2. And we're saying negative 2 is equal to 4 plus y over 2. Okay, so now that we have this, we just have to solve for x. So to solve for the x, you need to get rid of the 2 on the denominator. So we're going to multiply both sides by 2 to do that. And then 0 times 2 is still 0, which is equal to, that cancels and we have 3 plus x. Then to solve for x, take 3 over and you have that x is equal to negative 3. Okay, and then here, same thing, we need to get rid of the 2. So multiply both sides by 2 2 times negative 2 is negative 4 is equal to, that cancels, 4 plus y. Then if you take your 4 over, you get negative 4 minus 4, which is equal to y. Negative 4 minus 4 is negative 8, so y is equal to negative 8. And so that would mean that the coordinate of C, that endpoint we're looking for, is now negative 3 and negative 8. And that is our answer. Okay, so moving on to the next question. Okay, so the next question, 3.4, says, determine the equation of the line parallel to BC and passing through S, which is negative 15 and negative 2. Write your answer in the form of y is equal to mx plus c. Okay, so let me get the diagram down. Okay, so all they told us here is that we're finding the equation of the line parallel to BC and it passes through S. So it means that that line looks something like that because it's parallel to BC. They gave us a coordinate for S, so that is negative 15 and negative 2. Okay, when lines are parallel, it means that their gradients are exactly the same because they're slanted in the same way. So it would mean that the gradient of the line we're currently looking for is going to be the gradient of BC. So do we know the gradient of BC? Not yet. We'd have to find that. But we know the coordinates B and we know what C is as well. We found out that B, well, let's start with C. C is negative 3 and negative 8. And we knew that B, we found B already, which is negative 9 and 0. So let's go ahead and find the gradient first. So our gradient, the formula is this. So it means that to find the gradient of BC, we would just say y2 minus y1. We can start with the C. So negative 8 minus 0 over negative 3 minus negative 9, which of course when you distribute would become a positive 9. So the gradient of BC is equal to negative 8 over, this is like say 9 minus 3, which is 6. And as you can see, these, they can actually simplify. So gradient of BC is equal to, they both have a factor of 2. So that's negative 4 over 3. Okay, so we have the gradient now. We have the gradient of this line as well and BC. We just need to find the equation of it. They told us a point that this line passes through. It passes through S. So we can use that point to find it. Okay, so there are two equations, of course, to find the equation of a line. You can either use y is equal to mx plus c, or you can use this one, y minus y1 is equal to m times x minus x1. Now, I like to use this one, and the reason why is because I don't have to go ahead and find c first, then put it back in, which is still fine though. But this one, I don't have to. I just substitute everything, simplify, and my equation is there. So I'm going to use this equation. So I'm going to say y minus, now here's the thing, x1 and y1, those are your coordinates. Okay, so the point that it passes is S. So that's our x1 and that's our y1. So I'm saying y minus our negative 2, which is just going to be y plus 2, of course, when you distribute, is equal to negative 4 over 3 times x minus negative 15, which becomes a positive 15. Okay, so now let's distribute. Now I start here by saying it's equal to, and I start distributing, knowing that this is still here. So that is going to be negative 4 over 3x. And when you multiply, well, if you say negative 4 over 3 times 15, things can cancel diagonally. You see 15 and 3 have 3 in common. So 3 divided by 3 is 1. 15 divided by 3 is 5. So that's really negative 4 times 5, which is negative 20. It's over 1, but you know it's going to still simplify to negative 20. Then, you see with the y plus 2, I'm going to leave the y here and take this positive 2 over, and it becomes a negative 2. So it means that y is really just equal to negative 4 over 3x minus 22 when you simplify. So that is the equation of the line parallel to BC that passes through S. Okay, moving on to the next question. So the next question, 3.5, says, calculate the size of angle BAC. Okay, again, we need a diagram. So here's our diagram, and they want us to find the size of angle BAC. So really just this angle over here. Okay, so what we can use to find this angle is really the angle of inclination. So I'm going to move this shape here because I just need a little bit of space. Let's go ahead, and this is what I'm going to do. I find out how this angle was formed. And normally you have to extend certain lines to do that. So what I'm going to do is extend this line of BA. I'm going to extend that like that. So like that, and extend the line of AC like that. Okay, so now that I can see that, do you see that these two angles, they're vertically opposite? So this is BAC and that is also BAC. So let's concentrate on this one and see how that was formed. So how you find out how an angle is formed is by looking at the point of intersection between the two lines where the angle is formed. So how I'm going to do that now is I'm going to draw an imaginary x-axis. So that is really just a line that is parallel to the x-axis. So I'm going to take this line and put it here so that I can better understand how this angle was formed. So now that this line is here, what we're going to do is, let's look at this. If you look at this angle over here, remember that's the main goal. We're just trying to find this angle. Look at it as if it is a pizza slice. Imagine you had this entire piece, right? And you wanted to get that little part. So if you took away this part, then you'd be left with that. So how this angle is actually formed is by taking the angle of inclination of this line over here. And as we can see, that is the line AC. Taking the angle of inclination of AC and subtracting it by the angle of inclination of this line, which is the line AB, okay, or AS. So that's what we're going to do. We're going to find the angle of inclination. To find the angle of inclination, you just need the gradient of the line. So we're taking the angle of inclination of AC. What is the gradient of AC? The gradient of AC, here's the equation. So the gradient is 2. So since we know that, we can find its angle of inclination. The formula for angle of inclination is tan of theta is equal to the gradient. But we know our gradient is 2. So we're going to leave theta here, but I'm going to specifically call this theta of AC so I don't forget what angle it's for. So I don't forget what line it's for. And then I'm going to take tan over the equal to sign. So we get shift tan when you take it over. It's really just doing the inverse of tan. So that's going to give you shift tan of 2, right? And let's go ahead. Now, I would actually want to calculate it, but let's not do that. The reason why is because when you say shift tan 2, you're going to get decimals as well, okay? So because of that, I'm not going to find the answer. I'm just going to hold on to that. So remember, I said we need to find the angle of inclination of AC and subtract it by the angle of inclination of AB. Okay, so let's find the angle of inclination of AB. Again, tan of theta is equal to the gradient of AB. The gradient of AB, we knew that, okay, is 1 over 3. So that is tan of theta equals 1 over 3. Then we leave theta here, take tan over. It becomes shift tan of 1 over 3. Okay, so now to find the angle BAC, all we're going to do is say BAC is formed by taking the angle of inclination of, remember this is AB, angle of inclination of AB, is by taking the angle of inclination of AC, the bigger angle, right, of AC, and subtracting it by the angle of inclination of AB. This one, the smaller angle, that line, okay, angle of inclination of AB. And then I'm going to take it like that so that the answer would be more accurate. So it's equal to, so that is shift tan of 2 minus shift tan of a third. Okay, so we can put this onto the calculator. So on the calculator, you just say shift tan of 2 minus shift and then tan of 1 over 3. Okay, so that gives us exactly 45 degrees, and that would be the size of a BAC. Okay, so that is our answer in that question. Okay, moving on to the last question in question 3, which says, if it is further given that the length of AC is 6 root 5 units, calculate the value of the area of triangle ABD over the area of triangle ASC. Okay, let's get the diagram down. So our diagram so long looks like this. Remember, we already found that angle there, okay? So we found out that this angle was 45 degrees. This little part here is 45 degrees. But remember, these are vertically opposite. So it is still the angle BAC. So that is 45 degrees that we have there. Okay, so I'm going to fill that in just in case it helps us. So that's 45 degrees. And let's just go ahead and see the triangles they're referring to. So they say the triangle ABD. So that's ABD. Let me highlight that. Okay, and then they spoke about the triangle ASC. So you see that we haven't really joined that one yet. So S and C gets joined and they form a triangle. So let me highlight that one. Okay, so as you can see, ASC is the green triangle and the ABD is the purple triangle. Okay, so let's see how can we actually find the areas of these triangles. Starting with this triangle ABD. Well, in order to find the area of a triangle, there's two formulas we can use. If you have a triangle, any triangle that has a perpendicular height, so it could be like that, it could be specifically a right angle triangle where that would be your perpendicular height. It could also be an obtuse triangle where you could find a perpendicular height for it. Okay, so as long as you have the height of these triangles and you have a base as well, you can find it by saying the area of the triangle would be equal to half times the base times the height. But then there's also triangles that do not have perpendicular heights visible right there. So the area of those triangles work like this. So let's say this triangle's name was ABC. Find the area by saying a half multiplied by the side AB multiplied by the side AC. And if you have this middle angle, it's actually specifically if you have the middle angle here, and you will say sine of angle A. So we have these two formulas, right? Let's just see how we can find the areas of each of these triangles. Let's start with the purple one. So with the purple triangle, as you can see, it's actually an obtuse triangle. But here we have an advantage because we can see that the base is a horizontal line since it lies on the x-axis. And because it's a horizontal line, if we know the coordinates of D and we already have B, we can easily find its base, okay? And then, can we find its perpendicular height? Yes, we actually can. The reason why is because you see that this is the highest point of the triangle. And if you go down to the base, okay, perpendicular, we have a height. So we can actually find that because I want you to see that this point A, how we plotted or how that point was plotted was by going, okay, so it's 3 and 4. So they went 3 to the right and they went exactly 4 units up. So we know how high this is. The height of the triangle is 4 units. So we just have to find the base in this case. And to find the base, the entire base, you see that you just need the coordinates D. D is the x-intercept of this line. So we can find that. So you see that here, we can use that. We're just going to find that base. Okay, let's look at the green triangle now. So we can find the base here. So the green triangle, well, the green triangle, it's already skew. So finding a perpendicular height is not too easy here. Even this line here is not a height. It's not a perpendicular. We can't really call it that yet, okay, because we don't really know. So the only way that we could have used half base times height in the green triangle is if we maybe found out that this was perpendicular. So if lines are perpendicular, when you take their gradients and you multiply them, they give you -1. So it would mean the gradient of this and the gradient of that should give you -1. But I know it's not going to, because we know this one, the gradient is 1/3, and we found the gradient of BC to be -4/3. So it's not going to work. What we can do in the green triangle is use this area, okay? How about, so there we have a middle angle, we have 45 degrees, check. And then we would just need this side and this side. So you just need the sides adjacent that angle. So you just need the sides that are next to that angle. So we can find a S definitely because we have the coordinates, and AC, well, they actually told us something about that. They told us that AC is 6.5 units. So there we go. Now we know what we need to do. We already have that. Okay, so we can go ahead and find this. So the area of triangle ABD over the area of triangle ASC. Okay, so the area of triangle ABD, we're using a half times base times height, But hold on. We need to find the coordinate D in order to do that, okay, for the base. So let's find D. Here is the equation of the line AC. D is the x-intercept. So to find the x-intercept, you just have to make y equal to 0. So we're saying y equals, that was 2x minus 2. And we'll just go ahead and make y equal to 0. So 0 equals 2x minus 2. Take your negative 2 over, which is equal to 2x. Divide both sides by 2. And x is equal to 1. So we know now what D is. It's 1 and 0. Okay, so if D is 1 and 0, what is the full length of the base, BD? This is negative 9. This is 1. So it means you went 1 to the right and 9 to the left. A total of 10 units. Okay, so that is a total of 10 units. You could have also said this. To find BD, you would have to say, you always have to say the bigger one minus the smaller one. So since this is 1 and 0, and this is the bigger number, you're going to say this one. So x1 minus that one, x2. Okay, so that's 1 minus negative 9, which is of course going to be 10. Okay, because that becomes a plus 9. So BD is 10 units, and we know that the height of it is 4 units. So the area of BD, we can continue with this now. So the area of ABD is a half multiplied by our base of 10 units multiplied by our height of 4 units for that triangle. Okay, we're done with that one. And now the green triangle, we already know what formula we're using there. So it's a half multiplied by this side AS. So we also have to find AS. Okay, so we're going to use the distance formula for that. Okay, so I'm just going to move that there. Let's just also move this here. I'll just put an arrow to show them that I continued there. Okay, then let's go ahead and find AS. This is the distance formula, which is in your formula sheet. So we know that A, we can just call that x1 and that's x2, and then that's y1 and y2. So AS is equal to the square root of, and we're going to take, so x2 is negative 15. So that's negative 15 minus 3 all squared plus negative 2 minus 4 all squared. And then you can just substitute that onto your calculator to find AS. And we get 6 square root 10. Now, I'm not going to simplify that because it's not our final answer. The final question is this. So I'm not going to simplify that. Okay, so this is the area of triangle ABD over the area of triangle ASC, which we say a half, multiplied by, so remember, multiplied by the one side, which is AS, we found that to be 6 square root 10. So that's 6 root 10 multiplied by the other side of that green triangle, which is AC, and they told us that it was 6 root 5 units. So that is 6 root 5. And then multiplied by, the last thing we multiply by is sine of that angle, which is 45 degrees. So sine of 45 degrees. Okay, so you're just going to put this into the calculator and you can get your answer. Okay, remember grade 12s, use your calculator because this is not a practice. This is an exam. In an exam setting, use your calculator because it will help you save time. You need to manage your time. So this is equal to, we get 2 over 9. That is what it finally simplifies to. And that is the last question for question 3. And we finally move on to question 4. So we're on question 4, and question 4 says, in the diagram, the circle centered at C, which is 2 and P, is drawn. Then we have A, which is 5 and 1, and B, negative 3 and negative 3 are points on the circle. Okay. E is the midpoint of AB. Okay, so that is the midpoint of AB. So interesting, line from the center to the midpoint. Okay. Then they say 4.1, calculate the coordinates of E, the midpoints of AB. Okay, so we have to calculate the coordinates of E. It's just the midpoint of AB, so we use the midpoint formula, which looks like this. And these are endpoints, so that can serve as x1 and x2 and y1 and y2. Okay, so we're really just saying there, we're just going to say the midpoints, we'll just call that E. Might as well just call it E. So E is really just negative 3 plus 5 over 2, and then negative 3 again plus 1 over 2. Okay, simplify. So this is like saying positive 5 minus 3, okay? And that is 2. So 2 over 2 gives you 1. Then that's like saying 1 minus 3, which is negative 2, over 2, which is negative 1. So there's our coordinates of E, and this is for 2 marks. Okay, so moving on to the next question. The next question, 4.2, says, calculate the length of AB. Leave your answer in third form. So the length of AB, well, let me put this down. We know that this is 1 and negative 1. We just need to find the length of AB. So use the distance formula, which looks like this. And we just need to use that on A and B. Might as well just use it like that. So that would be 5 minus negative 3, which really just becomes a 5 plus 3. So that's 5 plus 3 all squared plus, and then y2 minus y1. So that's 1 minus negative 3, which becomes a 1 plus 3. So that is 1 plus 3 all squared. You can substitute into your calculator. Also, grade 12s, just remember it doesn't really matter which one you name as x1 and x2. You just need to be consistent. So if you named this one first x1 and that x2, then this one has to be y1 and that y2. That's really all. Okay, so when we put that onto the calculator, this is the answer that we get. We get 4 root 5, and we don't have to put it in decimal form. So that's our answer. Okay, moving on to the next question, which is 4.3, and it says, determine the equation of the perpendicular bisector of AB in the form of y is equal to mx plus c. So the perpendicular bisector of AB. Okay, so the perpendicular bisector is just a line, so we already know that theorem. They're using Euclid here, clearly. This is the center of the circle. If this line goes from the center of the circle to this being the midpoint of this chord, right? Then the line from the center of the circle to the midpoint of the chord is always perpendicular to the chord. That is the converse theorem of theorem 1. But this is analytical geometry, so we don't really need to give them reasons. Okay, so we're going to continue. With that being said, this is the perpendicular bisector CE. We're going to use that. Now we have to find the equation of it. Well, to find the equation of the perpendicular bisector, it's a line, okay? So you just need the gradient and another point to find the y-intercept. Well, for us to do that, we first of all need the gradient of this line, but P is missing. So clearly we can use the gradient of this one, and we can use what we know about perpendicular lines and what their gradients do. So let's go ahead and find the gradient of AB first. And of course, you can use AE. It will still work out since it lies on the same line. But I'm just going to use AB because I've already labeled these ones x1 and x2 and so on. So our gradient formula looks like this. And then we're just going to substitute. Okay, so since I already labeled them like this in the diagram, I'm just going to continue like that. It's still fine. So we're going to go ahead and say 1 minus negative 3, which of course will become a plus 3 over, and we have 5 minus negative 3, which becomes a plus 3 as well. So that is really just 4 over 8 that we can see there. 4 over 8, if you simplify 4 over 8, it gives you a half. Okay, so we know the gradient of AB. Remember, that is the gradient of this chord. Now, the chord is perpendicular to this line. And what we know about perpendicular lines is that if you take the gradient of AB and you multiply it to the gradient of CE, which is the perpendicular bisector, it should give you negative 1. So let's substitute the gradient of AB. That's a half times the gradient of EC, and it will give us negative 1. So to find the gradient of EC, we just say that this is equal to, and we need to get this out of here so that we can leave this alone. It's been multiplied, so to remove it, you need to divide. So let's divide both sides by a half, and we will get gradient of EC being equal to negative 1 divided by a half, which is negative 2. And there we go. That's our gradient of EC. We're not done yet. We need to find the equation of the straight line. So now that we know this gradient, right, the equation of this line, it passes through E. So we can substitute E into the equation we have and we'll find the y-intercept. So here I'm just going to use y equals mx plus c since I used the one I like in the previous question. So remember that E is 1 and negative 1. Okay, so there we go. This is our x and our y value we'll substitute. So I'm just going to go ahead and substitute. We'll say y is equal to, and we'll say negative 2x plus c. Okay, so almost done. We just need c. Our y value is negative 1 is equal to negative 2 times 1 plus c, and negative 2 times 1 is negative 2. When you take negative 2 over, it becomes a positive 2, right? So it's positive 2 minus 1, which is c, and 2 minus 1 is 1. So finally, it means that y is equal to, we use this formula because it was almost complete, we just needed a c. So negative 2x plus 1. And that is the equation of the perpendicular bisector of AB, which is of course that line EC. Okay, so that is it for 4.3. Moving on to 4.4, which says, show that P is equal to negative 3. Okay, P is equal to negative 3. Well, we have the equation of this line now, and we know that the x value of the point C is 2. The y value is 3, so we can just do that. We're going to substitute 2 to get the y value into that equation. So y is equal to negative 2x plus 1, and we know c is 2 and p. So this is our x and our y. So we'll go ahead and substitute in place of y. P is equal to negative 2 times 2 and plus 1. So this is going to be P finally is just going to give us negative 2 times 2 is negative 4, and negative 4 plus 1 is negative 3. And there we go. So P is equal to negative 3. Moving on to the next question, 4.5. 4.5 says, show by calculation the equation of the circle is x squared plus y squared minus 4x plus 6y minus 12 is equal to 0. So they really just want you to find the equation of the circle. Equation of the circle. You see, in a circle, all you need to find the equation is you need the center and at least 1 point on the circumference, and then you're good to go. You can find the equation of the circle. But as you can see, the format they put it in, once we find it, we have to expand it. So let's go ahead and see. Well, right now we know what P is. P is negative 3. So we have that. We can use the center of the circle, and let's just use another point. I'll use A because positive numbers just seem easier to use than negative. So we can use that. We're using C and A. So this is what we have here. The equation of a circle is in your formula sheet, and it looks like this. Okay, so our center, that's what we start with. We substitute. That is your A, and that is your B value. So when we substitute, we'll just have x minus 2 all squared plus y minus negative 3, which of course becomes a plus 3 all squared, is equal to r squared. So you see now that this equation is almost complete, it just needs r. So to find r, we substitute this in place of x and y. So now we can go ahead and substitute that. So we're going to say our x value is 5 minus 2 squared plus y value is 1 plus 3 squared is equal to r squared. And you can substitute this into the equation to get the value of r squared. Then we can put it back into this equation. And we get that r squared is equal to 25. So 25 equals r squared. So let's put that back into this part. So we'll say therefore, just put it in and put r squared there. So equals 25. And remember, they want it in this format, so we need to expand it. So let's expand. You see where you have x minus 2 all squared, you can choose to go x minus 2 times x minus 2, which takes long. In math, you need to try and take shorter steps because it will help you avoid mistakes. You're human, so you can make little mistakes here and there. But the shorter the steps, the lower the chance of you making little mistakes. So what I'm going to do instead is use the quick method. You take the first term and you square it. That gives you x squared. Then you say the first term multiplied by the second term, which we can see would give us negative 2x. Then you multiply that by 2. So that gives you negative 4x. Then lastly, you square the last term, which is positive 4. Okay, so you do the same thing here. Square the first term, that's positive y squared. First term times second term, that's 3y times 2 is positive 6y. Square the last term, positive 9 is equal to 25. Okay, let's put it in the same order that they wanted. They first put the x squared, then we have the positive y squared, then they put the thing with the x, so minus 4x, which doesn't have any like term as you can see, then the positive 6y, Then we can say this positive 4. Well, I might as well just take that 25 over. So bring the 25 over, becomes negative 25 is equal to 0. So positive 4 plus 9, and that gives you 13. Then minus 25, 13 minus 25 is negative 12, okay? Because 25 minus 13 is 12. So negative 12 is equal to 0. So that is it for 4.5, and then we move on to the last question in question 4. Okay, so we're on the last question in question 4, 4.6, which says, calculate the values of t for which the straight line y is equal to tx plus 8 will not intersect the circle. Okay. Honestly, it seems like a visual question, so I'm going to bring the diagram down and just look at it quickly. So, for which it will not intersect, you see, if you have your circle and you have that equation, now we don't know what the gradient is. It could be an increasing function or a decreasing function, we don't know. But we just know that the y-intercept is 8. So that line cuts 8. And it goes like that, basically. It could be like that. It could also be the other way. So for you to find out for which values of t it will not intersect the circle, the only points, not the only, but the first point where it will intersect the circle, it will have to be a tangent to the circle. So it's like, goes like that, and then it touches the circle at one point, right? And then after that, it can kind of like move. Well, the way I drew it now, it's not going to move properly. I should draw it from here. So it's kind of like this. If this is your line, a visual example of this is looking at it like this. This line eventually is going to touch the circle. And then if it keeps moving like this, it will keep touching the circle. I keep touching the circle. And then it touches the circle one more time. Then after that, it stops intersecting the circle because it's far away, because it's away from the circle enough for it not to touch. But the thing is, to actually find this, we can continue looking at it. There's not enough data to find it like that, like if you try to find it visually. Okay, so especially because this is a circle and not a parabola, I feel like even if it was a parabola, it wouldn't also just be easy to, well, it would be better because a parabola, you can at least find the gradient of a parabola. So in this situation, I don't think we should be looking at it visually because it's not really working. But I only like to show this just so that you can understand what the gradient does, what that t value is doing. It only changes the slope, but it will forever cut 8. That's really what they're saying. Well, the line needs to cut 8. Okay, so I can't really find this because there is not enough data, or maybe I'm not really thinking it through properly. So I'm not going to find it like that. Let's look at a more equation way of looking at this. Fine. They said calculate the values of t, right? For which the straight line y is equal to tx plus 8 will not intersect the circle. Okay, how about we find out the values of t for which it, or let's make the line intersect the circle first, then find out the values of t for which it will not intersect the circle. So there's a reason they gave us this equation. It's actually easier to use in this case. So our line is y is equal to tx plus 8. And our circle is that x squared plus y squared minus 4x plus 6y minus 12 equals 0. Right? That's our circle. Let's go ahead and make them intersect first. Then we'll find out for which values of t they will not intersect. Well, for these two to intersect, it's kind of like making, well, this one starts with y is equal to, and this one has x and y. It's like making y equal to y. But you can't really make y the subject here. So what I'm going to do is treat this as a simultaneous equation. Okay? So if you treat it as a simultaneous equation, in simultaneous equations, what you're trying to find out is the points of intersection of the two graphs that they give you. That's what I'm going to do. Let's go ahead and take this, since it's a straight line equation, it's a linear equation, we can substitute it into this. So it's like taking equation 1 and substituting it into equation 2. Okay, so every time you see y in this equation, replace it with tx plus 8. So you have to be very careful here not to make little mistakes, because that's what they can catch us. So we're going to say this is x squared plus y Okay, I see y. So change. It's going to be tx plus 8. Now that's y squared. So this needs to be squared. Okay, and then we have minus 4x, then plus 6y. So that is again tx plus 8. I'm just trying to be careful because I can make silly mistakes. So we have x squared, and then let's work on this now. So I'm going to use that same way that I used to square this because it's so much helpful here so we don't make mistakes. Square the first term. You see they're both variables. So t will become t squared, and then x becomes x squared. That's squaring the first term. Then you say first term multiplied by second term. You see that will give you 8tx. Then you need to multiply that by 2. So we get positive 16tx. Then square the last term, which is positive 64. Okay, then we have minus 4x. Then let's distribute. That's going to be positive 6tx. And that's going to give us positive 48 and then minus 12. Now here, I don't want to make mistakes. Let's just go ahead and start adding like terms. Okay, that's all we have to do here anyways. So x squared. Funny enough, these two are actually like terms. If this was not a t squared, I might as well just leave them together. Let's just say x squared plus t squared x squared. Okay. Does anything else have a tx? Well, we have 6tx. Okay, so 16 plus 6 is, that's for 22. So we have positive 22tx. That's done. Okay, of course, we're also done with those ones. Then we have okay, let's hold on to the constant. We'll add these constants afterwards. So the last variable we have is minus, last thing with the variable, minus 4x. Okay, now our numbers. 64 plus 48, well, 60 plus 40 is 100, 4 plus 8 is 12. So that's 112, but then we have a minus 12, so which is positive 100 we have, is equal to 0. Okay, you can also just double check with the calculator as well, which I did. And so now we have, when I'm looking at this equation, it looks like it has like terms, but the t is really just disrupting it. So because the highest exponent on x is 2, it is a quadratic equation, which is very good because remember, we're just trying to find out the values of t for which these will not intersect. Okay, so since it's a quadratic equation, we can go ahead and use the discriminant, which I call delta because the symbol delta is called delta. Okay, so the symbol for discriminant is called delta. So we have this, and we can go ahead and, well, it is a quadratic equation, but it's not in its standard form yet. Remember that the quadratic equation standard form looks like this. It's ax squared plus bx plus c, meaning you need to have something which has a variable of x squared, which has a variable of x, and then a constant. I see that here. We just have to group certain things. So what I'm going to do is, this has x squared, this has x squared. Let's group that together. We'll take x squared out as the common factor so that we can see the coefficient of x squared. This one has x. Yeah, it has a t, but it has x and that has x. So we'll also group those two together so that we can also see that. And then that will just be our constant. So take x squared out as a common factor. And what is left? You'll be left with 1. And then here you're left with positive t squared. Okay, here, I know the highest common factor is not just x, but I'm specifically trying to get x out so I can see the coefficient of x. So I'm only going to take x out as a common factor. And what is left? So with 22tx, the x is already there, so we just have 22t, right? If you take 22t, multiply by x, you get back to that. Then here, what is left? Just a negative 4. And then plus 100 is equal to 0, which is perfect now. So now I can see that the coefficient of x squared, the a, is this number. That is our a. And then the coefficient of x, which is the b, is this number, because that's what's being multiplied to x. And then the constant is just 100. So this is b, this is 100. Constant is 100. Okay, so now we just need to find out the values of t for which it will not intersect the circle. Right now, it is intersecting the circle, but we need to make it not intersect the circle. To make it not intersect the circle, because you have a quadratic equation, we're going to tamper with the discriminant. If we make the discriminant equal to 0, you will have real roots here, meaning it will really intersect. Okay? So we don't want it to intersect. We don't want real roots. If you make it greater than 0, it will also have real roots and it will also intersect. But if we make the discriminant less than 0, then it's not going to intersect. And that's what we're trying to go for. So we're going to make the discriminant less than 0. So delta is b squared minus 4ac. I'm going to make that less than 0. Our b value we now know is 22t minus 4. So we say, I'm going to put it in blue, 22t minus 4, and we're going to square that because b is squared, minus 4, and then a. Well, a is 1 plus t squared, so 1 plus t squared. And then we have c. Well, c is 100, so you just put that in. 100 is less than 0. Okay, a lot of squares, and we just have to be really careful here. Let's go ahead. So the first thing we're doing is we're squaring 22t. Well, 22, square 22. 22 squared is 484. Okay, you could manually calculate it, but that takes long. You need a calculator here. Then that's 484 t squared, right? We squared that. Then you say 22t multiplied by negative 4, which is negative 88t. And then you need to multiply that by 2. So 88 times 2 is 176. So that is negative 176t. I'm just trying to be really careful here. Negative 4, square that. That is positive 16. Okay, done with that part. Let's keep moving. Okay, let's just be careful on how we're going to multiply this. I see that this can distribute in like that, but remember it's being multiplied all through. Let's multiply the negative 4 and the 100 first, which will give us negative 400. Then say that is being multiplied by 1 plus t squared. Okay, it's less than 0. Okay, so now we just have to distribute here. So we still have the 484 t squared. And then we have this. So that doesn't really have a like term with anything. So minus 76t, then plus 16. And then when we distribute here, we get negative 400, and then that gives us a negative 400 t squared, and that is less than 0. Okay, so now we just have to put our like terms together. So do you see that we have t squared and t squared? So that is 484 minus 400, which will give you 84 t squared. Then we have, this is the only thing with t again, so negative 176t. And then we have a positive 16 minus 400. So what does that give us? And we get negative 384. And all of that is less than 0. Okay. Now, at this point, this is a quadratic equation, as you can see. It's a quadratic inequality. Now we just really need to solve for the quadratic inequality. So I know there's definitely a common factor, and how I'll find out whether there's a common factor or not is I'm just going to take each of these numbers and see what they have in common. So if you take 84 is equal to, just see the factors it has, shift and factorize. I see it has 2 squared. You would probably have to do that and then write down the factors that you're seeing in common. Then I'll just say 176 is equal to, and shift and factorize. And then lastly, 384 is equal to shift and factorize. Okay, so do you see that all of these factors, they all have 2 in them? So between 2 squared, 2 to the power of 4, and 2 to the power of 7, what is the common factor that you have? That would be 2 squared. So it means 4 is common between all of them. So what we can do here in this inequality is divide both hand sides by 4. And then let's see what we get. So 84 divided by 4 gives you 21. So 21 t squared. Then 176 divided by 4, that gives you negative 44 t. And then the 384 divided by 4, that gives us negative 96 is less than 0 divided by 4 is still 0. Okay, so now we're at this point. We don't know if it factorizes or not. So what we can do is, instead of looking for factors, I will open up two brackets like I'm going to actually factorize. But I'm going to use the quadratic formula because we need to save time and rather just use quicker methods but still get marks for factorizing if they are given marks for factorizing. So how we'll do that is we'll use the quadratic formula. We just will not show them that we have used the quadratic formula. Okay, so this is the quadratic formula. So I'm going to put a fraction and I'm saying negative. Now we're going to say negative b. So bracket negative 44 plus minus, okay, I'm starting with plus, the square root of b squared, which is negative 44 squared, minus 4 times a, which is 21, and then times c, which is negative 96. And that goes all over 2a, which is 21. Okay, so we get fractions. Now here's how to work with stuff like this. I know in the past I've shown you guys how to use the quadratic formula on quadratic equations, but the ones that have x squared. So the ones with the coefficient, this is how it's going to work. Remember that that's giving you your critical value, meaning your solution for t, right? It's telling you that t is equal to 24 over 7. So how you're going to put it as a factor here is, you see the denominator. The reason you divided by 7 is because the 7 was in front of the t. So what you had before was the 7t, and then you see this 24. It's like taking it over the equal to sign and becomes a negative 24. Then you see now that if you said 7t minus 24 is equal to 0, then you'd have said 7t is equal to 24, and then you'd have divided both sides by 7, you see, to get that. So that's what we did there. And then to get this factor, the other one, we would just change that to a minus. And we get negative 4 over 3. Same thing. T is equal to negative 4 over 3. The denominator is your coefficient of t. And then you take that number as if it's coming over the equal to sign and becomes a positive 4. So there, it looks like we factorized. Okay, so we have our critical values and our factors as well. Okay, so these are the critical values we have. Now remember, this is a quadratic inequality and we're trying to solve for it. So also notice, because it's quadratic, it will form a parabola. But specifically, what type of parabola? Well, the value of a is greater than 0, so it would be a concave up parabola. So your parabola would be like this. You have your concave up parabola. Here's your x-axis. And so the smaller value is the negative 1, of course. So that's negative 4 over 3. That's your first root. Your second root is the 24 over 7. So your inequality is asking for the values of t for which the y value is less than 0. When we ask for values that are greater than 0, so if you ever see greater than 0, you would take parts of the graph that are above the x-axis. And if they say less than 0, this would be parts of the graph below the x-axis. So clearly, because our inequality says that our expression needs to be less than 0, we're only going to focus on the parts of the graph that lie below the x-axis. And so what are the values of x, or t rather, for this? So if I line this up to the x-axis, you see the values I get. These are values that are greater than negative 4 over 3, but less than 24 over 7. Okay, because that's the direction they're moving towards. That's these values that we see here. Okay, so we're going to therefore say that our solution to this is t needs to be greater than negative 4 over 3, but less than 24 over 7. And that would be our answer to this question. So it's a long one. Let's see why it's 6 marks. So that's the answer. And I can bring back the visual example back so that you can see what is actually happening. Okay, so this is what this means. Remember that this is the value of t, right? In that equation, y equals tx plus 8. Because this is in the form of y equals mx plus c, and you know c is your y-intercept, we know that the graph, the line, right, has to cut the y-axis at 8. Now, the t represents the gradient, and you know that if the gradient looks like this, it's an increasing function, so your gradient is positive. If it looks like that, it's a decreasing function, so your gradient is negative. So it means the gradient could have been various things. So now we know what the gradient should be for it to not intersect the circle. So this is an example of that. What's going on is that you have that line, right, passing that y-axis. And I'm going to just have to put it like this so that I can move it around. So when the gradient changes, it's going to change the slant or the slope of this graph. It's going to make it move around. So let's look at it like this. When the value of t was exactly -4/3, because this is a negative gradient, it will probably have been this one, right? So it was probably touching the graph at one point here. Then when it became greater than -4/3, it starts to increase. What happened is that your graph started to increase in gradient, okay? When it started to increase, it maybe just did this, right? And then it had to just be lower than 24/7, which is a positive gradient. But then if it went anything beyond that, what would have happened is that your graph would have started intersecting the circle. It would have first intersect the circle at one place here. Then if you keep moving, it will intersect here and there. Keep moving, intersects, here and there. And that's really what's going on. Okay, let me also just show you on Desmos what's actually going on so that it's not like I'm just making this up. Okay, so here on Desmos, here is the equation of the circle, and here I just put x plus 8. So we will put coefficient or gradients for that graph. You see what happened is when I substitute -4/3, so if you substitute -4/3 there, do you see what happens? It's a negative gradient and it intersects the graph at one point. We were specifically looking for values of t where this graph will never intersect the circle. So that's why it can't be equal to -4/3 first of all. So when we put it like that, that's what happens. How about, because we said that t needs to be greater than -4/3, right? So it should get bigger from -4/3. Let's substitute a value bigger than -4/3. -4/3 is -1.33. If you move on a number line, you can try -1, which as a fraction is -3/3. So look at what happens when we do that. You see how that graph moves away from the circle? It stops intersecting the circle. And if you try something bigger, like -2/3, it goes even further away. And you could do this and you'll see that it just keeps moving and moving, like the way I was trying to spin it around to show you what was going on. We can even try it from this side. When it is 24/7, let me substitute that there, and then let's see what it does. So you see what the graph does at 24/7. And then, of course, if you start to, because in this case, t needs to be less than 24/7. So if you start to decrease that, so anything lower on the numerator would decrease this because this is an improper fraction. So let's say we try 20, right? Let's try that 20/7. You see how it moves away. Okay, so values that are less than 24/7 are working there. If I change that to maybe even something like 15, see, moves further away. So it was a very interesting question. So that is a visual example of what's actually going on and what the gradient really does to a line. In the diagram, we have triangle ACD has the vertices where we have A being just A, and then D is 3 and -9, and C is -9 and 0. So that is on the x-axis, where A is a point in the second quadrant, okay? And they tell us that B, which is -1, and K, that lies on the side DC, as we can see there. Okay, so the first question is calculate the gradient of DC. Okay, so how do you find the gradient of DC? Well, as you can see, we have 2 points, so we can find the gradient using the gradient formula. So the gradient is equal to y2 minus y1 over x2 minus x1. Okay, so with this, just make sure to be consistent. If you start with this as your x2, then that needs to be your x1. You cannot say this one minus that one and then this one minus that one, okay? Then that's where the mistake happens. Okay, so we're just going to say it's y2 minus y1, so we can just say 0 minus -9, which is 0 minus -9, right? And that just becomes a +9 over, and we have -9 minus 3. So -9 minus 3. And let's just see what that gives us. So the gradient there is, we have 9 over, and that gives you -12. Then we just have to simplify that. So looking at them, they both have a highest common factor of 3. So if you divide by 3 on the top and bottom, 9 divided by 3 is 3, and negative 12 divided by 3 is negative 4. So that is our answer. The gradient of line DC is negative 3 over 4. Moving on to the next question. Then our next question is to determine the equation of DC in the form y equals mx plus c. Okay, so find the equation of DC. We already have the gradient of DC, so to find the equation, we can use the y equals mx plus c formula, or you can use this one, y minus y1 is equal to m times x minus x1, which I honestly prefer using. Okay, so all we really need here is we just need the gradient and 1 point on the graph. That's going to go in place of x1 and y1. So we're going to go ahead and just pick the easiest point really. So the easiest point here would be the C. So negative 9 and 0 can be our point. So keep that negative 9 and 0. That's our x1 and that's our y1. So that is y minus, and the y1 is 0, is equal to, our gradient is negative 3 over 4 multiplied by x minus, and that is minus negative 9, which becomes a positive 9. So we just have to simplify. Y minus 0 is just going to stay y because it's y minus nothing. And then we're going to distribute here, which is negative 3 over 4x. And distribute, you can see that if you say negative 3 over 4, they don't have anything in common like diagonally, so it's just going to multiply. Negative 3 times 9 is negative 27, so over 4. And that's just our answer. That is the equation of line DC. Okay, moving on to the next question. The next question, 3.3, says, show that k is equal to negative 6. Okay, so where's k? K is over here. And do you see that it lies on line DC? So because it lies on line DC, you can use this equation to actually find that corresponding y value, because that's what k is. It's a y value that belongs to this x value of negative 1. So substitute negative 1 in place of x and you'll get your y value. Or you can just substitute the negative 1 and k in place of x and y. Okay, so we can just say the point B is negative 1 and k. So we're going to take that as our x and that as our y value. So this is our equation. In place of y, we're going to say k is equal to negative 3 over 4. And then in place of x, we say negative 1 minus 27 over 4. Okay, so this is, we just have to solve and simplify. So that's going to give you positive 3 over 4 minus 27 over 4. 3 minus 27 is negative 24. So that's negative 24 divided by 4. 24 divided by 4 is 6. So that is therefore k is equal to negative 6. Okay, because it's negative. So there we go. That is our answer. And moving on to the next question. Now 3.4 says calculate the length of DC. Okay, yeah, they put in a lot of focus on that line DC, but our points are 3 and negative 9, and C is negative 9 and 1. So just put that down. 3, negative 9, C is negative 9 and 0. Okay, it's on the x-axis. Okay, and we're just going to find the length. So you need the distance formula, which looks like this. And we're finding the distance of line DC. Okay, so x2, that's going to be our x2. So we say 3 minus x1, which is negative 9. So it's negative 9. And if you distribute, it will become a positive 9. So all squared plus y2, which is we have negative 9 minus 0 all squared. Okay, so you're just going to have to simplify this and find that answer. So this is equal to 12. That's going to be 12. 3 plus 9 is 12. So 12 squared is 144. Negative 9 minus 0 is negative 9. Squared is 81. And so if you add these two together, we just need a 60 from here. If you add that 60, that's going to be 204, but you'll be left with 21. And that's 225. Okay, so you're going to have 225, the square root of 225. Which is 15. Okay, so distance of DC is equal to 15 units, and that is the distance. Okay, moving on to the next question. 3.5 says calculate the ratio of dB over DC. Okay, so dB over DC. Let's just see where that is. Okay, so DB over DC. We already have DC. We found that to be 15 units. So all we need to do is find DB. Okay, and we already know what K is. K was -6. So we have D, which we remember, and as you can see here, that's 3 and -9. And B is -1 and -6. Okay, so we just need to find that length. Then we can put them over each other. So again, the distance formula, but we can just substitute at this point. So x2 minus x1, we can just say 3 minus -1, which is +1, all squared, plus y2 minus y1, which is -9, and that becomes minus -6, which is +6, all squared. And we can also just find this. So square root of, that gives you 4 squared, which is 16. This is going to be -3 squared, which is 3 squared is 9. So that's +9. 16 plus 9 gives you 25. So that is the square root of 25, which is equal to 5 units. Okay, so we know what dB is now. And so that would mean that dB over DC is going to be equal to, we're taking dB as 5 units. DC, we remember, is 15 units. So over 15, and that would just simplify to, they both have a common factor of 5. So divided by 5, 5 divided by 5 is 1. 15 divided by 5 is 3. So the ratio is 1/3. Okay, moving on to the next question. Okay, we are on 3.6, and it says, if M is a point on AD such that AC is perpendicular to MB, calculate the ratio of triangle MBD over triangle ACD. So you can kind of already see what they're doing here. They're taking this triangle and they're saying if there's a point M on AD, okay, such that we have AC, right, that line being parallel to that new line that gets drawn. Okay, so that's M over there. Okay, so yeah, we can actually just do that. So we put down M here, and then if you connect them, they are saying such that these two lines are parallel. Okay, so we have parallel lines there. Let me just put it like that, at least M. Okay, parallel lines. And now we need to find triangle MBD. Let's just be sure about that. MBD over triangle ACD. Okay, so MBD. What does that look like? That's over here. MBD, the smaller triangle, over ACD, which is the bigger triangle. So that one over there. That's really all they're saying. Okay, so just remember that these are specifically speaking about the areas of the triangle. So there are two ways to find the areas of triangles. You can use a half times the base times the height. But as you can see, we don't have a height. We don't have any perpendicular height in any of these triangles. So we can use the second method of finding the area of a triangle. If you have a triangle, and let's say this triangle is called ABC. To find the area of this triangle, you can use the area rule. And that looks like this. A is equal to a half multiplied by the one side. So let's say you were given the angle A. Okay, so it's a half multiplied by the side next to angle A multiplied by the other side next to angle A, which is AC, and then sine of angle A. So that's how it's going to work. Now with these ones, you will notice that these two triangles are actually sharing a common angle. And that angle that they're sharing is D. And that's going to be our advantage. That's what we're going to take advantage of. The fact that they're both sharing that. So you see by where we have sine angle D when finding the areas of these two triangles, right? They're going to eventually divide by each other and cancel. And we'll just be left with whatever units was there. And those would divide and we would get the ratio at the end of the day. Okay, so let's go ahead and do that. Let's see what we have with these two triangles. In the blue triangle, we have, well, we just found this. We found that BD is 5 units, okay? And we know DC is 15 units. But we also know now that BD over DC is 1/3, like we saw here, okay? We simplify that to 1/3. So what we can do with that is, because we have parallel lines, we can use the proportionality theorem to get ratios for this side, okay? Now, let me not just jump to conclusions. The whole point with getting these sides ratios is because you see how they're both sharing this angle, angle D. Okay, because they are both sharing that angle, we're going to take that side over that entire side. Okay, and see how they're both sharing this angle, angle D. Okay, so when you're looking at finding the area of that, you're going to have to use this side, and that center angle. Likewise, with a bigger triangle, you're going to have to use this side, and again, that center angle, angle D. Okay, so that's why we would find these ratios. Okay, so first of all, we already know that DB over DC is 1 over 3. So we're going to actually write the ratios down, but let's actually just put it down so that we can write the proportionality theorem. Well, this is not really Euclid, so you don't have to give reasons. So when we're looking at those two triangles, we can also just tell them that DM over DA, that is going to be equal to 1 over 3. Okay, so DM over DA is equal to 1 over 3. And the reason why is because you can see that BD over DC is equal to 1 over 3, simplifies to 1 over 3. Okay, and so these two, that's really the proportionality theorem, because we have a line drawn parallel to one side of the triangle. So it makes those two sides to be in proportion. So if we know that DM over DA, right, is 1 over 3, that is DM over DA. How you can write that down as ratios, because we don't actually know what the value, okay, of these ones are. We don't know the length of the line, but that is fine because we can still work with this. So what we can actually do is we're going to name them according to what their ratios are. You see that DM has the ratio of 1. So you can give it a variable value, okay? So you're saying whatever this line is, right, that DM is going to take one part of it. So I can call that A. And that DA is going to take 3 parts of it. So we can call that 3A. Okay, so there we've already named them. And now we can actually use this in that area formula. So remember that we're just trying to find the area, okay, the ratio of the area. So the area of triangle MBD over the area of triangle ACD. Okay, so that is equal to, and we're going to say, so the area of triangle MBD, that's the smaller triangle. So the formula for that area is a half multiplied by, and you're going to say the side length, okay? So since we have already seen that this angle D is the center angle and it's been shared by both triangles, we're going to focus on that as the available angle that we have. So we're going to use the side lengths or ratios that we see. So you see that MD is A, so a half times A multiplied by the side length of 5, okay, and then sine of the center angle, which is angle D, over, same thing here with the bigger triangle. So it's again a half multiplied by the side ratio that we have, okay, because we don't have the length, but we have a ratio. So 3A multiplied by the side 15 units, and then sine of, again, angle D, because it's also sharing that angle, and that's the angle that we have, or the angle that we've chosen to use. Okay, so that's what we have, and now we don't really need that anymore. And if you simplify this, this is what you're going to get now with this. So do you see that a half and a half, they would divide, okay, and become 1, and then A and A would also divide and cancel. And it's still that 1 over 3 that is there. See, 1 on top and the 3 on the bottom. That's exactly what would have happened regardless of whatever length it was. The ratio was 1 over 3, meaning it is shared, as in the one line gets one part of whatever the full length of that line is, and then the other line gets 3 parts. That's just really the ratio that it's been shared in. Okay, so that's why it doesn't matter whether they give you the ratio or the actual length of the line. And then here, we'll leave that for now, and you see that sine of angle D and sine of angle D would cancel. So all you are left with there is really just a 5 on the numerator over, and on the denominator you're left with 3 times 15, which is 45. Okay, these are factors. We have a common factor of 5. 5 divided by 5 is 1. 45 divided by 5 is 9. And that's our answer. 1 over 9. Okay, that is it for 3.6, and we move on to 3.7. Okay, we are now on 3.7, and 3.7 says, if it is further given that the gradient of AD, okay, the gradient of AD is -4, and the length of AD, okay, length of AD is the square root of 612 units, calculate the coordinates of A. Okay, let's see what this looks like. They're giving us a lot of information about the line AD. Okay, we don't really need these anymore. So AD, they tell us the gradient of AD and the length of AD, which is that 612, right? Those are the two things they tell us. So how can we use this to find the coordinates of A? So the thing is, we should try not to get stuck here, because the thing is, they're given a lot of information. They gave the length of the line and the gradient of AD, -4. Okay, that is a lot of information. And we just have to see how can we use it to find A. Okay, so we're not going to find that by guessing. But what we can do is, when we look at A, right, it's a point in the second quadrant, like they also said. How can we find the point A? What are the things we would have needed to find the point A? Well, for us to find the point A, because it lies on this line, at least if we had an X or Y value, we would have been able to find it, okay? But then giving us an X or Y value is already too simple. It's like this one. So what do we actually need? They gave us the gradient though. If we had the equation of the line, I guess, and we had one point, we could find it. However, we don't have the equation of this line. We do have the gradient though, and the gradient can be used to find the equation of this line. Okay, so we can actually try attempt to find the equation of this line using what we have. So we know the gradient. Okay, we actually can. We can find the equation of this line because we know the gradient and we have one point on the line D, okay? Because it's the line AD. So we can find the equation of this line. And then when we find the equation of the line, how can we use it to find what exactly A is? Okay, that's probably where this comes in. They gave us the length of that line. So if we find out what the equation of the line is, let's say it's y is equal to, I don't know, 2x plus 3, for example. It's obviously not, it's a decreasing function, so it can't be. So let's say negative 2x plus 3. And let's say that was the equation of the line, right? What we could actually do here is, even if we don't have this full point, look at how we can actually use this point. Because we don't know what this is right now, we can call the x value, we can call it x, and the y value is y. However, you see that we have y is equal to negative 2x plus 3, right? So we could just substitute that as the y value, 2x plus 3. And there, now you have a point that is in terms of x. If you use that, okay, and you use the distance formula to find AD, because we already have the length of AD, it will become an equation that will be in terms of x. Okay, so that is really just the logic behind it. Let's go ahead and actually apply this now. So we have everything that we need. So the first thing is find the equation of line AD, because you've been given the gradient and you have one point on the line, which is 3 and -9. Okay, so let's go ahead and do that. We're just going to say that the gradient of AD is -4, like they told us, and we already know D. Okay, that D is that point, 3 and -9. So the equation of this line, y minus y1 is equal to m times x minus x1. And this is y minus, and that's -9, so it becomes a +9, is equal to -4 times x minus, and that's a 3. And then we just simplify. So this is equal to, let's distribute -4x. That becomes a +12. That comes over and becomes a -9. And we're left with the y here. So y is equal to -4x, and 12 minus 9 is +3. +3. Okay, so that's what we have there. Okay, that looks good. And now we can just take this like we have this, right? We know that A is unknown, so we don't have the x or the y value. However, we can give it an x and y value. We can call the x value x, and because the y value is y, what does y stand for? What is y equal to? It's equal to negative 4x plus 3. So we say negative 4x plus 3. We'll hold that as our y value. Okay. And remember, they gave us the length. The whole point is we're going to use the fact that they gave us the length of AD to find this. Okay, so we have this as our coordinates for A, and D is what? D, we already had that, which is 3 and negative 9. So because they gave us the distance, right, of AD being square root of 612, we're going to use the distance formula. So the distance, and we put down the formula, and we're going to have that AD, well, I can just call it AD. We know what AD is already. The distance is the square root of 612. So we can say square root 612 is equal to, and here we're just going to substitute everything that we have. So that is going to be the square root of x2 is, well, I'm just going to take that. These ones is x2, so it's x minus 3 all squared plus, and then y2, again, top minus bottom, so negative 4x plus 3 minus negative 9, which of course becomes a plus 9. Okay, all squared. So it's really just simplifying here. That's all we have to do. Okay, we have a square root on both sides. You can actually just get rid of it by squaring both sides. And we're going to now have that 612 is equal to, and that breaks open as well. And you now have this in here. Okay, but we can just work on already distributing. So you have x minus 3 all squared. Square the first term, that gives you x squared. Square the last term, that gives you positive 9. Then say double of the first term, which is x, multiplied by the second term, which is negative 3. Okay, x times negative 3 is negative 3x, times 2 is negative 6x. Okay, so we have that done. And then here, that just needs to be simplified. So plus negative 4x, 3 plus 9 is 12. So plus 12 all squared. And then we'll also just distribute that. Okay, so I mean, we can take that 612 over now already. It's fine. So that's going to be x squared minus 6x plus 9 minus 612. I can just see it as 9 minus, it's just going to become negative. So just say that minus 9. Okay, 12 minus 9 is 3. So that's 603. That's negative 603 that you're going to get there, negative 603. And then we can just go ahead and distribute that. So that's going to be the first term squared, which is 16, positive 16x squared. Last term squared, positive 144. And then first times second term, and then times 2. So double first times the second term. That's really what we're saying. Okay, first time second term, that is going to be negative 48. 48 times 2 gives you 96. So that's going to be negative 96x. Okay, you can just make sure with a calculator. I don't know, these days I don't really feel like using the calculator too much, because I'm trying to rely more on my brain rather than always using the calculator. I feel like it makes you less confident sometimes, but do it when practicing. Okay, in the exams, the calculator is your friend. Make sure to always double check. Okay, and then we can just simplify. 0 is equal to, and so we're adding these two together. So that gives you 17x squared. And let's see, this and this. Okay, that's like saying 96 plus 6. 6 plus 6 is 12. That's 10. So 102. So that gives you negative 102x. And we're done with that. Okay, and then we have the constants. Okay, so because it's negative 603, right? Plus 144, you can use the calculator, but 603, and we're just going to say minus 144. But we're just going to remember that the answer is going to be negative at the end of the day, because you're taking a negative number and you're adding a positive that is not as big as the negative. So it's not enough to make it positive. Okay, so that borrowing. Okay, so 5. Can give this one the 9 and that one the 10. So that gives you the 100. Okay, so that is 13 minus 4, which is 9. 9 minus 4, which is 5. And 5 minus 1, which is 4. So 459, right? So that is going to be negative 459. Okay, and it is equal to 0, as we can see. So then we have these three. Yeah, at this point, I'm just going to use a calculator because really no use stressing yourself. Okay, so we have to factorize this and it looks complicated. However, I will say an advantage here. The fact that we have 17 in front of x squared. Okay, 17 is a prime number, so it can't really divide by anything other than 1 and 17. So it's probably the case that all of these, right, are multiples of 17. Okay, so we'll have 17 in them at least. So we can actually check that out. 102, I'm already going to say, yeah, let's just divide both sides by 17, but we'll also just verify. 0 is equal to, that would be x squared, and then 102 divided by 17, okay, that's a factor, that works, is negative 6, so it gives you negative 6x. And if we change that to 459, 27, okay, so that works out. So they actually do work. They have 17 as a factor in them. 27. So negative 27. And now we can just factorize this trinomial. Open up two brackets is equal to 0, x multiplied by x, and then factors of 27 that can give us negative 6. Okay, that can be 9 and 3. So negative 9, positive 3. So that still stays negative when you multiply them, but negative 9 plus 3 gives you negative 6. Okay, so that works out fine. Minus 9 plus 3. And then solve for x. It therefore means that x is either equal to positive 9 or x is equal to negative 3. And now we're going to decide. Remember that this is the value of a we're looking for, right? What did they tell us about a, or where is a really? Okay, so you can see where A is. It's in the second quadrant, and they also said so. A is a point in the second quadrant. So we got the x values. Do you see that in the second quadrant, it would have a negative value. So you have to take the negative 1. So the answer here would not be the 9, it would be the negative 3. So that's the A value, and then we need to find the Y value of it. So you have the x value. How do you find the Y value? We already have the equation of that line, okay? Substitute it into this equation, which is negative 4x plus 3. So we're saying y equals negative 4, and in place of x, negative 3 plus 3. Okay, and that gives us, that's going to be positive 12 plus 3, which is 15. So A is negative 3 and 15. And there we go. Okay, so that is it for question 3.7, and that is it for question 3. And we move on to question 4, which is on more analytical geometry. We are on question 4, and question 4 says, in the diagram M, which is 1 and 3, as you can see, is the center of the circle. The circle cuts the x-axis at N. ST is a tangent to the circle at P, as we can see over there. Then we have R, which is D and 1, with D being greater than 0. Okay, so it's just positive. It's on the positive side. And L lies on the circle. So L lies on the circle. O and V are the x-intercepts of PL and RL respectively. Okay, so we have O and V, which are the x-intercepts of their respective lines. The first question is, write down the coordinates of L. Okay, let's look. Where is L? So L's over here. And as you can see, they told us that M is the center of the circle. So that makes PL a diameter and M is the center. We can use the midpoint formula to find this. So we're looking at this as if this L, right, the X and Y value will just be X and Y since it's unknown right now. And we're actually just finding or working through this as if we're finding the midpoint of PL. Okay, so the midpoint of PL, we will find that by saying x1 plus x2 over 2 and then y1 plus y2 over 2. But here's the thing, we already have the midpoint of PL. That is M. So we're going to replace that with midpoint of PL. That is M. And we can just tell them that is that 1 and 3 that we have. And it should be equal to the midpoint of PL because it is the midpoint of PL. So this is the way we find the midpoint of PL, and that is the actual midpoint, okay, of PL. So we're looking at it as x1 and x2. We'll take that as x1. So that is x plus the second x value, which is 3, x plus 3 over 2, and then y1 plus y2. So that's y plus 9 over 2. Y plus 9 over 2. Okay, so one is the actual midpoint of PL. The other is the way you find the midpoint of PL. So they would be equal to each other because they both represent the midpoint of PL. So because of that, we're going to equate them. This is an x value. Because they're equal, the x values are exactly the same. So you're saying that 1 is equal to x plus 3 over 2. And again, because they're exactly the same, the y values should also be the same. So 3 should be equal to y plus 9 over 2. Okay, so here you can just go ahead and multiply both sides by 2. If you do that, you're going to get 2 is equal to, but on this side, the 2 will cancel. Okay, so we get that, and that's just going to be, now we're left with the x plus 3. Then take your 3 over, and so that's a 2 minus 3 is equal to x. Therefore, it means that x is equal to negative 1. Okay, so we have the x value there. Now the y value, again, we're going to do the same thing. You're really just multiplying both sides by 2, and so that gives you a 6 is equal to, that cancels with that, and now we have 9 y plus 9, right? And then take the 9 over. So that's 6 minus 9 is equal to y. Therefore, y is equal to negative 3. And that means that this point over here, the end point L is negative 1 and negative 3. Makes sense for where it is. Okay, so that is the first question. Moving on to the next question. The next question, 4.2, says, determine the equation of the tangent ST to the circle P. Okay, let's look at that. The tangent ST to the circle P. We need to just find the equation of this line. Okay, they told us that it's a tangent. So what do you know about the tangent? And do you see that from M to P you have a radius? Okay, what do you know about a tangent and a radius? A tangent, okay, is always perpendicular to the radius at the point of contact. So because they're perpendicular lines, okay, there's something we should know about their gradients. If you take the gradient of two perpendicular lines, right, and you multiply them together, they will give you negative 1. So we can actually use that. So that means that if you want to find one of those gradients, let's say it was M2, let's say it was M1 you were looking for, you would divide both sides by M2. Okay, so the gradient of the one line will be equal to negative 1 divided by the gradient of the other line. Okay, and that's really what we're doing here. So the first thing we're going to find, because we need the equation of this line, that's a tangent. Okay, we don't have the gradient of that. However, we can find the gradient of the radius. M to P gives you your radius. So we're going to take those 2 points and find the gradient. So M, that is just 1 and 3 like we saw. And P is 3 and 9. So 3 and 9. Let's find the gradient. So we can say gradient. I don't think we really need the formula. We already wrote it down before. So we're going to just say 9 minus 3 over 3 minus 1, which is 6 over 2, which gives you 3. 6 divided by 2 is 3. So the gradient of that line is 3, right? The gradient of the radius is 3. So to find the gradient of the tangent, we just say m of radius. So it means that the gradient of the tangent can be found by saying, again, remember, it's negative 1 divided by the gradient of the radius. Okay, so it's negative 1 over 3. You can also do that whole gradient of radius times gradient of tangent equals negative 1, and then actually make the gradient of the tangent the subject by dividing both sides by the gradient of the radius. Okay, but we have that now. Now that we know the gradient of the tangent, okay, got the gradient, you see that to find the equation of this tangent, you already have a point. So we can just use that point and the gradient to find it. So the point is P, 3 and 9, which we have here. And we can just go ahead and use y equals to, let's just use y equals mx plus c, since I always use the other one. So that's your x and that's your y value. That's P, the point on the tangent. And we're going to say 9 is equal to, and we have the gradient being negative 1 over 3. And then the x value is 3 plus c. So we're just solving for c here because we already have the gradient as -1/3. So when you multiply these two together, your numerator and denominator cancel and you're left with -1. So that's 9 and you have -1 here. But if you take it over, it becomes a +1, which gives you a 10 is equal to c. Okay, so that means your equation is y is equal to, your gradient was -1/3x, and your y-intercept is +10. So that is the equation of that line, okay, the tangent. Moving on to the next question. Okay, 4.3 says, show that the equation of the circle with center M is equal to this. So we just have to find the equation of the circle. So to find the equation of a circle, all you need is the center and 1 point on the circumference of the circle. So we can just use these 2 points, okay? M and P, and let me just write those down. Okay, and then the equation of a circle, right? The standard form is x minus a, which is the center, squared plus y minus b, which is the other coordinate, the y coordinate of the center, squared, is equal to r squared. Okay, so now that we have this, we can go ahead and substitute the center. Because m is the center, that is going to be the a and the b value. Okay, so we can put that there. So that's a and b. So that's going to be x minus 1 all squared plus y minus the b value is 3. So all squared is equal to r squared. So as you can see, this equation is almost complete. It just needs the r squared value. So to find that, you can substitute the other point in place of x and y, because that's an x and a y coordinate. So we're going to say 3 minus 1 all squared plus 9 minus 3 all squared is equal to r squared. And so 3 minus 1 is 2, 2 squared is 4, and 9 minus 3 is 6. 6 squared is 36, and together they give you 40. So that's equal to 40. Okay, now that we have r squared, you can substitute it into the part that just needed the r squared. So that is going to be complete. So we have x minus 1 squared plus y minus 3 all squared is equal to 40. Okay, now at this point, do you see that they distributed? So we're also going to have to do that. So let's go ahead and work with this. We square the first term, which is x squared. Square the last term, which will give you +1. And let me just make space. Okay, so that's x squared. Last term squared is +1. Then to get the middle term, you're going to say double of the first term multiplied by the second term, which if you multiply, it's going to give you -2x. Okay, same thing over here. First term squared is +y squared. Last term squared is +9. And then double of the first term times the second term, which is -6y, okay, is equal to 40. So this is what we have. And you see that the way they wrote it, they wrote x squared and then y squared first. So, and then the x and then the y. So we're just going to rewrite it like that. So therefore, it means that x squared plus y squared minus 2x minus 6y. Then we have a +1 plus 9, which gives you 10. So that's 10. And we can take the 40 over. Minus 40 is equal to 0. Okay, because they also just left the right-hand side equal to 0. So this is x squared plus y squared minus 2x minus 6y. 10 minus 40 is -30 is equal to 0. And that is the equation of our circle. Okay, so that is it for 4.3. And then we move on to the next question. Okay, 4.4, we are told to show that D is equal to 7. Okay, so the D they're referring to is this by R that we have over here. So we have to show them that this is equal to 7. Okay, let's just look at what we have. First of all, do you see we have a Y value, and that's great. That can really help us a lot. Now, to find this, let's also just complete the other things that we have. We know the value of L. We know that L, the coordinate, is -1 and -3. Okay, so we know that already. So we can just fold that in. Those are -1 and -3. And now to find R. Okay, so I see a big thing with Euclid here. Do you see that because this is a diameter, the angle supported by the diameter at the circumference is always equal to 90 degrees. Okay, so because of that, we can actually use that. Now, we don't actually have to tell them that because that would really just be a reason. The only thing we can tell them is that you see this line PR, it is indeed perpendicular to LR. So we can start off with that. So PR is indeed perpendicular to LR, and then we have that. Now, because the lines are perpendicular, this is very helpful. So we have this point, it's complete. We also have this point, it's also complete. This one is only missing one value. That is good. It's only missing an x value. So it's a situation where we can create an equation, kind of like how we did here, right? Where we created this equation in terms of x. It's a very similar situation. But what we're going to use here is the fact that these lines are perpendicular. So what do you remember about perpendicular lines? Which is what we spoke about, really. So they really just focus in on the same ideas and the same rules, really. So we know that if these two lines are perpendicular, then it means that the gradient of PR multiplied by the gradient of LR would give you -1. This is an equation. So we're going to go ahead and formulate expression to find the gradient of PR, the gradient of LR, but they would be, of course, because you see PR, it's going to be in terms of D. But the gradient of LR is also going to be in terms of D, but that is perfectly fine because they're both just going to be in terms of D. And then it's equal to -1, and then that gives you an equation in terms of D that can help you to solve for D. So that's really what we're going to do here. Okay, so let's go ahead and do that. Gradient of PR times gradient of LR equals -1. Okay, so let's go ahead and find that. So we're going to say gradient of PR, that's y2 minus y1. Let's just focus on a specific format. So here with this one, I kind of want D to just always be in front. So I'm going to say 1 minus 9. So 1 minus 9 over x2 minus x1, which is going to be D minus 3. Okay, so I'm going up like that. Multiply by the gradient of LR. So with gradient of LR, again, I want D to be, in front. So I'm going to start with this being the y2. So that's 1 minus -3, which becomes a +3 over, and then D minus -1, which is D plus 1, is equal to -1. Okay, so as weird as this equation looks, we can actually use it to solve for D. So let's just simplify what we need to simplify. 1 minus 9 is -8 over D minus 3. And then multiply by, that's going to be 4 over D plus 1 is equal to -1. So we are multiplying fractions. When multiplying fractions, you can simply just multiply the numerators, which would give you, that is like -16 times 2, -32. And then over, now multiply the denominators. Now the denominators are binomials. So how you can multiply them is really like this. So say D minus 3 multiplied by D plus 1 is equal to -1. Okay, this is looking good. At this point, because we have an equal to sign, we can actually cross multiply. But how I'm going to think about cross multiplying is, let's actually just tamper with this -1. Okay, I see it's -1, but we're going to put it over 1 so that it's a fraction. And then I'm going to take that negative and actually give it to the denominator. Here's why. When we multiply across, we're saying -32 times -1, and then that gives us +32 is equal to, and then we're saying this D minus 3 and that, right, times the 1, and it'll stay exactly the same. D minus 3 times D plus 1. There we go. Okay, now we can just work on solving for D, which we know will have two solutions. So there's still a 32 here, meaning you need to distribute before factorizing. So that's going to be D squared multiplying by FOILing, and then plus D, and then minus 3D, then lastly -3. Okay, we can bring that 32 over. So minus 32 equals 0. Now we have D squared, and that becomes -2D. And what is -3 minus 32? That's -35. Is equal to 0. And we can factorize now. Is equal to 0. D times D gives you D squared. And then factors of 35, that can give you 2. I'm already thinking of 7 and 5. 7 and 5. Okay, 7 times 5 is 35. And then If you say negative 7 plus 5, that gives you negative 2. So we're going to go ahead and put negative 7 here and positive 5. Okay, so therefore this means that D is equal to 7 or D is equal to negative 5. And we can look in the diagram to just see where D is. And I remember them saying something about D. Yeah, they told us that D is greater than 0. So keep that in mind. D is greater than 0. So we cannot take the negative 1. And so we're going to leave that one and tell them that this is our answer. So you can tell them, but D is greater than 0 and say, therefore, D is equal to 7. Okay, so that is our answer for D. That is 4.4. And moving on to the next question. Then we have 4.5, which says calculate the size of angle L. Okay, there is angle L. Angle L is over here. So I'm also just going to fill that in. That is 7 now. So we're calculating the size of an angle in analytical geometry. I'm not even going to try to look at it through an Euclidean geometry angle. I don't really have to do that. That's also 90 degrees, okay? And that's 90. Just make sure to include everything that needs to be there. So rather than looking at it like that, I'm going to already look at it as if we were just dealing with this in analytical geometry only. What you can do to find out how an angle is created, because you see, angle L is this angle over here. It's not a simple angle of inclination. So you have to find out how it was created. So you're going to first of all draw at the point of L, right? You will draw an imaginary x-axis. So a line going through like that passes L. Okay, so it's parallel to the original x-axis because it's just another x-axis. And now we can actually find out how this angle was created. So look at it like this. You see this angle L? It's this angle over here. How do we create that? Well, if you found the angle of inclination of the line of this line, so you see going from the x-axis to that line, and that is the diameter, okay? So we can say the line PL, okay? If you found the angle of inclination of that line, and then you found the angle of inclination again from the x-axis to that line, let's just change the color, x-axis to that line. Do you see, okay, that line LR? Do you see that if you subtract these, you're going to be left with this angle? So we're really saying this entire angle, right, minus this angle gives you this angle of angle L that we're looking for. And that is how we would find angle L. So angle L will be found by finding the angle of inclination of the bigger line or bigger angle, right, that line there, PL, minus the angle of inclination of that smaller one, LR, and we'll be able to find it like that. Okay, that looks good. And I remember I was working with LR previously, so this should be fine. Let's go ahead and do that. Okay, so that is what we're going to deal with. Let's see, how can we actually find those angle of inclination? To find the angle of inclination, you need the gradient of the line. So to find that angle of inclination, we'll use this formula. Tan of theta is equal to the gradient of that line. Okay, so all we have to do is now find these gradients. So the gradient of PL and the gradient of LR. Let's start with the gradient of PL. So with the gradient of PL, let's see, where is that? Well, do you remember that that is the diameter? If this is the diameter and that's the gradient, if you knew the gradient of PM, which we do know, then you know the gradient of PL because they lie on the same line. They're collinear, so they have the same gradient. So what is the gradient of PM? We knew that. That was the gradient of the radius that we found here. Okay, the gradient of PM was 3. See, PM. So we know that. Okay, so we know that one already. So check. I'm just going to say we know that that gradient is 3. So gradient of PL equals 3, since it's the same thing as the gradient of PL. The only calculation or the only thing we can show them there is really just telling them this. Okay, gradient of PL is equal to 3, which is the gradient of PM. Same thing, equals to 3. And then now the gradient of LR. Now that one is something we were trying to calculate here. See, gradient of LR. So you see at this point it was incomplete. We can just take it from here. But we know what D is now. So now we will be able to substitute that and we'll know exactly what the gradient of LR is. So gradient of LR is equal to, and we'll just rewrite what we have there and substitute D. So 4 over D plus 1, 4 over D plus 1, but we know what D is. D is 7, so 7 plus 1. 4 over 7 plus 1, that is 8. So 4 over 8 is a half. Okay, so we know these gradients and we can actually find that angle L. Okay, I should have said angle L equals. Okay, now we can say, therefore, this means that to find these angles, let's just find them separately. So we'll find the angle of inclination of PL first. That's tan of theta is equal to our gradient. PL is 3. And now we can find that angle. The angle of inclination of PL is shift tan of 3. Okay, I'm not going to find the answer now. Leave it like this so that we can just use that as it is. And then we'll do the same thing for LR. So that is tan of theta is equal to, and it's 1 over 2. So that is theta of LR is equal to shift tan or arctan 1 over 2. Okay, now we can finally use this to find these. So remember how we said this is how we find the angle L. So we'll tell them angle L is finally found by saying, again, the angle of inclination of PL, which we now have as this. We're going to take that shift tan of 3 and you subtract that by shift tan 1 over 2. Okay, that way there's no rounding off or anything like that. So angle L is finally equal to, and we can just find the answer. And that, as you can see, gives us 45 degrees. So we know angle L. That is perfect. We know the angle L, and we're going to fill that in as well. So that is done with that question. Angle L is equal to 45 degrees. Done. Okay, moving on to the next question. Okay, so we're on 4.6, which says TR is a tangent to the circle at R, and we need to prove that PT is perpendicular to RT. Okay, so let's see what they're speaking about. Let's rather actually bring this diagram down because it's just going to be very helpful when it's down. Okay, so there's the diagram, and they already told us something about TR. Okay, so we're joining these points. So TR, they said, is a tangent. So we can use all tangent properties on that. TR is a tangent to R, and we need to prove that PT is perpendicular to RT. Okay, so that over there. Let's look at this. How do we prove to them that these are perpendicular? Okay, we can look at it in different ways. You can do it with shapes, like spotting a shape that would have a 90-degree angle here as well. So to do that, we'd actually have to connect something. So MR, we're going to just construct a radius here. If you construct a radius, it's something we should know about a radius. Okay, this is actually turning out to be not as bad. Seems to be, how many marks is this? It's 3 marks. Okay, so let's look at the steps that we can take here. If we can show them that this shape, right? We have this shape, and we can show them that it is either a square or a rectangle. That would prove that that is 90 degrees. Okay, so we can go that angle. How do we prove that something is a rectangle or a square? For you to do that, you need to first prove that it is a parallelogram. And to prove a shape is a parallelogram is really simple. You can either prove that all the sides or all 2 pairs of opposite sides are parallel, or you can prove that 2 pairs of opposite sides are equal. Okay, I see that we can actually take a different approach to making the lines all parallel. Here's the thing that we can actually see here. Do you see how we constructed MR, right? MR is a radius. However, there's some Euclid in here. You see that this is angle L, right? And angle L is supported by the line PR. However, at the center, we also have another angle, MPR, being supported by that same line, PR. So the angle at the center is always going to be twice the angle at the circumference, supported by the same chord or arc. So here, if this is 45 degrees, this is double that angle, so this would be 90 degrees. And that is going to actually be very helpful. If this is 90 degrees over here, and we can actually just tell them. So tell them that angle PMR is going to be equal to 90 degrees. If you like, you can tell them because of angle at center being equal to twice the angle at the circumference. So if that is the case, then you see that this is a quadrilateral. So all the angles need to add up to 360 degrees. So because of that, if you add all of these angles up together in this quad, so in quad PMRT, right, all the angles must add up to 90 degrees. We've got 90 degrees over there, adding with angle T. Okay, we can just call that angle T because there's no confusion there. Plus this angle over here, which is 90 degrees. Okay, so at this point, I noticed I didn't actually state that that was 90 degrees. We should. So that would have been before all of this. We should have already written that down. We should have told them that MR is perpendicular to TR. So MR is perpendicular to TR. Okay, then we're telling them that this is 90 degrees. And then if you add all the angles inside the triangle, so this angle 90, the T, this angle 90, and this extra angle 90 degrees, then they should add up to 360 degrees. We don't really need a reason. So it means that angle T plus 270 degrees is equal to 360 degrees. Therefore, angle T is equal to 360 minus 270, which is 90 degrees. And so that would prove that it is exactly 90 degrees. I think that's fine because that's three statements we're really making. We show them that these two are perpendicular. We show them that that angle is 90 degrees using what we already had there. And we have shown them now that that is. So that's 3 points, 3 statements that we've made. So therefore, it means that these two lines are perpendicular because angle T is 90 degrees. So we can tell them that it means PT is indeed perpendicular to RT. Okay, I'll just go with that because it seems fine. It's like 3 separate facts or statements, so things that we found. Okay, so that is it for analytical geometry, grade 12s. I'm sorry that I'm uploading these really slowly. I think in question 1 for paper 1, I did mention that I was going to be really busy this year. So I will try to get the remaining parts out, just edit them and upload them. And I will see you guys in trigonometry. Bye.